And okay. Hello, everyone. I'm not sure if you can see or hear me well. Let me know in comments if everything is great. And yeah, hello everyone on Global Summit for Node.js 2022 from Geekle. I'm so happy to start it again. Sorry about this background. We are the Ukrainian team, and none of us in Ukraine now, because you know why? Because of this war, we had to flee from our homes, but we still work on Geekle community. We're still trying to bring all these innovations together to find best use cases all over the world and bring to our streams. And today with us here, our brilliant community manager, Anna. Anna, could you please join me in this stream? Hello, Anna.
Hi, everybody. Hi, how are you
doing? Finally. I always say this finally when we start these events. Yeah, because we was working hard for several months to launch this event. How do you feel, Anna?
I'm feeling very excited, and really I'm feeling like great achievement to bring together all these awesome speakers. You even can't imagine who will we see and hear and listen to and get a lot of interesting stuff from them. So yeah, it was quite interesting to find them and to talk to all of them and to gather them together. So I hope all guys will enjoy it.
Me too. I'm sure. I'm sure because like almost all our events are like super cool. And thanks for your emotions. And tell me, please. Actually, I know, but tell us where you now.
I'm in India. I'm just traveling in different cities. Now I'm in Chennai,
India.
but actually in Hyderabad. So yeah.
Yeah, I'm in France. I'm in Nice, and please, people, let us know where you are now, where you're watching us from, and maybe I don't know, city, country, or room you are sitting now. And yeah, okay, Anna, give us more figures about this event. How did you manage to create, and how many speakers? What is the event about? Yeah, it's your time now.
Great, thank you. So we will have like more than 25 speakers here. All of them prepared amazing topics about their new updates, what they've done, and mostly we will have a lot of use cases because, when I was talking to them, I thought, Siri is Siri, but please give me something hot. Even if it was not that great, but you know that others shouldn't do the same, please let us know. We want to hear about that as well. So yeah, guys, you will have a lot of use cases. You will have almost like more than 25 speakers that will join us. And also we will be expecting to have more than 7,000 people that will come and watch and will enjoy.
Wow.
And hopefully will like this stream. Also, they will write us some comments, feedbacks. We really appreciate this.
Yeah, 25 hot topics, 5 hot speakers. Wow, that's amazing. As usually, like we do it on most of our events. Anyway, yeah, by the way, I really happy to mention now our partners, our friends, the company who supports us is Bright Security, who sponsored this event. People, thank you very much for this support, and thank you very much to everyone who paid at least $1 to support this project, so we can keep moving forward and develop this project and deliver more useful use cases, content, and all this stuff. By the way, we're expecting here for Paul. Paul, could you please jump in here? Yeah, here it is. Yeah. And so, yeah, give us more information about our sponsors and what they bring to us besides like sponsorship.
Yeah, so hi everyone. And I wanted to say thank you, as Ed already mentioned, to Bright Security Labs. And also, I wanted to add that we're going to have very cool, very awesome workshop from them. So if you are interested in unit testing, if you're interested in testing and security integration into your pipelines, make sure to look for the special email for the separate email that we will send out with registration to this workshop. And what's even cooler is that from Bright Security, you will receive 3 free of charge hours of testing. So I believe it's going to be 20 or 30 hours, and that's enough like for testing like a fully functional website or an application. So very cool, and thank you for supporting us, and thank you for the kind of bonus that everyone would receive.
Yeah, cool. Thank you for this intro. Yeah, and Anna, let's talk about event itself. How it is organized, what topics, what blocks, what days, how did you prepare everything? Let us know.
Yes, of course. Firstly, I want to say a huge thank you to our program committee members. Guys, you are amazing. Honestly, I don't know how you can handle me with all this, me, please, one more topic, please, one more topic, and, like, check this one. Really, I don't know how, but you are amazing. Thank you for that, and hope to see you at our next event, Node.js event. So I'll contact you later, of course. So about the event, we have 2 days of the event. Today, we have a day for junior developers. So everybody who knows just a little bit about Node.js can watch, can see us, and can note some interesting cases and information. So guys, if you have your colleagues who still don't know about our event, please just share this link, YouTube link, and they also can see, they also can watch us, and they also can find out something new. This is all. Also, tomorrow we will have day for senior developers. It's more deeper stuff with really hard topics and different use cases that were really hard to achieve, but they've done it. So yeah, you can check our agenda and find what might be interesting for you as well. So these 2 days. About blogs, we will have 5 blogs today and 4 blogs tomorrow. It really will be interesting. So just please take a look at the agenda, and I hope you will enjoy it.
Thank you very much for writing us these comments. Thanks for this great support. We really need it. Thanks for supporting us. Thanks for supporting Ukraine. Thanks for standing with us. Yeah, thank you very much. Anna, that's amazing. I think we have to just move to the first speakers and stop this chatting. Have we mentioned everything we have to, or what?
I think yes. If you forgot something, we will drop it on chat, or I'll come and announce it during the breaks or somewhere. So guys, you will see me a lot of times today, I promise. So this time we will leave this stage to our first moderator, who will moderate first 3 topics. And guys, don't forget to subscribe Geekle channel, so you will see updates about all upcoming events that we are planning to have, and we will have them. So, and also share, like, comment.
Yeah, fingers up, yeah. Thank you very much, Anna. Thanks to everyone who joined to this opening of this event. So yeah, I believe Nick will join right now and say something about the technical stuff or whatever. And okay, people, good luck with this event. We expect for great content. And thank you very much again. Bye.
Bye-bye.
Okay, hey everyone, Nick here. Like always, I will be on the backstage. So first of all, I want to mention that this live stream is going to be recorded. So don't worry, you'll be able to watch this later at the same place where you're watching it right now. Just get back here later and you'll find the recording. So don't worry about that. Second, I wanted to mention then, please behave, don't spam in the chat, and keep it only for discussion about the topics and also, of course, we'll expect lots of questions from you. Our speakers are there. The Q&A session just for them to answer your questions. And by the way, so we are starting our first block. And after this block, we will have an exclusive topic from our great sponsor, Bright. So this is going to be a topic about unit security testing. So definitely stay tuned for it. This is going to be the 4th talk today. And so the last thing I should say is that, that I'm going to introduce our first moderator, who is also going to be a speaker tomorrow for our senior track. So let's welcome Esther here. Hi, how are you doing?
Hi, Nick. Thank you for introducing me. I'm feeling great today, and it's quite
Great.
hot here, but I've bring drinks and food, so I think it will be a fun talk.
Okay, the stage is yours. Please introduce our first speaker for today.
Thank you, Nick. So, hello everybody. I'm glad to be here with you today for the Node.js Online Summit 2022. I'm broadcasting from Singapore here, and I hope you all are excited and in a pleasant and safe environment. And please contact our chat if you have any questions in the chat box, and prepare your questions because there are all speakers that will answer you, and we hope you don't hesitate to share your opinion about any talks. Now I would like to present you our first speaker, Korkan, who came today with the topic of bringing power to the IoT. Hello, Ik.
Hello. Thank you for a nice introduction, Esther. Hello, I'm Ege. I'm a research scientist at Siemens, and today I'll talk about bringing the power of web to the IoT, and more specifically, the Web of Things and the node-wot. I have joined here from the Munich, Germany, and thank you for also choosing me as the first speaker. I hope you'll have a nice summit for Node.js.
Yeah, thank you, Ik, for being the first speaker. I hope we will all get to learn about IoT. So, what was your last project about IoT?
So on IoT, the last project I had was to integrate some medical equipment actually from a manufacturer. Since there are a lot of companies who are trying to get into the on board with IoT, and they are sometimes lost with all the technology landscape. So with the Web of Things, we are helping some of them to do this in an interoperable and standardized way.
Okay, that's very cool, Ik. So we are very eager to hear about your talk. So the floor is now yours.
Thank you. All right. So welcome everyone once again. I'll get right into it since I already introduced the title. And I'll actually start with a YouTube video, and more specifically about its title. So if we look into this video, which is a rather popular one, we see this interesting pattern that the title has a very has a number that's very close to the view count. And of course, this person isn't doing this manually by hand, and is probably and rather certainly, if you watch the video, is using the YouTube API to watch the view counts and update the title accordingly. In a way, this is what we used to call web mashups. So now this term is a bit disappearing, but actually it's still very alive. We see web mashups in many different websites where they bring together different services together, right? So sometimes some payment, some map services for a hotel booking website, maybe some weather information for your trip, or there are lots of services analyzing Twitter feeds per region and giving some statistics, and so on and so forth. So thanks to the web, we are able to build such services or these compositions of services that are better than the sum of its parts. But my talk is about the IoT, right? So what is it, first of all, and why do I started talking about web in the first place? So in this talk, at least, we are looking at these devices that are communicating with some internet protocol in some network, maybe local or not, and something that is unusual for such devices that they are not big servers, they are not big computers, they could be very small or big, but they are not the conventional computers that we are used to. And we can communicate with such devices over the public internet, sometimes even without any security. Sometimes they are through some cloud platform, so they are basically bridged towards through a cloud platform. And so this is in a way one way to look at the IoT. And if we look at it from the Web of Things way, so the term Web of Things was coined maybe in 2007 or so. But at the time, it was just a proposal. They were saying, okay, how about modeling such devices as resources over the web? So if we have some sensors, let's like assign each of them a certain resource, and so on and so forth. So this was, in like more than 10 years ago. And this thing that was a proposal on the building REST APIs has become this whole standardization effort at the W3C about describing any kind of API for IoT devices using any protocol. Now, this is a rather big group that has now 4 deliverables, 93 participants, over 35 organizations, and even more actually if we consider the whole community around it. This is just the people who participate in the standardization efforts. And in the core of this, we have what we call a thing description. So a thing description is just an abstract description of network APIs of IoT devices. So these network APIs, we group them into these paradigms called property, action, and event. So properties are things like sensor values, actions are, let's say, brewing a coffee, turning a robot, and events are, as the name implies, are things like pressing a button or an event stream. There's also this possibility to add some other vocabularies or standards on top, so you're not constrained with what is specified in here. So you can basically add your own terms and so on in a standardized way and still be interoperable. And very importantly, also for this talk, is that it allows us to point to actual devices and their actual endpoints where we can like send them requests and get responses and interact with them in the end. But why am I talking about all of this? So, I mean, this is a Node.js summit, right? And I just started talking about standards. Well, actually, the TD standard is very worth mentioning because in the terms of programming, it allows us to build a certain abstraction layer. And in many ways, this is actually a design pattern that is very new and allows us to have this protocol agnostic programming, meaning that we are talking and interacting with such real-world devices, but it doesn't necessarily mean that we have to really understand and learn and program the way the protocols ask us to do it. Well, of course, the actual reason I'm here is that the reference implementation is in Node.js. So it's part of the Eclipse ThingWeb project. The library I'll talk about today is called node-wot. Node-wot is the reference implementation because it actually gave birth to different other implementations in different languages where they are inspired from node-wot in terms of the architecture, how to write such programs, and so on. Let's see some code. So first, I'll start with some simple stuff to show some small snippets, and then I'll show you some videos on how to write such programs, a bit the reasoning behind, and so on. So first, I'll show you how we can write the code of a thing. So let's say in this case, this is a temperature controller, but this can of course be a robot arm, a sprinkler for your garden, a conveyor belt in a factory, and so on. So what we see here are these 2 little blocks. So as you quickly see, there is nothing very complicated, and also we do not see anything about the protocols. What we are seeing here is just some two functions, and with these functions, we are basically setting these property handlers. So meaning that if somebody wants to read the temperature, let's go and read the temperature from the actual sensor in our on our hardware. So it could be even your CPU temperature, and return it to the one who asked it. In a similar way, we can also handle somebody asking us to increase temperature. And to do so, we'll, let's say, turn on a heater, so turn a switch on through an API layer. And after some time, we'll turn it off. So this is hopefully then going to increase the temperature. So as you see, it's quite straightforward. And we are just basically handling some data and not necessarily like programming in a, like to say that, oh, let's handle this HTTP request or something. But actually what happens in the background, so we can think of it as there's these 2 entities. So on the left-hand side, we have a temperature sensor or temperature controller, and on the right-hand side, we can have something that could be a browser, it could be a protocol client, something like Postman and so on. It could be just any application or a Node.js application, so anything. And what they do is that they simply send a request, and this first is met in the protocol layer of our device, and a Node.js library is basically interfacing with this protocol layer in order to get the request and give it to the node-wot script. And in this case, basically, all of this abstraction is handled by node-wot, such that in this example, when we see the code, we are just getting the actual request payload, but not all the header options and all these kind of things that might be necessary. Right. So of course, then you need to maybe interact with your hardware to really change the temperature and so on. But that is, of course, then could be done with some Node.js API. So on the opposite side, we can also have these consumers. That's what we also the entities that interact with a thing. Right. So the code is also rather simple. What we have is that we are consuming this thing description. So think of parsing a JSON, and then every 10 seconds we will read the temperature, and then if it is lower than 20 degrees, we will try to increase it. So this is basically just a logic to control our temperature in a way that we want it. And again, these are functions that actually send protocol requests, even though we are not seeing them in here. So again, if you want to look at what happens in the background, we have this time this device, but it can be with any library. So we are not constrained to using node-wot, since node-wot is not a framework. And of course, this will get a request at some point. And to do this, we first start by consuming this document. And so this is happening inside our node-wot script. And through the layers with a certain library in Node.js, we send the actual request through the protocol layer. So basically, all of these layers are abstract for you so that you can focus on the application logic, which is the actual critical part when we think of IoT applications where we want to really use these data or these devices in order to do something with them. We don't want to just collect them and so on, right? So how is this all possible? So I simplified a lot, but so first of all, we are able to simplify this thanks to the thing description. So the thing description is, as I mentioned, is a W3C recommendation, so a standard, and it's basically a JSON LD document. So the LD part means that we can link other vocabularies to it. And right, so this is published 2 years ago, and we are now working on a 1.1 version, which brings some new features and still stays backwards compatible. So if you look into the details a bit, so since we will be programming something a bit like this, so this is how a thing description looks at the top level, meaning the first hierarchy level in a JSON. So what we see on the left-hand side is some what we call the thing metadata. So these are just some human-readable text. So what you may put on a user interface or something like this. And we have some security metadata. This is generally explaining you what a consumer needs to provide as authentication in order to interact properly with the device. I will get into the interaction affordances, but like I mentioned, we have these properties, actions, and events. And lastly, we are also able to link to some other documents. So let's say you want to link to your documentation, you want to link maybe to your user interface, so that somebody who gets this document can navigate to those other interesting links, like you explore a website. Once we go deeper, so we are in the interaction level. So there we see these properties, actions, and events. And again, we are able to put some metadata for humans or for user interfaces. And then we can also describe exactly how the data looks like. So for this, we are using the JSON schema, and basically it allows us to tell you that it's a number or it's an object of this type, and so on. And this is basically describing what kind of inputs and outputs or requests and responses we need. And at last, with the green parts, we are going into the concrete protocol. And this is where it gets a bit messy, since protocols are generally a bit messy, and that's what we want to, in the end, abstract you from. And since we are talking about 3 concrete devices, we need to put concrete endpoints of the devices. And for this, we need to have some sort of a URI that is unique, so that's locating the resource. Like I said, we are modeling all the values of such devices as resources. And you can then say that, okay, this will be a JSON if you get it, and this will be a read property operation. So this, with this URL and this other information, you will be reading such a property. Oops. And so, and then of course, the last part where you see this like meta name and so on is what really links it to the concrete protocol, where you need to say, okay, you need to construct a GET request and so on. And so there you can go wild. So you can really put all types of header information and so on if this is needed. And that's where we have the whole protocol information and nowhere else. All right, so that was the first part, but the second part is, of course, node-wot. So what node-wot enables is the bigger part which enables us to program with this kind of design patterns. So node-wot is just a very simple library. You don't need to install a bunch of stuff. You just need to install the core component, which allows us to basically give the interfaces for what it means to have a read property. And you just then install some optional bindings. So these are different protocols that you can install, and you just simply include them in your Node.js application. You can also use our CLI. So the CLI gives you different deployment options and maybe some other types of configurations. And so it depends a bit on your use case. But in the end, it's just some dependencies that you need to include. Like I said, with the Web of Things, we are targeting any kind of network protocol. And in node-wot, you are able to use more conventional, let's say, internet protocols like HTTP, CoAP, MQTT, or some cloud protocols like Google Firestar. And we can also use some sort of WebSockets, but this time is for now only on the server side. And maybe more interestingly for some, and I'm guessing not many people have heard of these, but it is also possible to use some industrial automation protocols with node-wot, where the actual protocols are much more complicated than what we have in the internet. They are more unknown, they need more expertise. And with node-wot, we can actually abstract this for you, and you can basically use such complicated industrial automation protocols like you're just using some HTTP protocol. And what is even nice, we are not constrained to this. If you want to extend, which you can, you just simply need to implement the protocol interface, meaning you just need to define for my lovely protocol what means, what should I do for reading a property. So in the case of HTTP, we say that it's a GET, but for some other protocols, it's of course different. So basically, you just need to implement these, and it's pretty straightforward. Right, so with this, I'll start with some small programming videos. They are quite short to give you a rough idea. And I'll first start by the sting logic. So we will implement together this temperature controller. Right. So as you see, we have an empty package JSON and an empty script. And we, of course, then start by installing our dependencies. So in this case, the core. And then I go and install the HTTP binding, since we will do some things with the browser as well today. Right, after that, it's pretty simple, and we can just start including our library. And right, and then we need to configure the server, so that we need to say it's port 8080, for example. And then we start what is called a servient. So a servient is basically what we can add different servers and clients to. So we can put multiple protocols as well, or we can make something a server and a client at the same time. But in here, it's just a server. So for the demo purposes, I'll add a helpers class so that I can set the static IP address to localhost. Great, and then I add my server to the servient, and after that, we can start it. So what we did now is basically just configuration of this entity. So we need to specify what protocols we wanted to use. But after that, we are done with the protocols. So right now, what we will see is just writing what our device should do, and not worry about the protocols anymore. Right, so we start with our thing description. So we write first this produce command, and we start putting a TD. And here you see that we have first a title. We just put something we want, and we just say, okay, this has a temperature property. It's a Celsius. It's a number. Right, then we want to initialize this value, and here we are adding a read handler. So this is basically what will really respond with the property. So for now, we are just returning this initial value, 34. And actually, we are almost done. So then we just need to expose this over the network. And at this point, we are partly done. So with this, we have everything running. So I won't show the details here, but basically now we have a thing description reachable over the network and this property as well. So now once we click on the temperature, so it will open a new tab, and here we can actually just see the value, 34. Of course, we are not limited to using the browser or something. You can just simply use anything that can send an HTTP request. And here you see, yeah, we send it with the curl, get also 34. Not a big deal. Right, so now we will extend it with actions. So right now we will put an action into this thing description part, so this produce command. And we say that, okay, you can increase the temperature and you need to give something in seconds. So this time we are expecting a certain input from the consumer. Right, and then of course we need to add the handler. And then here we need to parse our input. So the reason we are doing this parsing stage with this value function is to enable us to use different payload formats. So we can actually get this data over JSON or XML or text, but we can still parse this and provide as a JavaScript type to the programmer. Right, and then what we're doing is simply mimicking what would happen in some real device. So of course, this is just happening in my laptop, but we are just mimicking, okay, if you are sending 20 as the input in 2 seconds, we will reach +2 degrees. Right, so I'll restart the thing, and as you can see, we still have the temperature, it's still available as a value. But now, if we are sending a post request, so that's what we see on the bottom right, we are able to now actually increase the temperature. So now as we get it again, as you see now, this is 35.2 since we have sent 12. So maybe it's a bit too small. Right, so basically like this, we are now interacting with this device over any kind of HTTP client, and we say, okay, I will read the temperature, I will increase it, I will reread it whenever I want, increase it whenever I want. So now on the program side, we will also introduce these events. So now we will add an event called overheat, and this will deliver a number. And for the demonstration purpose here, we are saying, okay, if we are exceeding 35 degrees, we are going to emit an event saying it's overheated and the current temperature. So I restarted my thing, and on the right-hand side, I will start my subscription. So this is just an HTTP long pause, so we're just basically waiting. What happens is that now in another console, I will send the actual temperature increase, and this will finish the subscription, and I will get the overheat event. Right, like this. Right, so that was actually it for programming an actual thing. And of course, this is just one way to do it very simply on our HTTP. And as I've said before, you can use the other protocols very easily. And now I will show the other side of things, so how it looks like for a consumer. So we have, oops, I will switch to the other slide. Yes, okay. So now we have programmed our thing, this temperature controller, and it's running. So now it is running, and I want to program a consumer. So as you see, of course, a consumer doesn't need an HTTP server. So for now, we're just taking the client part of the HTTP. And of course, then we are not adding a server this time, but now we are adding what is called a client factory, which basically allows to spawn these clients. And then we're ready. So again, we can just start programming. First, we go and fetch our thing description. So this thing description could be anywhere. It could be in the file system. You can just copy paste it in here. But in this case, we're fetching it from the actual device. And then once we do this, we can consume this so that we have this thing object available to us. Meaning that after this consumption step, we can do the actual code. So as you see here, now we are every second we are trying to read the property, parse it, and then log it, right? And so for now we will just do this. So we can actually now start our consumer. So as we said, it's just the temperature value and parsing it and logging it. Yeah, so on the right hand side, as you see, it's logging this every second. So it's working quite fine. And now we will add this other logic to control the temperature, meaning if it is below 35, I will try to increase the temperature by 1.2 degrees. Right, so to do so, yeah, we write this invoke action code, and we can then run it. And as you see now, we have been logging 35.2 since our interactions with the device have worked well. Right, and then lastly, we are adding this event. So this time we are simply just adding the subscription, and in case that there is an event delivered, we will log it, but then this time we will also exit the program to avoid anything else happening. Right, and we restarted our thing as well. So now we are ready to start the consumer. And as you see at the very bottom, the event has happened since I have also increased this by 1.2, and I have logged it, and I am done. So this was also a simple consumer application that we've programmed. So this is something you can program in 10-20 minutes, and it's quite straightforward. But actually, as you might have realized, these are simple applications, and that's generally not our goal, right? So this is just a simple library in the end. And I thus invite you to give Node.wot a try and let your imagination go wild what you can create with it. And also, even a star helps to support the development. So make sure to visit our GitHub page to be our stargazer. And also to give some more motivation, what happens with Node.wot. So that's what you see in some of the standardization events at the W3C. It was heavily used, and you can see that there are some DIY devices, some toy-like devices, some industrial devices on the left, even some vehicles that could be actually interacted with. Also, you can use it on the browser. So the code that you write also works in the browser. This is one of the beauties of Node.js, in my opinion. So this is just a demo website for you to use it. It's not the end product. And you can simply write these functions that we've seen inside the browser to interact with devices, in this case, HTTP and WebSockets only. You can also build desktop applications. So here what you see is an Electron application built on top of node-wot that allows us to parse these thing descriptions and automatically generate the user interface, and thus just with clicks allows us to interact with these devices other than writing code. Of course, that's not what you're limited to. Node-wot is meant for you to build something bigger with it. And with Node-wot, you can just build proxies, for example, so that you have some protocol and you translate it to another one. You can build dashboards. We also have some Node-RED nodes for you to use them in Node-RED and build dashboards with Node-RED, or you can, of course, build it in any way. You can build some simulators such that you mimic the network behavior so that people can interact with this over the network and more. So it's really up to you. And if you really want to learn more about all of this, so if you want to learn more about the standardization, so the Web of Things, I invite you to w3org/what. And if you want to learn more about node-wot, we have of course, our GitHub repository and also the website thingweb.io. Right, and with this, I am done. I will let this animation of node-wot evolving over the last 3-4 years, and I am open for questions.
Wow, that's so cool. So we can know that we can explore many things with IoT now with a simple library that we can use. So there are so many questions here from the participants. Let me ask the first questions. Since IoT stack and all are much powerful tools for AI, why don't we make use of them more than we currently do? So what do you think about that?
What stack? IoT stack?
Yeah.
Oh, that's a quite good question. So, so yes, I agree. So, with thanks to the IoT stack, we are actually allow us to reach the data from such devices in a much easier way. But for being able to have such generic AIs, either you have to use a certain so framework or product that all puts all these data into the same format so that you can like properly use your algorithms on top, or if you are basically lost with this integration hell and you need to talk with all these different devices and understand them. So in that case, the Web of Things actually really helps. And what is really nice is that you are not losing any of the semantics. So all of the very device-specific or domain-specific information is never lost, and it is still kept in there. So we are not transforming any of the semantics. So we are not losing that. So you can build intelligent solutions on top of it.
So have you ever experienced adding some intelligence to the devices maybe?
So at home, I actually am using it also for my little garden in the balcony, and so I automated with some weather prediction and like water some stuff. But it's just my hobby. But at the same time, yeah. So node-wot is something also that we use in Siemens for some small projects, or what we do sometimes on more browser side projects. And in the end, adding an intelligence to the device is also a bit, let's say, subjective. So for me, devices can also be not intelligent, but we can build more intelligent stuff on top of them. So that means we can be more flexible and so on. So each time you push something towards the device, you become less flexible. And if you have something outside of the device, you are much more flexible and don't worry about firmware and this kind of like problems.
Okay, continuing from the last question, there's also a question about how do we apply the maybe node-wot or IoT itself in the areas of biomedical engineering.
That's a good question. So in the end, so the general trend I'm seeing is that no matter the domain, people are trying to connect these somewhat rather old machines sometimes to the internet. So what I've seen so far is that always we have some sort of a funny network setup where that people use a certain protocol that is only working for that case. But with the IoT, we are really pushing towards using these devices as normal internet services. So of course, biomedical devices, they are also sometimes very old, so they need they cannot be just replaced all the time. They are very expensive. So I would say that for anything that needs this IoT integration, you can simply describe these with the thing descriptions and just integrate them to a more modern stack. So that's a bit the beauty of it. So we are not losing any of the $1 million devices that people need to buy for these applications. You don't need to keep changing them once a new stack just pops up. You just keep those devices you have and you just integrate them to your new solutions. So biomedical engineering is, I think, a good example. So it's one of the domains where the devices are expensive and don't change super often.
Yeah, especially in the pandemic, the last pandemic in 2 years, we need more devices with practical capabilities.
Yes.
Also, another question is like this question has two parts. For the first part, is my understanding correct that the node-wot is supposed to abstract communication between services which manage the sensor hardware? Is it correct like that?
Exactly. In one way, yes. So the hardware is already abstracted since you are communicating over the network, and what is happening in the hardware you don't need to care anymore. So this is correct that this is already abstracted. Yeah.
Okay, and continuing the question is, but this lib does not allow us to talk to the sensor hardware itself, and we should also use something like Johnny 5.
No, so the so this is important to distinguish that node-wot isn't meant to interface with the actual hardware inside your board. So Johnny 5 is a good example, is a Node.js library that allows us to access these the embedded sensors over some serial protocols, and it is some sort of a framework. I think I used 4 years ago. So ideally, you would use node-wot in conjunction with something like Johnny 5 or your I2C protocol library, so that once you get a request to, let's say, read a temperature, you then transfer this with the proper Johnny 5 or whatever API you have on the hardware to the actual sensor and get the value back. So we are not mixing us into the actual hardware communication, and we will never do this. So that's a clear separation. So you should use it together.
Yeah, thank you for your response. I think it's quite clear. So another question is whether every IoT device that use node-wot has to be able to run Node.js.
So if you want to program these thing applications I mentioned, yes, it has to be able to run Node.js, which is not always the case, I know. However, if you have a device that already has this network interface, you can just use node-wot on this consumer side, so on this client side. So a good example is Philips Hue. I have no affiliation with Philips, nor do they participate in the standardization, but we are still able to write thing descriptions for Philips Hue devices and communicate with them using node-wot.
Okay, that's cool. And then, wow, the participant is like quite. He saw that there's ESP32 in the photo. So, can I run the node-wot on non-JavaScript devices?
No, but a bit like the last question. So in that case, the ESP32 is using MicroPython, and you have basically this MicroPython stack allowing us to interface with the hardware, and it has I think that one was an MQTT thing. And then basically with node-wot, we are able to talk with it from, let's say, a computer and send the requests. So in that case, we don't need to know anything about MQTT. We just use the MQTT binding of node-wot to talk with MicroPython MQTT thing on ESP32.
Okay, cool. So another question is, yeah, we have quite a lot. Can
That's
we
nice.
use node-wot with SCADA?
SCADA, so as the for the wait, I need to remember. This is sensor acquisition. This is this industrial user interfaces, I guess, or I don't know what kind of platform they run on generally, but I personally haven't tried it.
Yeah, maybe, yes, I don't know who asked this question. Maybe you can ask or give more explanation about SCADA, maybe. So, yeah. So, yeah, I think
So
it's
I am also in the chat,
yeah.
so I'm in the YouTube chat. So if you want to give more information on what you meant with this question, I'm here for the next couple hours.
Yeah, yeah. Also, it will be the next moderator to.
Yeah.
Yeah. So thank you very much, Ik, and I think it's very great to learn about IoT. This is a very brightening first session, and I think you have very much experience in Siemens directly to the IoT. So the talk is very well according to your experience, and we got a lot of insights. So thank you, Ik.
Thank you.
And we will now move on to the next speaker, which is Mr. Afreen.
Hi.
Afreen?
Yeah, I'm sharing my slides.
Okay. And please turn on your camera too so we can see you.
Yeah, just a second. Thanks.
Yeah. So we are very happy to have Miss Afreen here. And she is an also experienced programmer, a software engineer at Red Hat. And she has 3 years of experience working in JavaScript ecosystem with different libraries, and also Node.js and React. So she's very experienced, and also she will talk today about what is new in the Node.js 8 version. So hi, Afreen.
Hi. Hi,
Yeah.
Esther. Thank you. Thank you for the pleasant welcome.
Where are you
First,
now?
I am based in India at a city called Lucknow. And yep, and that's about me.
Okay, so woman in IT rocks, yeah. Nice to have a second inspiring speaker with experience in Red Hat, and I will add your presentation to the screen. And now the time is yours.
Thank you. Thank you. So, hello everyone, this is me, Afreen, and today I'll be talking about V8. We as a programmer code a lot in Node.js and JavaScript, so I think it would be nice to have a conversation about V8 and the internal working, like how this all compiles and actually generated as a bytecode and then executed on your respective machines and in your browser. And what's happening behind. So I think that's the whole story. I will try to make it not very much difficult or overwhelming because there are a lot of internal keywords, or you say some buzzwords around there, and I'll try to keep it as simple and easy as possible. And please ask questions if you find anything uh, anything that is not just right. Okay, so we can start then. A little bit about me. I worked as a software engineer at Red Hat, and 2 days back I have resigned, so I'm now working as a freelancer. And I have experiences in the cloud storage technologies, and particularly on the QX and design of the cloud storage consoles. And in doing that, I have come across the JavaScript and the entire ecosystem of its libraries and whatever it has, Node.js, React, TypeScript, and Babel, and everything else. And as well as with V8, I came interact. So I will share my story, like I was just like a JavaScript developer like you, and I just writing some fancy and idiomatic code, and it was very pleasant, and I was very fascinating because we all know that JavaScript is not sort of a language like other languages are, like in the sense like C or C++ or any other like the niche programming languages we had, and it has some of its own nuances, which is very much like as you discover it and you work it more on it and you discover it and you find it very fascinating and at some time frustrating. So I was that kind of developer. Then I was just curious and wondering like how all these JavaScript has is processed. Like for C and C++ and all the other languages, Golang, we have a certain mechanism that it has a compiler, it has a processor and something. The JavaScript runs on browser, it also runs in the Node.js environment. So all of these kind of things were like with creating a curiosity in my head that what was that behind it, and that's the whole story of this talk. I will walk you through my journey, like how I like found out and how what's behind that and everything that worked it. So let's begin. So once I started looking into the JavaScript, I came across this term V8, which is the JavaScript runtime engine, and it powers Chrome web browser. And then Rand took it some years back to put it into the Node.js and provide it as a backend language. But then comes like we all hear that JavaScript is an interpreted language. It is an interpreted language, and most of the places still you see blogs and everywhere it was there, and I was confused because I will talk you through the other phases of the slides and everything, like what is it? Some part of it's are compiled as well. You hear often that okay, it's compiled and and in this term and that term. So it was very confusing to understand what is V8 in actual. So that and so digging down into that thing, we found that okay, just to summarize a JavaScript is you can tell it's an execution engine. It's a JavaScript execution engine. Obviously it's also a compiler and it's also an interpreter. It's a combination of it, but overall all these terms refers to the same thing, that it's an execution engine. You run your JavaScript inside it. So various terms are used to reference it, and for any programming language it's an implementation decision that whether you want the language to be compiled or interpreted, and it's based on the engine that is running that. So it's completely an implementation decision still. What is V8? And V8 we will figure out like how the compilation process or the crunching of JavaScript code happens along the way, and how it like processes it and does everything at each and every phase. But overall, a very high level view, it's an execution engine like you find in, yeah. And on JavaScript, like if somebody asks you like it's an interpreter compiled, so you can say that now, that it's an implementation deep level detail what a language comes with. And okay, so let's begin with the main part or the meat of it, like what is the anatomy of a V8 compilation process. And V8 is the runtime engine, and it has certain parts like any compiler phases. Like we have a certain basic compiler phases that we have all learned in the back in our schools and everything, that it has a parser, it has a lexical analyzer, a scanner, or you say, and then you get an abstract syntax tree, the semantic analysis phase, and then you go through all the way down to the optimization phases, and then ultimately releasing the bytecode or the executable code, which is the process. So the parsing process has at the very high level is this, and the same goes for the V8 as well. It's not anything that's new happening here, but it's the same thing. But you will find some fancy names here, which I will try to explain in the coming up slides. But in the nutshell, it's that thing only. So you have a parser, you give the JavaScript source code, which actually analyzes at the first phase. You can think of that lexical analysis and scanning, and which is finding and the keywords and identifiers, like the syntax errors that you get, like what is that the syntax is correct or not, and all these initial things. Then there is a fancy term which is the interpreter ignition, which is akin to V8 itself, which is a very I say that a very highly optimized interpreter of V8, which actually generates the initial bytecode, and then that bytecode is basically fed to the compiler turbofan as an input you can think of, and then it finally generates the optimized machine code. So the bytecode that is generated is basically unoptimized, you will say, because an interpreter is a fast guy, and it just gives you the output at front, the right away you ask like what's the input, and you type it and it gives you an output. So it's fast, but at the same time it doesn't optimize in doing so because it has to focus on one thing. So we have all the trade-offs there. That interpreter is there, and it has to give you the output as fast, so it doesn't optimize this. But we don't leave it that there, and V8 doesn't leave it that there, and that's why you hear the terms like V8 is the fastest, and it's so fast, and you also see the results and metrics with respect to that. So the basic thing is that the compiler turbofan is basically that which optimizes it very like in an intelligent fashion, taking some very intelligent decisions at the moment of the time of compilation, and it tries to optimize it in a way that it can run fast in your browser or in your Node.js REPL environment, wherever you're trying to run it. So that's the high level overview of what we are going to cover today in this talk. So I'll move to the next slide. Okay, so before we go ahead with all of this, like there is the ECMAScript role. I know it's that nasty one. ECMAScript comes everywhere, and it's sometimes I see that people find it very hard to identify like ECMAScript, JavaScript, all that things. I might be sounding funny for some of those who already know, but just for the sake and simplicity of this talk, I'm trying to iterate on that a bit. That every compiler or every translator that you make today in any language, it will convert a language A to language B. So it has to understand both the languages spec, because it's converting from one spec to another. Think of it in that matter that you are a translator from English to Japanese or English to Hindi. So you need to have a solid understanding of what's the correct grammar in English and what's the correct grammar in the Hindi. So both of these things, if a translator knows, then only it can do justice to the translation process and to the translation of the language and the objective that we are trying to achieve. The same goes with the compilers or translators or interpreters that we call the V8 engine that is there. So it takes the spec of JavaScript, which is the ECMAScript. So it's a standardization of JavaScript, which is handled by an organization which is ECMA International, and the spec is called the ECMAScript. And yes, and you often heard in certain I think blogs or videos, you see that okay, there is a new standard ES6, ES8, ES5, and all these. So these are basically the new features that are getting added to the language, and the spec for that is given by ECMAScript. So V8 follows that, and the role of ECMAScript is very basic, and you can also write your own translator on that terms if you just need to follow the ECMAScript translator and everything. That's it. So that's with the ECMAScript, and V8 follows that. And now let's jump to the first phase, which is the parser that we have seen. So the parser, what it does is that it takes, like when you type Node.js index.js, you're giving a file, and then it goes through the file. There is all that, it's going it line by line, doing all the lexical analysis, and then it breaks the code into the tokens to identify what does that means, and then these tokens make up the abstract syntax tree. So I think it's too much verbose right now at this point of time, so let's jump into some of the basics. So lexical analysis is very akin to any compilation process for any programming language. So it's just the first phase for any compiler. So you just scanning, just like this, you scanning or you scroll through Instagram photos, and a similar fashion, your compiler also scans through it, and it converts your high-level input program into a sequence of all tokens. So let's say if I have an input like if x is greater than 3, and like that, so it will the compiler it will break down into the most identifiable, meaningful terms. And by that I mean, like, if in English right now you are reading that global summit for Node.js on your screen, so your brain is deciphering global as a separate word, summit as a separate word, and you are deciphering the space between global and summit, that okay, these are the two separate words, and not that the global summit is that one word. So your brain is deciphering in that manner, and you're not experiencing that because it's obviously subconsciously, but exactly that the way you are seeing it right now, the compiler also wants to or should need to know all of these things in that manner. So we have the if statement. So it analyzes, okay, if is a keyword, and then there is a punctuator, that is the bracket, and then it identifies, okay, it's an identifiers, and it's the name of variable or something. So I need to keep it as an under identifier, and that's the same way. So if I go back to that example of global summit for Node.js, so you identify it's global, it's certain noun, summit, it's certain noun, for preposition or something, that sort of thing is there. So in that manner as well, the compiler is trying to analyze what you have input in your code and trying to identify and make some sense out of it. So the first phase is like, it's breaking each of these elements into certain tokens, identifiers, operators, numbers, and once it's done with that, then we go to the next phase. So first phase is identifying each or making sense out of it, what we have written in our code, which is basically identifying and putting them into certain buckets, keywords, bracket, identifier. So a lexical token, basically a sequence of characters that can be treated as a unit in the grammar of the programming languages. So all these programming languages also have a grammar, so it's just akin to that. And now at this point of time, it will tally the ECMAScript specification as well, that what are the keywords that are listed there and what are there, and so I can find it out. So yeah, so that's with the lexical analysis and tokens. Now the abstract syntax tree. So this is very interesting part right now, and we don't realize that we do it very often. Like when you read a paper or you read any article, you are identifying and you are making sense of the language principles that you have learned. So let's take, for example, we all are at Global Summit and we all know English, and we know the grammar, the preposition, the 7 parts of speech and everything. And at the point of time when we are reading and we are trying to decipher in the meaning of the sentences or the whatever the post that is written, we are trying to decipher that, okay, that's a noun, that's a preposition, and now it's making a complete sense. But for a compiler, think just for a moment like how it would see your code. You know that it's an if else body, but it needs to understand that and put that if under the section of if body and have to actually make some sense out of it. Now this is the semantic analysis of the compilation phase, and it's a very important and it's very you say complex at times it gets. But the thing is that the way that generally all compilers do is constructing an abstract syntax tree out there, which is just an abstract structure of the program source code, and it's just like in high level, okay, there is a condition, there is an operator, there is a while loop, there is a recursion, there is a function call. So all these items, and it can grow up very large at times, and it can also be like get very complicated. So there are techniques for optimizing the abstract trees as well, and how you construct the abstract tree as well. And at this stage itself, if you see a syntax error like right in front of any the code you ran in your computer right now, so what it will say is like if there is any syntax error, it throws out. It's that phase after which it analyzes that, okay, there is some word which is not fitting into the syntax of the language that it's providing, and it's not fitting anywhere, so it says, okay, there is a syntax error. Just like that, if you see very often, I think it's a very common I think error that we get often around that. So that's it. You get the syntax error for that. So that's with the parsing. So you have got the parser, and you have constructed the abstract syntax tree out, and it's all that V8 is doing. It's all that the V8 is having that, and it's doing that, and it's till right now there is nothing special, I would say, or very like different than other languages, and it's very similar, and you can relate it to that. But now comes the very interesting part, which is that the ASTs are now used to generate the actual bytecode, or what you call the machine code. Now, bytecode here is very crucial here, and it's an unoptimized bytecode that I told you previously, and it's not that it's completely that you can run it or do something, but it's just an intermediary, you can say, code or the language that is generated right now, and it is going to create this one. And I will show you also the glimpse of it, like how the bytecode looks like, and how it's created. But before that, there is also one important term that V8 has done, like recently, or not recently, I would say, but from the previous architecture, there was a very from the initial architecture, you would say, that from which the Node.js was like created, there was a shift, and there was different components like crankshaft or things like that you might have heard. And now, which is the latest architecture, which was I think changed in around 2010, I'm not sure, but something around that lines it changed. Now the architecture, and it has the ignition and the turbofan engine, and with that there's come the just-in-time compilation. So we have heard that compilation is basically that you give the source code, and it went through all the lines and everything out the code, and it gives you an output and an object file, which is completely like the ahead of time compilation, and you just have everything else. But just in time compilation is like you give the code right there, and it gets compiled right there, just to put it in that simple way. So it combines the best features of interpreters and compilers, making translation and both execution faster. So you see that the execution is faster, but again the optimization is not that we are achieving it, and the code is not running that fast, so we have that problem. So it's both of things, that translation and execution is faster. Now the interpreter executes the code line by line, and the compiled code is additionally optimized and re-optimized dynamically at runtime with the just-in-time compilation. So this is the basically thing that with the just-in-time compilation. And also that there are certain techniques that V8 in the Chrome browser, if I know it's Node.js, so I would not shift to, but just for a fact that in the compilation process in the browser, the V8 has a different threads, like in the main threads and in the background threads, it moves certain of these compilation processes, switches back and forth there, so as to just run. So yeah, that's there. Now, finally, we have to go through the ignition engine. So the V8 ignition engine actually generates the intermediate code, which is the bytecode from the syntax tree. And ignition is basically a fast, low register-based interpreter, because interpreter which can be created in certain fashions. It's basically a low-level register-based interpreter, and written using the backend of turbofan. And I have taken this text from the talks of the V8, so that's why you see it's a very textual and verbose. So the ignition interpreter works through the AST and creates the unoptimized bytecode. And after we get the bytecode, the generated AST will be deleted just to save the memory. And when the bytecode runs, the information about the running code will be collected. So why this information is collected? So it can be passed to the turbofan compiler, which that actually optimizes it and then saves the information for future optimization. So there are instances where you have this one function A, that is function for anything that is running for once, so it's not needed. But let's say there is a function that is running over and over again at a lot of times. So it can basically, again, if you are a React developer, you have heard of memoization or something, so it can just like think of that in that terms. I'm talking in a very high level terms. So like it can memorize that and use it for future optimization. So it's just that. So ignition engine is basically the interpreter engine, which is basically for functions that are going to execute it once or twice. But your turbofan is something which is going to be running for functions which are going to be executed more than once, surely. So that's it that's through the ignition engine basically that does. So it's an interpreter. You have got the abstract syntax tree. You pass to the ignition engine, and it gives you the bytecode, which is basically not optimized right now, and we will go through that. So this is basically the high level diagram. You can see that you have a JavaScript source file and you have parsed it. You have created an abstract syntax tree. Actually, V8 has created it, and then you have compiled it, and you have got the ignition bytecode there. So here the ignition bytecode there, and you can see that these are basically not very much not understandable, which is expected. It's not for you; it's for the turbofan, so it basically understands it much better. But if you see that it's if you go through, it's basically those operations. It because it's a register based interpreter, it's having certain address like fetch operation, store operation, and then adding all those things and all these machine type of instructions. So think of bytecode as like a small building blocks that make up any JavaScript functionality when composed together. So V8 has several hundred bytecodes. So, and these bytecodes for operators are like add or typo for property like LDA name property. So V8 also had some pretty specific bytecode like create object literal or suspend generator. So there is actually a file called bytecodes.h in the V8 in the list of like in the V8 code base. You can look into that and check out like what are the bytecodes for uh, each of those like operators and types. Okay, so now we have gone through all the way through the ignition engine to finally come across and go through that whatever we have typed out in our REPL node index.txt file, and now the turbofan is going to convert this bytecode into a very highly optimized machine code that can run on our system and our browsers and everywhere else. So this is basically the job of turbofan, just to optimize and do the things that normally the ignition interpreter cannot do for us. And it displays that you can see that it gets the constant like you what you say the performance impacts is the and you hear about V8 that okay it's really fast, it compiles it really in 30 milliseconds, and that's also so this is a phase that it basically does the magic. And now if we connect all the dots here, because V8 is not just taking JavaScript code but also the WebAssembly code. So just leave off that part, but just focus on the JavaScript code where it is written. And there are some very like decoder and scanner, which is basically I did not talk in sense, but I talk as a whole as a parser. But I did explain that okay, there is a scanner and token that you can expect, and that phase that should be there. And there are also pre-parsers, which is basically making the job of the parser a little bit easier by linking and coding. So you have a dependencies there, you're linking the libraries, you're pulling the code and all of that stuff. So it just loading the modules and everything. So it's just sort of those things, linking and loading it that it does. So that's basically there. And then from the parser you get your beautiful AST abstract syntax tree, and then it goes to ignition interpreter, and you optimize, you send it for optimization obviously. And then you also have collected some profile data, which I've told that while interpreting it collects all the data which is there, and it also deletes the AST which was there in the memory back then. And then you convert it to the turbofan to convert into the optimized machine code, and there you get your actual JavaScript running on your environment or on your machine, which is over there in a certain machine, a specific machine on which you are running your command or Node.js environment. So that's it basically with the V8. It's a very simple architecture. I would say it's very difficult, or that part of it, if you see in the other languages, which is like Java, comparing with which is having virtual machines and all that sort of concept. But also at the same time, it makes it very powerful as well, and it's very interesting to study and find out that okay, how this happens. So when the next time you type in your code on the REPL or somewhere, you would have a decent amount of understanding, like how it works and whatever it's there. So that's basically there. So I hope you have like it, and I hope it makes some sense now. That's all. Thank you.
Thank you, Afreen. Wow, I learned all about how it's inside the Node.js 8 version. So I think there are a lot of information that I didn't know before. So it was a very interesting story that you told us about what is inside the Node.js 8 version. So for all the participants, please feel free to ask questions and we will answer them to Afreen. So what was your last project in your work that you have been working on with Node.js?
Okay, in Node.js, what was my last project? It's a front-end application, I would say, that we have. Actually, it's a micro front-end application which we have installed for OpenShift, and yeah, I think that was basically leveraging the Webpack framework as well with the micro front ends, whatever it's there, and we have a Node.js backend server that is just pushing things then and there. That's it. Yeah, that was my last project. I recall.
Okay, here's a question from the participants. How set timeout runs in Node.js version 8? As set timeout is a web timer API, it's not a part of JavaScript.
Okay, so set timeout runs in Node.js version Node.js V8 as set timeout is a web timer API. So I don't have answer to this right now, but I can check and let you know later, because I have used not. I'm not sure about the internals basically, and I think I won't do justice if I speak anything right now.
Chat also with the participants. And is it possible to revert from the bytecode to the original JavaScript source code?
It's possible to revert from the bytecode to the original JavaScript source code. Well, there are some de-optimization, like you can you have an optimized code and then you go from de-optimized code, like back to the bytecode from that. There are certain commands, but I'm not sure like if you could go from the bytecode to the original JavaScript code. Uh, but there may be certainly some places where you could do that, and I would like to know why would you like to do that. But anyways, if you have for debugging or some sort of that thing, I'm not sure that you could do that, but probably I think I would rather check it. It's a good question.
Okay. How about uh, more explanation about the provider data and why we have to de-optimize error from the turbofan generated bytecode?
Yeah, good question. So the de-optimize arrow is basically because I say that the profiler data is getting collected, and as soon as it collected, so the just-in-time compilation that is working is basically optimizing and de-optimizing. So if it found that certain thing that it memorized, like let's say for a certain function foo at that point of time, and now it's not right, so it will de-optimize it and go forward with the next implementation, and whatever the selective implementation that it chooses at that time, the turbofan, it will go with that which is best at that time for the code. So it's basically it's that's why I told when in the just in time compilation that it's basically always it's a dynamic compilation, so it's always going back and forth, back and forth, and that's how you get this speed. So as if some memory is getting consumed a lot in that sense, like if you have heard that you have a packed arrays and the holy arrays, and if certainly you have added, you have a packed array and then you created a hole in an array, so certainly that changes the whole algorithm and everything around that, so it is constantly dynamically optimizing and de-optimizing in that fashion.
Wow. And could you please also explain about the de-optimized part on the connecting the dots slide?
Yeah, I think I have explained right now that the optimization part, basically what's there, and it does. It's basically, just think of it in a dynamic fashion. Like you're saying that you're going with an algorithm, you are finding, because it's the thing with optimization is that there can be n number of things in compilers, and basically in every compiler the semantic phase, the lexical analysis phase remains almost this, you can say, in a certain blocks or levels, but the optimization phase in each and every programming language compilers keeps on changing, because this can be anything. And the V8, what V8 team does that it's very that intelligently, that they, because when, again, I think I'll go a little bit deep, so keep with me. So that the thing is that with compilation you also have optimization, so you have certain optimization techniques. Okay, so if I saw that, okay, there is a variable that is used there, a plus b, and if I could, I already have, like, you have used a syntax like a shorthand syntax like a plus equals to b, and then you can convert and optimize it and write exactly the register and the variable and load functions there. So it's basically a good optimization there. So all the way right thinking in that terms, so it will also create a lot of memory space for you. So it's always a challenge for compilers to have a lot of not consume a lot of memory, and in the sense like, and also run faster. So there's always trade-offs, and the way V8 has split it is with the ignition engine and the turbofan, which are dynamically converting it and using all these techniques like just-in-time compiler and everything in that fashion. So it's optimizing and then de-optimizing, and it's taking it's going through one of the rules. Okay, I have optimized it now, it's done. It's a machine, so it cannot take itself a selective decision, so it has to have certain rules. If a function is executing a lot of time, then it has actually needs to optimize it and save it. But let's say that function is just used once, though it generally doesn't make sense, so it would de-optimize and do that. So that's basically there. But obviously you can read more about this in the V8 docs, which actually have a good, very very good metrics. If you search in the Google the V8 docs, it will come it with that. And I understand that I cannot do more justice with de-optimize at this point of time right now, but you, if you are very much interested, you can go and read the docs. And I think my talk and my all the experiences are very much inspired by that blog, because that covers a lot of good information and with various good metrics, which was written by the Google devs itself. So you get a much better understanding like how all these works and back and forth. And at this point that we are talking in the browser, it's in the Node.js environment, but in the browser they also switch between main thread and move certain processes to background threads as well. So which was very interesting if you go and check that out.
Oh, one of the participants as well. It's very insightful. How did you get into learning all this?
Yeah, so I think that was the story hall started. So I started with my journey started with my internship with a different company, and it's also a cloud-based company, but they have front end. They have to test their product for the front end like React and everything. So I used to test the product for them and how it worked for the React library and the whole thing. And then I think it started from React to JavaScript, understanding JavaScript. And once I understood JavaScript, like you always have heard like prototypal inheritance and all that crazy stuff. So then it gets, and by the time I think Node.js hype is on as very much. So I took the initiative to get into the Node.js and try to, and the first thing that we heard in Node.js is V8. So I dig into the V8 and right into the V8 docs, and that's how I learned all of this.
Oh, it's a very cool thing about learning all the details and inspiring us to know actually what actually happens, yeah, behind the scenes. Yeah. So, is it fair to say that the result to run both be a union of the optimized and non-optimized code? Moving on from the previous question.
Mhm. Result would be a union of the optimized code and optimized code. I think there is a difference in the terms. If we say union, there is like optimized code is also there and non-optimized code is also there. I'm sorry, I'm very picky with these things, but yeah, but I understand your question that at the sum of the result that we get is that it's some optimized and some non-optimized code. So yeah, I think that's what happens. like non-optimized code is what, like the code is not optimized. It goes through all the parts of your code and it optimizes certain parts of your code, and whatever it has like optimized it previously, like it optimized it previously and it found that okay, there is some better thing, then it replaces it with that thing. So it's just that way.
Yeah, cool. So the last question is, does the JS engine of other browsers such as Firefox and Safari work similar with the V8 engine?
Yeah, very much similarity. You would find it out. I have not checked out those browsers like Spider Monkey and all that, but I have heard that in the community, which we can say is like the word of mouth, that they work all pretty much same. That's why you have, just because see, that goes to the back to the ECMAScript slide that I showed you, that all browsers follow the ECMAScript slide. So you get a benchmark basically, like with any, I think you get with any programming language or anything as well. Like Go, there is Golang, JavaScript, and you have those shiny matrices and blocks saying that okay, this runs at this milliseconds and this runs this milliseconds, and that way. So it's the internal thing that can take some times on, and it's the optimization phase that you will find very different in all of the compilers. But all the things up to the semantic phase and following the ECMAScript international and generating the machine code, and all these phases are very much similar. But the optimization phase you will find in each of these engines very different.
Okay. Yeah, thank you very much for sharing with us about how the V8 engine works. So I think there are still a lot of questions, and you can ask Afreen later in her social media or through the YouTube chat, right? So you will be staying with us, Afreen, right?
Yeah, thank you.
Okay, thank you very much. And now there will be an announcement first before we move on to the last speaker from this block. So please
Hi,
play
everyone. Now we want to say a huge thank you to our platinum sponsors, Bright Security Labs, for supporting us and also for giving us the opportunity to share with you some free scanning hours on their platform. Now we will post a link in the chat, and be sure to go register and grab yourself free hours of scanning. And yeah, also look for announcement about a very practical hands-on workshop that we will have on 9th of June. So be sure to check it out when we have the announcement and register for that workshop, and have a great Node.js Summit.
Thanks, Paul. So that's a great opportunity. You all wouldn't want to miss the opportunity. So please join the workshop. And now for our third speaker in this block, which is Luciano Mammino, will present about finding a lost song with Node.js and async iterators. He is a senior architect at 4Theorem, and I think we will get a lot of knowledge from him because he is a very experienced programmer. He coded from the age of 12, and he is also the co-author of Node.js design patterns and other technologies. And without further ado, we will listen to the talk by Luciano.
Everyone, and thank you for joining this talk. Before getting started, let me tell you that the slides for this talk are already available online, and I'm going to be showing you a bunch of code examples, so that's why I like to share the slides before you can go and check them out later. So just grab a screenshot or scan the QR code. I'll give you also the link later. So here is a little story for you. Some time ago, I was having a random song in my head. I don't know if that ever happens to you. And basically, it didn't matter what I was doing all day, this song was coming back to my head. And the only thing that I wanted to do was basically listen to that song. But there was a little problem with it. I couldn't remember the title or the author of the song. So how could I remember that song? There must be a way to remember, right? And today I'm going to tell you a little bit more about this story and how I solved this problem using a bunch of interesting technologies. Last.fm and its own API, Node.js, and async iterators. And hopefully by the end of this talk, we would have learned a few new interesting things about Node.js and async iterators. But let me introduce myself first. My name is Luciano, and I am a senior architect at 4Theorem. I work in Dublin, Ireland. I'm also a Microsoft MVP and an AWS certified solution architect professional. I am the co-author of this book, Node.js Design Patterns, And you can find me online in pretty much everywhere, LinkedIn, Twitter, my own blog. So feel free to connect. I'd love to chat with you later. Very quickly about Fortheorem, we are a consulting company mostly focused on AWS. We have been helping a bunch of small and big customers to migrate to AWS or to optimize their own workloads on AWS. If this is something interesting for you, let me know and let's connect. Also, we are hiring, so another reason to connect. So don't hesitate to reach out if you're interested in something like that. Okay, back to the story. There was this song in my head and I didn't really know what to do. I could only remember the word dark, which was probably in the title. So the first thing that I did, I went on Spotify and searched for the keyword dark. So that turned out not to be very helpful because, funny enough, Spotify doesn't really give you a lot of detail or a lot of control when you try to do a search. It only shows you the first 1,000 titles that match that keyword. And I was just scrolling through and I couldn't really see anything that really reminded me about that song. And then I suddenly remembered that I've been using a service called Last.fm for a long while. And if you never used it, it's basically like a social network for music where you can use plugins to record all the songs that you have been listening to. So if you have your own music player, and Spotify, for instance, supports that, the music player will be sending all the songs that you have been listening to. And over time, you are building a database with basically your musical interest. And this is my profile. I've been using it for a while. As you can see, I joined the platform in 2007 and I have been scrobbling, which is the terminology that Last.fm uses to say songs recorded, more than 250,000 songs. So hopefully that song must be there, even if I listened to it years ago. Okay, but how do we search in my personal music catalog? There is an API. So as a developer, this is something that I really like. And this API, even though it's not the newest, has been around for a while, and you can see there's some XML, is hopefully going to be good enough to help us to find the song that I'm looking for. So the first thing that looks interesting in the API is that there is this user get recent tracks method that we can invoke. And in theory, it should give us the most recent track that a user has been listening to. So in my case, I can use that for my profile and see what were the latest tracks. So I can start to build something programmatically that goes through my history of songs and maybe search for the word dark in there. And maybe that way we'll find the song that we are looking for. So let's give it a shot and let's see what happens. If we want to try this API with curl, I need an API key. Here I have it in an environment variable, so we can just run this command and see what happens. So it looks like we get some data in JSON format. Again, the format is not the prettiest, but hopefully something we can work with. But now the first thing that I want to do is convert this curl to JavaScript so we can add more and more business logic and be more flexible that way. So let's do that. Okay, very easy. I'm using a new client from the Node.js Foundation called Undici, which is actually really, really cool. And basically, I just need to import a request from that package. Then we can build a request where I'm specifying my own API key, my username, the method that we want to call, and the format for the response, which we expect to be JSON. At this point, I can construct the URL, I can specify the body for the request, make the request, read the response payload as a JSON, and we can console log the resulting data. If we do all of that, we should see something like this. Now, the first part is like a metadata part where we get the sense that we are getting a paginated response because it's telling us this is page 1 of 50,000 something pages, 5,000 something pages for this particular user, and there is a total of more than 250,000 records. And then the second part is called track, and track is actually an array of all the tracks that are available in this page. Funny enough, there are 51 tracks and not 50 as specified there, so there is something dodgy here, but we'll find out more about that later. But the next question is, now that we know how to fetch the data for the first page, how do we go to the next page? And if we look again at the documentation of this method, we notice that there is a parameter that is called page, and we can specify that as a query string parameter. So our intuition is that the first page will be page 1, and then we can say page 2, page 3, page 4, and we can keep iterating until the very last page. And that way we can traverse the entire history for my profile. Okay, let's update our script to do that. So we need to initialize a variable. Initially is going to be 1. Then we define a while true. So we're going to iterate endlessly until we reach the very last page. At that point, we should break. So now, as part of our query, we have a new parameter, which is page. So initially that's going to be 1. And everything else is the same. The only difference is that before completing the loop, of course, we need to check if this is the very last page. So we are checking if the value of page is equal to the number of total pages that we get as a response. And if it's the last page, we break. And of course, we also need to increase the page counter every time we complete an iteration. So let's see how that looks like. So it looks like we are getting pages. As you can see here, there is a counter that is increasing. So that looks reasonably okay. Hopefully it's really working as we expect. Now let's have a look inside the tracks. So to do that, we can simply do a print, because at the moment we were seeing object. So we want to look a little bit closer into those objects and see if the data makes sense. So here what we want to do is print the date. We want to print the name of the artist and the name of the track. And we also print some separators to actually visualize where a page ends. So we can distinguish between pages. How are we getting the data? Also here I'm cheating a little bit because I changed the pagination size to 10. And this is just to visualize a little bit better how the data looks like across pages. And this exercise is useful because we start to notice a bunch of weird things. The first one is that there are songs that have undefined as a timestamp, and this seems to be always the first song for every page. Also, interesting enough, if you look at the second and the third page, the song is exactly the same. So this is a little bit suspicious. And the other thing, and this is even more concerning, is that between pages, so the last element of one page and the first element of another page, in this particular instance, looks exactly the same. And it's not like I was listening to the same song twice, because the timestamp is exactly the same. So there are literally duplicates between pages. And this is something that might be a little bit confusing, and hopefully we can get rid of just to avoid bugs and confusion. Now, this problem is actually very common in paginated APIs, and it's called the sliding windows problem. And basically this problem happens when you are looking at data in a paginated way, but this data is not static. The data might be changing as you keep going through the data. So that means in our case that as I'm going through the data, I might be listening to new songs. So the data set is basically always moving. Okay, so let's try to visualize this problem to understand it a little bit better. So we're looking at tracks from the most recent to the oldest. And we are looking at this data in a paginated fashion. In this example, we are getting 5 items at a time. And what are we doing is basically saying, okay, but at a certain point in time, because I'm listening to the music in the background while I go through the data, some new track will come in at the front because it's going to be the newest track. So at this point, if we look at the pages again, all the data has shifted to the left, right? So if we look at the last element of the first page before the new track, that element is now the first element of the second page. So this is why we were getting the duplication, and this is a little bit annoying. Now let's see if there is something we can do to get rid of this problem. And one thing that we can do is to switch from the page parameter and use another parameter that is called to. And to is basically an end timestamp, so we can do a pagination based on timestamps. Let's see how that looks like, but we're going to call this time-based windows. So again, we have tracks from the newest to the oldest. This time we only fetch page 1, and after we fetch page 1, we take the last track of that page, and we are going to call the timestamp of that track T1. Then in order to fetch the next page, what we are going to do is basically say fetch the first page, but before T1. And that basically means setting the parameter 2 to T1. Now, before and to is a little bit confusing, but keep in mind that here we are going in reverse order from the newest to the oldest. So from the biggest timestamp to the smallest timestamp. So what we do, we can keep going this way, and we keep fetching only one page at a time. We don't really know how many pages there are. And for every next page, we basically take the last timestamp from the previous page to determine the starting point of the next page. And when are we done? We are done when we get an empty page, or when the num page, which is the total number of pages, is 1, which means we are at the very last page. Okay, let's try to change our business logic to implement this idea. Now we just need to swap the page parameter with the to parameter. Initially it's going to be empty, which means take the most recent for the lastfm API. And again, we need to make sure that's used in our query string. And now the condition to check if we are at the very last page changes a little bit, because we just need to check if total pages is minor or equal to 1. Also, we want to make sure we update our pointer, so we read the next timestamp by looking at the last track in the current page, and we take the timestamp of that one. Okay, let's see if this looks a little bit better. Now, if we look at the timestamps, they seem to make sense, so hopefully our implementation is perfectly correct, so the boundary matches as expected. And now we don't see any more duplicates, as you can see. So this seems okay, seems like we are actually fixing the problem. Now that we have a working solution, can we generalize it? So, for instance, the idea is, I'm coming to this a little bit as a library author, is, okay, I'm trying to solve my own problem, but if I manage to generalize this problem, maybe other people can have a nice way to fetch data from lastfm, and they can do whatever they want with it. So they can build their own custom behavior on top of this sliding window time-based solution that we built. So, for instance, we could build a generic reader class or object if you want, and this object, once instantiated with an API key and a username, should be able to expose this information in a nice way that you can programmatically control and maybe do search, maybe you can do analysis, you can save it to a database, you basically can do whatever you want with the data that is coming in. So I started to wonder, okay, what is the nicest interface that we can expose in JavaScript and Node.js so that people can use it in a nice way? They don't have to, they will basically have a nice developer experience. So I started to look back at everything I knew, and the first thing that came to my mind is, okay, I could build an interface based on callbacks. So for instance, the reader object will have a read pages method, and when that method is called, you can specify what needs to happen for every page and what needs to happen in case of an error, and you specify those behaviors by passing 2 different callbacks to this function. This is one way, but I wasn't super happy with the idea of callbacks, so I kept thinking and trying to find different ideas. And another approach that came to my mind is using event emitter. If you are a Node.js developer, this is something that you have probably seen a lot because event emitters are used heavily in Node.js. So the idea is that, okay, we could have a method called read, which as soon as we trigger it, is going to start to consume the data from lastfm. And then we can have events. For instance, we can have an event called page, which will trigger our own callback if we set up a listener for it. And that page means we have a page, you can read the data from that page. And then we can have another event completed. That event can give you the idea of when we completed iterating over all the data. In this case, I'm also using it for errors, but we could have had another reader on error dedicated event. Again, this seems like a good idea, but I was trying to think, okay, are there better ways? And because I'm a big fan of streams in Node.js, of course, another idea might be to use streams for this, because streams are the perfect abstraction if you have data that is coming in, but the data will come in different chunks, and you might want to start consuming the data as soon as you have some chunk available. So streams, not surprisingly, I built on top of Node.js event emitters, so the interface that we have here is actually very similar to the interface we saw before with raw event emitters. So another interesting thing is that if you use streams, you can use the pipeline operator. And the pipeline operator basically gives you a nice way to combine different streams from a reader, transform stream, and then a writable. And you can easily handle errors on completion by using a callback. So this is something I recommend you if you're going to use streams. But now, again, I was trying to think, okay, what else can we do? And then I remember, okay, but actually async iterators are a perfect use case for this. And the first reason is because you can write a for await. And a for await is amazing because it looks like writing a simple for loop. So that will basically consume every single page for every single iteration. And it's going to wait for you to execute another iteration until the next page is available. And even better, the code is going to look sequential because everything you write after the for await is going to happen only after you have been iterating through all the data and there is nothing else available. So if you have things that you want to do at the end, you can simply write the code after the for await. But even better than that is error handling, because error handling can be unified. You can just put a try catch around the for await, and this try catch will capture both synchronous and asynchronous error. So you have a nice way to manage all kinds of errors that can happen while going through these tracks. So if you have, for instance, an access to a property that doesn't exist, that's a synchronous error, and the try catch will work. But also if you have an asynchronous error that derives from trying to do some asynchronous operation, that will also be captured correctly, and you will be using your catch to handle that particular error. Okay, so now the next question you might have, okay, we want to make this API an async iterator. How do we do that? And in order to understand that, we need to explore the iteration protocols. And I'm going to speed up a little bit here just to make sure we have the time to cover everything. So just to clarify something, there are two concepts that are very similar and they might be confusing. So let's try to define the difference between an iterator and an iterable. You can imagine an iterator as an arrow that points sequential data, and the only thing that it knows, you can tell it go to the next item, and it only knows how to do that. It basically gives you a current item and you can keep calling next to go to the next item. And of course, it's going to tell you when there are no more items left. An iterable is a slightly higher level concept. It's the idea that you have a collection and you can iterate over that collection going one element one by one and get all the elements one at a time. So generally, an iterable is built by giving you an iterator, and with that iterator, you can get all the data. So you can imagine the iterator as a plain arrow and an iterable as a collection, and you can get an arrow to go through the data. Okay, so how do we implement the first protocol? And the first protocol is the iterator protocol. We need to define an object, and this object needs to have a very specific shape. And the shape is basically that you need to have a function called next, and this function will return an object, and this object contains only two keys. A key that says done, and this is a boolean, so it can be true or false, and a value. So value is the current value that we are emitting from the iterator, and done is basically telling us, is this the last value or not? Let's see how we can do that with a very simple example. Let's imagine we are building a countdown and we want to go from a certain value to 0. So how do we do that and make it an iterator? We said we need to return an object, and this object needs to have a next method, and this method can return done true if we already reached 0, or it can return done false and the current value if we are still iterating. How do we use it? We can basically say we create a countdown and we start from 3, and then we keep calling .next, 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 and you can see that what we get in return is value 3, value 2, value 1, value 0, and finally we get done true. Now, if you know generators are a nice syntactic sugar to create iterators. So we can rewrite all our previous code exactly like this. So a generator is basically a special function that you define with an asterisk in front of the name, and then you can use this keyword called yield. And when you use yield, basically what happens is that the JavaScript runtime suspends the execution of that function. It will yield that particular value, and if you call the function again, it will resume the execution of the function, and it will also remember the value of every single variable. So if we write the code that way, we can use it exactly in the same way, so it works almost like the same thing. The only difference is how the value is emitted in case of done true. Okay, now let's look at the iterable protocol. So the iterable protocol is basically a way to define that an object is iterable, and to do that you have to implement a special method called symbol.iterator, which is a zero argument function that just returns an iterator. So to be an iterable, an object needs to have symbol.iterator, and that function returns an iterator, which is something that we just defined in the previous protocol. So if we want to convert our countdown example into an iterable, what we do is we return an object. This object needs to implement this special symbol.iterator function. And this is a function that doesn't take any argument, and it returns an iterator. And if you look closely here, this is exactly the previous code that we wrote before, because we knew that that previous code was an iterator. Now, because we know that we can use generators to define an iterator, we can also rewrite the previous code like this, which is a little bit nicer to read and write. What is the nice thing about iterables? Iterables allows you to use a higher level syntax, which is the for of. And with for of, you can basically say, rather than calling .next manually and having to check, is it done, is it done, is it done? You can just do a for loop, and inside that for loop, you will get the current value, and you can just use it without having to unwrap data from that particular object returned by the iterator. So with this approach, you just do a for loop and you get 3, 2, 1, and 0. So much nicer to read and write again. Okay, but all this stuff is synchronous. We want to do HTTP, we want to call APIs, so we need to do the same things, but in an asynchronous way. How do we do all of that? Surprise, there are equivalent protocols for async. So there is an async iterator protocol, which is very similar. Again, we build an object. That object needs to have a next method. That next method needs to return an object with a certain shape. But the interesting thing is that this time it doesn't return the object straight away, but it returns a promise that resolves to that object. So that gives us a way to make returning object asynchronous. We just return a promise, and that promise will resolve to an object with the shape done and value. So now let's try to do, again, the idea of a countdown example, but this time before one event and another, we can specify a delay, for instance, of 1 second. So how do we do that? We basically say, because next this time needs to return a promise, the easiest way to do that is just to make the next function async. Then what we do, we wait the given delay, for instance, could be 1 second. And then everything else is pretty much the same. Again, by being this function async, implicitly the return will be a promise, and this promise will be resolved to one of the two possible values when effectively we complete this asynchronous function. How do we use it? Again, we create our async countdown, we start from 3, and we keep calling .next, but the difference is that this time, for every invocation, we need to await that promise in order to actually have the value. And you can see that this time the value will be 3, 2, 1, 0, and eventually we are done. If you want to run this code, you're gonna see something like this. And you can tell that we are waiting more or less 1 second between one element and another. So this seems to work as expected. Again, we can use generators as a syntactic sugar, and the funny thing in JavaScript, I don't know if you've ever seen that a function can be both an async function and a generator function. And that basically looks like this. You have both the async keyword and the asterisk, and you can use both await and yield in the same function. So this is pretty cool stuff that you can do with JavaScript. Now, the last protocol we need to discuss is async iterable, which is basically the idea that you have an object. This object contains a collection, but this collection is not available already, it's something that will come up over time. So it's going to be somewhat an asynchronous collection. And the protocol looks very similar to the synchronous counterpart. You have a symbol.async_iterator method that you need to implement, and that method just needs to return an async iterator. So let's look at for our async countdown. We just need to implement this, and this is going to be returning our iterator from the previous example. Okay, an interesting thing is that if you use async generators, by default, they already create async iterables, so we don't even need to specify symbol async iterator. And basically, this code is going to be, by default, both an async iterator and async iterable. So you can see how generator functions are very powerful to abstract the concept of iterators. Now, the nice thing of async iterables is that we can use that for-await syntax that we were talking about at the very beginning of the talk. So basically, if we write this code with for-await, we can see that something like this happens. Basically, we just get 3, 2, 1, and 0. And this is convenient because we don't have to think when to break, we don't have to check the return object to understand when it's done, we don't have to call .next and await it manually for every single call. So now that we know how async iterable work and how to implement one, let's try to apply this knowledge to our last.fm object. So we have our business logic here. What we need to do to create an async iterator is basically, or an async iterable as well, is basically to define the function as both async and generator function. Then what we do is basically saying pretty much everything we wrote before. The only difference is that now when we have the data available, what we do is we just yield the data. So whoever is consuming the iterable can just take the data and do whatever they want with it. And that's basically everything we need to do. How do we use it? We instantiate our object. And then because this object is going to be an async iterable, we can just use a for-await. And in this case, for every page that we get out of the iterable, we just want to print this page. And this is going to look something like this. And if we zoom in a little bit, you can see that we get data page by page. Now, we haven't solved our problem yet. We still don't know the title of the song that I was looking for. So how do we do that? Let's try to use our library that we just created. And every time we get a page, we can go through every single track and try to filter out and keep only the tracks that contain the word dark in the title. So how do we do that? We create our instance of the last.fm client, and then we do a for-await. Then inside, for every single page, we check every single track in that page. And if the track name contains the word dark, then we just print that particular track. So I did all of this, and I let it run for a while because I had hundreds of thousands of songs in my history. And basically what happened is that eventually, these were some of the results. I was reading them, and eventually I noticed this title. And this title was very familiar, and it was actually the song I was looking for. And if you look at the timestamp, this was basically 9 years ago. So I have no idea how this song came back randomly to my brain after having listened to it for more than 9 years. Okay, so just to close up this talk, I hope you learn about async iterators and all the other async and synchronous protocols that you can use in JavaScript and Node.js. But one interesting thing is that when you create your own custom async iterator or all the other iterator iterable protocols, you can always build additional behavior on top of them and make a smart interface that users can use them confidently. For instance, one thing that I noticed while doing this exercise is that occasionally the last.fm API would return a 500 or a 503, so the API wasn't really stable. And I was very annoyed because after waiting for like 20 or 30 minutes to go through all the data, it would just suddenly crash and I need to restart from scratch. So one thing that I implemented as part of my own custom iterable is integrated error handling and automatic retries. So basically, if there was that kind of error, like a transient error, the iterator will automatically retry internally. So as a user, you don't have to be concerned with that problem. And if you want to see how that looks like, I actually built a small library. So you can check out this link and the code for that particular library. And that's everything I have for today. Thank you very much. And hopefully you'll have some nice feedback for me. So I look forward to hearing more from you. Bye.
Wow, it's a very cool presentation from Luciano. So often we have to call APIs and then there's a lot of pages there and we are usually confused. How can we do that? So that's a very great presentation from Luciano. So now we have the solution after getting some problems similar like that. So Luciano, there are some questions and I would like to share the first one. So how can we find a song with just listening to a small part of it? It's a very large database of songs. So how can they do it so fast?
Yeah, actually, I don't know if I know the answer to this question. I think there was an article some time ago that was explaining how you could create like an index of parts of a audio track, I guess, if you want to generalize the problem, and then use that index for search. So you collect other, I don't know, sample data by recording from a microphone or something like that, and use that information for comparing the search. But I honestly have no idea how to implement something like that myself. So if somebody knows or somebody has links, I think it would be very cool to share them because it's somewhat relevant to this talk and I would be very curious to read it.
Tried to make some like 10 years ago, but it's quite challenging to compare the music and with the database and like indexing. Yeah, that's quite complicated in the back part. Yeah, the back end part. So I also am very interested in how can we know how many pages are there? Maybe you can give explanation.
Mm-hmm. Yeah, in the case of Last.fm, that really depends from how they give you the data through the API. And for instance, you get different results depending if you use the different parameters that I showed in the talk. So if you use the page parameter, so you go from page 1, 2, and 3, and 4, and so on. Every time you get a page, in the metadata, you also know exactly what's the total number of pages. So you can tell, okay, if I am at page 5 and there are 10 pages, there are only other 5 pages left. The problem is that when you start to use more dynamic filtering, like when I switch from the page number to the to parameter, and you also have data that is dynamically changing all the time, you just get a number of pages that is not necessarily going to match your next query. So I think the best bet you have there, and this at least was the way I implemented it, is when you see that you have no more pages left, that means that if you try to call another page, there is not going to be any data. So at that point, it's probably safe enough to stop.
Okay. And how about what is your recommendation on saving the results? If there are so much pages, what should be the best practice for us to save the results? And I think some results are not important, but some results are important, and sometimes there's a mismatch. And how do you recommend to save the results in a better way?
Mm-hmm. So if I'm understanding the question, one cool thing that you get with async iterators, but also with streams in general, is that as soon as you have some data, for instance, in our case, the content of a page, which might be, I don't know, 20 or 50 tracks, you can already take all that information and do something with it. So if you're, for instance, if you're trying to save it to a CSV file or a database, for example, you don't need to wait for all the tracks to come through and then you do like a huge save at the end. Maybe you wouldn't even have enough memory in your machine to do all of that. But with streams or async iterators, you can just take every single chunk of data and save it, and you keep appending that way. And this will be very efficient, but also it's gonna allow you to consume even potentially infinite amount of data, because you are always streaming the data that you are getting piece by piece, rather than just waiting indefinitely for the data to come through.
Okay. There's also Victor said that the next step will be to add a search to the lib, so anyone can just pass the keyword and have a result.
Oh yeah, that could be a nice pull request if you want to contribute. Thank you for that suggestion.
Okay. Any other questions maybe from the participants? I think it's a very insightful code and we can learn so much. So do you have many of these problems in your work? So what is the most challenging thing about using iterators? Maybe you have some difficulties that you found during your work.
Mm-hmm. Yeah, I think the pagination example is probably the most common. I've been working a lot with AWS lately, and it's actually really nice that the latest AWS SDK for JavaScript has all these concepts built in. So for instance, if you're using DynamoDB and you want to read data from a DynamoDB table, you are getting different pages. The object that you get is already an async iterator, so you can just use that for await. So that's very convenient. But I also had to implement in the past like workers that needed to consume jobs from a queue. And that's also another nice case where you could implement the interface for the worker as an async iterator, and then you just write everything in a for loop. And basically with that for loop, you are automatically waiting for new jobs to be available before you repeat another iteration of the loop. So these are some use cases that come to mind where async iterators actually give you a very nice interface. There is another one that is really interesting that was initially promoted by Dino, the alternative to Node.js, and they show in their own HTTP library that you can create a server and then you create the handler for requests by doing a for await loop. And that's a really interesting one because there are some caveats. Like you might, if you're not careful, you might end up processing one request at a time. So your server will be very, very slow. So that's a case where it might look nice to use that abstraction, but it might also be dangerous. So be careful. If you see something like that, make sure you really understand how the event loop works and make sure that you benchmark your server to make sure that you are not effectively blocking one request at a time before processing the next one.
Yeah, great to hear your answer. There's also a question about any tips on debugging generators when using yield. I tried recently and used array from a lot.
Yeah, that's a good question. I didn't ever need to do that like too much in depth, so I might be missing something obvious there, to be honest. I would expect that a debugger can show you the steps when you use yield asterisk. If that's not the case, I can see how that's a little bit dangerous, because when you do yield asterisk, you're basically delegating a generator to another generator, so the original generator is just going to stop, move the control to the other generator, and it's not going to resume until the other generator has finished. So it's like something like a recursive call, if you want, of generators. And I'm wishing that debuggers allow you to see that jump and see what's happening in the inner generator. If that's not the case, I suppose it's not a lot of fun to try to debug those things.
Yeah.
So sorry if I don't have a better answer to this question.
Yeah. Someone also asked to where we can use the generator.
Yeah, it's something that doesn't come up too often, I think, in JavaScript in general. Like you can probably go a long way without having to use generators. I think the most common use case is the one we discussed today. So when you are building your own custom iterators or iterables, I think it can be very convenient to use generators because they give you a nicer interface to manage the state. Like sometimes if you want to avoid to use generators, you can, but you need to build like a mini state machine yourself. and it's a lot more code. It's easy to do mistakes. With generators, it can be easier to do it. Other cases in general where you want to, when you are not really sure how the data is going to be used by somebody using like a library, and you want to build that library in a way that if people want to use the data piece by piece, like every time there is some data available, they can use it straight away. Or if they just want to accumulate all the data in one go, like in a large array, they can do both things. Generators actually give you like a result that allow people to do both. So if you want to build something flexible, that can be another use case for generators.
Thank you very much. And all other questions can be asked directly for Luciano. There's your social media, your Twitter. You have shared your Twitter page, and anyone that needs to ask more questions can contact Luciano. And he also has a great book about Node.js design patterns, so you can also check it out. Thank you,
Thank you so
Luciano,
much,
for
Esther.
your
Thank
talk.
you, everyone else.
Yes. See you.
Bye.
Okay. Thank you for the session provided from Geekle for letting me be a moderator, and this is a great experience for me. Tomorrow I will also be a speaker about machine learning and social network analysis, so please come to my speak. And after this, the first speaker, Mr. Ik, will become the moderator for the next session. So let's wait for another 10 minutes after the break and see you.
And now we want to say a huge thank you to our sponsors at Scout. As the application engineering landscape continues to evolve, the state of observability has become more and more exciting. With tools like Scout, you can get insights into your stack without having to be an observability expert. OpenTelemetry is a new open source project providing a unified standard for telemetry data such as metrics, traces, and logs. With power of OpenTelemetry, Scout is building a new observability platform to help simplify telemetry data into actionable insights and is now accepting beta testers. If you want to know more about OpenTelemetry and become a beta tester for Scout new observability product, go to scoutamp.com/observability, and you can find this link in the chat right now. Thank you, Scout, for joining and sponsoring us.
Hey Global Summit for Node.js 2022. Tanya here from Bright Security, the developer-first dynamic application security testing scanner. We've made it easier for you to run security testing and are the first scanner to integrate with unit testing. Start creating automated security unit tests with our new sec tester. Everything is controlled via the CLI to test each function or component in seconds. And with no false positives, you can finally trust your scanner's output to produce secure features at scale. Get exclusive access to this feature by joining our workshop on June 9th. See the link in the chat now or find it on the event website. Security testing just got brighter.
Now? Okay. So, right. Sorry for that. Of course, something had to happen. So, welcome everybody to our next block of sessions. My name is Ege from the first session, and I'm glad to be here with you today for the Geekle Node.js Summit. So today I'm broadcasting here from Munich, Germany, and for this first session we have a special guest from Bright Security. So let's welcome Akira, who works in developer relations at Bright Security, where they are on a mission to help developers build secure software. They have worked as a full stack developer in both e-commerce with PS products and edtech with Emeritus and MIT. They are currently working on a Node.js app to manage the myriad relationships formed in their rel. As an educator, Akira has mentored and taught students of all age groups and levels for over 10 years in technology and music, both in classrooms and as a tutor. You can talk with them about cybersecurity, clean energy, protecting biodiversity, and last but certainly not least, growing gourmet mushrooms. That sounds interesting. So let's all welcome Akira. And
hi, everyone. Thank you for the warm welcome. That's very kind of you. Can you all hear me okay?
Yes.
Perfect. Okay, good. All right. Well, hi, everyone. My name is Akira Brand. I work in developer relations at Bright Security. I am so excited to be here. I just want to say thank you to everyone, all the organizers for having me here. And also thank you so much to the participants in the audience today. I am going to show you something that no one has seen or done before. It is called unit security testing. It is a tool that helps you use unit tests in order to find security vulnerabilities in your code as you're writing the code itself. This is very new. It's very exciting. You are all actually the first people in the entire world to see it. So I'm very excited to present this to you. And as always, looking for feedback. Would love to hear your comments. One thing I will say is that in the chat, feel free to go ahead and ask questions. I will get to them as I can. Feel free to add comments if you have a funny story that you want to share about some of these things that have happened to you in your work. We would love to hear that. So let's get started. Okay, so what are we going to cover today? Well, First off, we're going to talk about an introduction to application security, what it is and why it matters. We're going to talk a little bit about our secret sauce of AppSec tech, which is unit security testing. We will do a sneak peek into our tool called SecTester that does unit security tests. And if we have enough time at the very end, we will have a little bit of section for questions. I also really like memes, so we will have many, many memes during the course of this talk. Okay, let's talk a little bit about me first off, so that you know who is talking to you today and am I actually qualified to give this talk. So like I said, my name is Akira. I'm a software developer and educator. I've been working in tech since 2018. I am an award recipient of a NASA hackathon. I won that toward the very beginning of my tech career. It was a hackathon based on using NASA satellite data to check living conditions in refugee camps so that aid could be provided in a more economical and less wasteful manner. I also really enjoy growing things. Whoops, sorry, my thing is going backwards. I enjoy growing things. As you heard earlier, I like to grow gourmet mushrooms, and I enjoy taking things apart and putting them back together as well. Okay, so what is application security? What am I even talking about today? So AppSec, otherwise known as application security, is an umbrella term used to describe anything that has to do with writing and shipping secure software. There are a lot of activities that AppSec covers. Some of those activities include hiring a pen tester to come and test your code from time to time. This is usually done every 6 months to once a year. Doing something like secure code reviews with other people on your team, and also doing internal training for your company to help developers learn how to write more secure code. Traditionally, AppSec is done by third-party testers once a year. It has usually been owned by the security team or third-party pen testers, as I've said. However, the entire industry right now is shifting toward developer-focused security training. Now you have to own it as a developer. You may not have to own it yet, but you will have to own it soon. The problem, though, is that the tooling to test for security vulnerabilities and to educate developers about how to write more secure code is lagging behind the need for developers to use it. The tools are either not built specifically for developers, they are built more for security teams, or they are hard to use, they're hard to integrate into the workflow, and they are slow and painful. However, you do want to be able to own your own application security early, and you want to be able to own it often. You want to own the process from start to finish. We are definitely here to help you with that. So why am I so obsessed with application security? Why is it important? Well, let me ask you a question. How many builds is your team doing per day? You're probably shipping code into production faster than you ever have before. Even with the best will in the world and a security team on hand, you also, however, may be shipping security vulnerabilities into production at the same pace. This is a big deal because the lion's share of security issues happen on the application level. They happen within the code itself. If you rely on periodic pen testers, they may not get back to you with issues in your code until almost a full year after you have written that code. Now you need to start context shifting. You need to start going back and looking at code that you wrote almost a year ago in some cases, and you have to remember what you meant by that code. That is really hard. If you're anything like me, I can look at my code from a year ago and go, oh my gosh, this is garbage. What was I thinking in the first place? And then trying to understand my thought process from those olden times is very difficult, and it makes it very difficult for me to continue to work on really, really old code. Another point to consider is that you might not be at the company anymore, and now some other person has to go back into your code a year later and try to figure out what you were doing without you being at that company anymore. The last point I want to make, again, is that you are ground zero. Like I said, the lion's share of application security vulnerabilities happen at the application layer. They are within the code itself. If you want an efficient product delivery system, you want to start treating security bugs as regular bugs. That meaning you want to start looking for them earlier, you want to look for them often, and you want to fix those bugs before you even reach production, not months or years afterward. So in the chat, I would love to hear from you what kind of security testing that you use right now, and if you like it. Does it work for you? Do you have any horror stories? Do you have any success stories? Would love to hear from you. And I have personally been sometimes the reason the security team wants to meet with the dev team. It can be very nerve-wracking. So hopefully that hasn't happened to you, but if it has, would love to hear your stories. Okay, again, just the quick prompt question I want to know from you. And let's see if anyone has any questions. I'm going to take a brief break. If anyone wants to throw a question in the chat, throw a question in the comment section, we will take a brief moment and just look at that. Okay, looks like there's no questions right now. Let's go on. Okay, so let's talk about developer-first security testing. Like I said earlier, existing tools are slow and existing tools are painful to use. There's lots of configurations. They don't go very fast. You might not have the right version of Java, or you might not have the right version of Node or something along those lines in order to use these existing tools, because again, they aren't built for you. They're built for security teams, or they're built for penetration testers. They're not built for you as a developer. However, the earliest time that you can integrate AppSec is in your unit testing. So what we again saw is well, there's a lot of tools out there, but they're not built for devs, and they're all happening way too late in the system development lifecycle. What can we build to help devs and help them find security vulnerabilities as early as possible? Again, the earliest time to integrate AppSec is during unit testing. The sec tester, which essentially is the unit security testing tool, that's its name, we built it to integrate security testing into your unit tests. It's all controlled via the CLI. It's all initiated via the CLI. It uses a very simple test runner, which is very simple to configure, very easy to tear down. And the most exciting part about this, to me at least, is that you can test functions using a dynamic application security testing tools engine, which is our engine. So it's a dynamic scan of a tiny piece of code, just your functions, to see, does this have security vulnerabilities? Another exciting thing about it is that it has immediate feedback on almost any security issue. We have several that we have already shipped. So we look for many security issues such as CSRF, insecure TLS configurations, things of that nature. But you can also write your own tests, which I think is really, really cool. So if you want to write a test for cross-site scripting, you can use our template and go ahead and do that. You can use our engine and go ahead and test for those things. Anything that our engine can test for, you can write your own tests in Jest or in Mocha or in Chai to be able to look for those security vulnerabilities. One thing I do want to hammer home, lastly, is that this has not been available until now. This is the first time you will see this from any product on the market. We're very proud to be the first. And like I said, you will not be able to find security testing tooling this early on in any product in the market right now. So all that being said, you might be wondering right now, well, what even is unit security testing? What do you mean by that? Let me say it this way. A great goal for any company to have is to have more than one application security tool and activity at each step of creating, releasing, and maintaining software. The first tool, as you can see over here on the left, used to be called a SAST tool. sometimes in conjunction with a secure code review. However, SAST is prone to human error. Excuse me, SAST is prone to false positives. The secure code review can be prone to human error. What a SAST does is it parses your code and sometimes even your binary, and it tells you where it thinks there may be problems. However, there's lots of false positives associated with this, and developers can waste quite a bit of time chasing ghosts, aka problems that the SAST tool says are there but actually are not there. We saw this, and we saw a huge gap. We saw that SAST tool is only looking at a one-dimensional context, and even then, it's only running after the code has been written. So as you're writing code, you may not know what bugs you're putting into the security, what kind of security bugs you're putting into your code. So we decided to create unit testing frameworks right there, right as you are writing your code. So similar to how you would write a unit test to test any kind of function or component of your code, you can now add a unit test to test for security issues within that piece of code as well. So it's very, very exciting. It's not as limited as SAST. It uses a DAST engine to examine the code while it is running for these security vulnerabilities. You can check out verification flow, you can check out microservices, and the last thing I want to leave you with on this slide is that there's no false positives. So you're not going to get the same experience that you would get with a SAST, which is a SAST telling you, oh, we think there might be issues here, we're not sure, and then you go check it out. No, that wasn't actually really an issue. With this tool, it will be truthful to you. You will know that if it has found an issue, that the issue is genuine and you need to go fix it. All right. So in the past, using a tool like a DAST scanner had to focus on either running individual scans of an entire application or integrating a lot of types of tests into a production or CI/CD environment. As you can see here on the right, there are some tests that are grayed out, and then there are some tests that are just in regular black. In the olden days, all of those tests had to run on production or right before production. What we've done with this is, first off, we took our DAST tool and we shifted it a little bit left. We put it into the CI/CD pipeline. So now CI/CD is taking care of some extra tests. They're taking care of CSRF and SQL injection. But there's still cross-site scripting, there's still OSI, there's still LFI. Those tests would still have to only run in the production environment. But we realized, oh, we can actually write unit tests to test for these individual vulnerabilities. So that is where the unit testing really comes into play. You can test for cross-site scripting. You can test for OSI. You can test for LFI on very, very small pieces of code. Okay. All right, so now let's take a look at the sec tester itself and take a look at the sneak peek. If you want to learn more, come to our workshop on June 9th. We will go through the sec tester in depth and give you all a chance to try out the tool. But at the end of the day, TLDR, we are using our BrightSec engine to run tests against your individual code components, such as individual functions. 2 caveats before we dive in. One thing that I want to mention, this is in alpha. If you play around with it right now, and we very heartily recommend that you do, we say you may encounter some blips, you may encounter some bugs along the way. This is normal for right now. We are working on developing lots of docs and training to help you out, and by the time you come to the workshop on June 9th, this will be in beta. It'll be a much more stable build. One other thing is that we really want your feedback. Please join our Discord or email us, ask questions there and give us feedback. We really do want to hear from you. Okay, this is very simple. What we're going to do right now is I'm going to show you quite a few screenshots. We're going to look at the tests themselves as well. We're going to look at example output. We're going to look at the actual commands that you need to run. But at the end of the day, this is only 3 or 4 steps depending on the configurations that you use. So unlike other tools, it's simple, it's easy, and it's fast. Step 1, add configurations. So what you will do after you get your API key is you will configure your API key either in a config.typescript or config.js file. You can put it in a .env file. It's very simple. And then the engine itself will pull the API key from this configuration, as with many other tools as well. So that's the first thing you do. Whoops. Oh. Okay, this is actually supposed to be step 2. Sorry about that. I accidentally wrote 3. The second thing you'll do is install dependencies and/or the runner. The runner itself is configured within the test itself, so I will show you that a little bit later. Or if you decide to go into our website and use our example product, our example project, you would just install the dependencies like so, npm-s. And then the last thing, run your test with npm run test. It's simply that simple. And then you will get the CLI output as so. So what you can see here, there were several different types of tests that we used, and all of these tests failed in the code that we were running against, which in this case is we are running against a QA version of a website that we built called Broken Crystals, which is meant to be intentionally vulnerable. So as you can see here, it's quite nice. It's quite short up and it's very concise. You could say, okay, missing content security policy header. We have a missing cross content type options header, a missing strict transport security header, and so on and so forth. So this one essentially is just testing for lots of different types of security headers. Now, what you can do with that information is you can go into our UI itself and take a look at those failing tests within the UI and get a lot more information. So within the UI, you can take a look at why it happened, where exactly it happened, and remediation steps and remediation examples that you can use to fix it. Or you can also go to our docs and Google within our docs to take a look at these different issues and learn how to fix it from there. Here also, for example, is an example of a failing test, what it might look like within your CLI. That's it. Literally, that's the whole thing. It's very easy to configure. It's very easy to set up. You run the test suite and then you get CLI output. From there, you can go to our docs and learn how to fix it. You can go into the UI and get some information on how to fix it. That's it. I want to take a little more time to talk a little bit about how it works under the hood and how the actual tests look like as well. But I'm going to take just 1 second and look for any questions in the chat or in the comments. Okay, it looks like show us the demo. Hey, perfect. We're right there. Show us how it looks like. Would love to. That's what we're doing. Could you tell me what these SAS, DAS, RAFs, etc. stand for? Andrew, that's a great question. For now, I'm only going to do SAST and DAST because if I do the rest of them, we'll be here all day. So like I said, SAST stands for Static Application Security Testing Tool. That looks at your static code. It's sort of like a linter or a spell check for security issues. It doesn't look at your code as it is running, though. It just looks at it in a one-dimensional way. A DAST tool stands for Dynamic Application Security Testing. This looks at your code as it's running. So it's more of a three-dimensional view of code. The better part of DAST as opposed to SAST is that DAST doesn't have false positives the way that a SAST tool does. If you want to know more, Andrew, you can go to We Hack Purple. I'll put a link to that at the very end. And we have an entire couple of blogs that outline all these different terminologies. Okay, let's go on. If anyone else has any questions, feel free to put them in the chat. Okay, so like I said, this is all very well and good, but can you actually show me a test? So what you'll notice is that if you decide to work with our example project, we're going to have two folders. One is a test folders that contains small tests against vulnerable qa.brokencrystals.com, which is, like I said, the intentionally vulnerable website. It will test against entry points and scan configurations, which will be used to find them. The research folder contains small tests against the same website, but it's not clear which scan configurations can find them, and you can feel free to research this. Okay, let's look at this. So here's again some of the tests that we include. As you can see here in the test dropdown, We test for all kinds of things. Right now, we do cookie security, CSRF, directory listing, so on and so forth. One thing I will say is that you can add your own tests. So you can use any of these templates to help yourself write these tests if you would like. And so say, for example, you want to write your own specific test for cross-site scripting, you can do that. It's pretty cool. So let's take a look at this example CSRF test. I'm going to make this a little bit bigger. I'm not sure if it will show up on your side as larger. If not, I apologize. This is a little bit small. Well, I kind of want to just walk you through this test itself. So here on the top, we have our imports. We import the sec runner, which is the runner for the sec tester. We also import our configuration file from earlier on in the project that we configured toward the very beginning. And then we're also going to import the test type. So for example, are we testing for cross-site scripting or CSRF or whatever? And also the severity level. We can write breaks in our test here to say, hey, if the severity level here is more than low or more than medium or more than high, I want you to show me that essentially. All right, the whole first section here, what you'll notice is that we start a new runner here. So every time we run a test, we boot up a new sec runner. And at the very end of each test, we will clear out the sec runner. And right here, when it says it and then header security async, this async function right here, we are actually creating a little baby scan, a little tiny scan using our Dast engine that will test the header security type. Of course, we give it a name, we give it a timeout, and we will just run it against, in this case, we're running it against localhost. So you can run it against your local host, you can run it against an API endpoint, or you can run it against a deployed website. So that's what a test looks like. This one, again, tests specifically for header security. That was the example output that we looked at earlier. And as you can see, it's not too long. It's not too scary, and you can use this type of template. You can use this pattern to write your own tests as well. So this is what you would see if you had a passing test. Just wanted to show you a quick screenshot of what that would look like for you. So you can see here 1 passed, 1 total. And if you have issues, again, this is showing the same output that we showed earlier with the header security test. As you can see here, it's in a nice little concise way, but you never have to leave your terminal, which is really quite nice. Okay, let's talk a little bit about some frequently asked questions that I've gotten. Number 1, can I add my own test? Absolutely, you can do that, no problem. The one thing that I would also say is that you are free to test or write tests for things that we don't even have tests for yet. So this is all open. So if you want to contribute as well, like that would be awesome. We would love that. Let me see, what else do we have? What languages is this compatible with? So right now we have Crystal Lang. So we have Crystal and Lucky framework. And then this version, as you can see, is written for JavaScript and Jest. The JavaScript Jest version, like I said, is in alpha. The Crystal one, if you know Crystal and want to mess around with it, is a much more stable build. So you could probably get a little bit more into the tool itself if you want to try it. Number 3, do I need to pay for this? No, this is free. This comes as part of the free version of Bright Security. You can write your own tests for free, of course. So it is free for all of our users, which is fantastic. The last question I get a lot is, isn't this the same thing as a SAST? Because it's around the same time. It's not. So one thing I do want to mention again is that SAST looks at your code only statically, and a DAST looks for your code in a running way. So this is using a DAST engine just very, very early on in the process. Let's take a look now and see if there are any other questions. Korkan says, yeah, it is okay, Akira. Hey, thanks, appreciate it. Victor Yu says, can it be executed offline? I see it requires cluster and API key. Victor, that's a good question. From what I understand right now, it does have to be online because of the cluster and API key. I'm not quite sure though if you can do it offline. I myself haven't done it offline. I've only ever done it against broken crystals using the cluster and API key. But definitely hit me up on Twitter or hit me up on email, and I'll definitely find that out for you for sure. Definitely want to know that as well. Andrew says, why the test you show takes so much time in minutes? That's a good question. It depends on a few factors. Number one, it depends on your internet speed. So I believe the internet speed of my coworker who showed me those tests is a little bit slower. When I run the tests, to run an entire test suite of, let me think, how many tests is it? I think it is 15 tests, takes me about 300 seconds. So that translates, I think, to about 2.5 minutes. Also, we are working on getting this not being rate limited, which also might be another issue because we're a security company. We need to make sure that people aren't just hitting our APIs over and over and over again, which could also be a reason for the slowdown. But as we get this out of alpha and more into a beta build, the test will take less and less time to run. There is a SonarQube tool, which does a bunch of things in terms of AppSec. Any thoughts about comparison? Victor, that's a great question. I have only used SonarQube a handful of times. How do I say this? My biggest differentiator between this tool and a tool like SonarQube is that from my lived experience, this is just my experience, the setup for our tool is much faster. So when I was trying to use SonarQube, I realized like, oh no, I have to like use a different version of Java than I have, and I have to go get this download of Java 11, and now we're on, I think, Java 17 or something like that. And like, why can't I use my current build? And it was a lot of steps from getting the tool to being able to actually use the tool. And I think in our instance, the steps from getting the tool to using the tool is much faster. You can get up and running in a matter of minutes, even if you're a beginner and you don't know a lot about security, as opposed to maybe 20 minutes, 30 minutes, depending on your level of experience. So that would, I think, be the biggest thing that I would contrast our tool with a tool like SonarQube. I'm going to wait for another minute or so to see if any more questions come up in the chat. If there's anything else on the demo that you want to go over with or anything of that nature, maybe you want to look at the code a little bit more, anything like that. Maybe you have a story of using your own version of a tool like this or different apps like testing tool, and you can tell us like how you liked it. Let me just give it a couple minutes. Okay. All right. It looks like we are good on questions. All right, cool. Evgeny, I'm not sure if I said your name right. Gosh, I hope that's right. Evgeny, that's a cool name. He says, nice talk. Thank you. See you on the workshop. Cool. I'm really looking forward to seeing you there. Yeah, that's going to be really cool. So on that note, I want to leave you with some resources. Again, I really appreciate your time and coming here. And I want to give you more ways to test your own code, more ways to learn about secure coding, more ways to improve your security knowledge in general. So that is the purpose of these resources. First off, though, again, we're having a workshop on June 9th. If you'd like to register for that, this is the link. It'll be free. It'll be myself leading it. We're going to have our CTO. We're also going to have our head of product marketing there, who is amazing. He's a really great technician. He has a lot of insight into this tool, even more so than I do, which will be very, very useful. We'd love to see you there. Let's go on to the rest of the resources, but I do see we have a question really quick, so let me pause. Yora says, Akira brand, hello. I don't really get the advantage of this tool for the header testing. I can also unit test the same behavior with the existing tools. Hi, Yura. That's a good point, right? So sometimes maybe you can write your own tests for things like headers, totally fine. However, writing tests for things like cross-site scripting and things like CSRF, like more security-focused things, like headers are security-focused, but you're right, you can write your own test for it as well. being able to write those tests with our engine is useful. And that being said, too, the thing that makes this special isn't so much the tests themselves, it's that you can use a Dast engine to test your code at the very beginning, as opposed to having to wait to production or just pre-production to use a Dast engine on your code. But that is a very good point. You can absolutely write your own tests for security headers. Okay, so let's talk a little bit about the rest of the resources. First off, I'm a resource to you. Like I said, I've been in tech for about 4 years. I'm relatively new to the cybersecurity world, so I'm learning along with everybody else. I'm so happy to answer questions, especially if they're asked to me in the workshop and I don't know them. I want to find out too. So you can email me any questions you have. You can DM me on Twitter. You can tag me on Twitter. If I don't know, I will absolutely look and we will find it out together. The second resource is the We Hack Purple community. This is a giant online free community full of people that work in all areas of InfoSec and AppSec. So we have CISOs, we have students, and we have everything in between. The Bright blog itself is a fantastic resource just for learning more about application security, learning more about different security vulnerabilities and how to fix them. Really good resource, lots of bite-sized articles that you can read in about 30 seconds to 2 minutes and just learn a little bit more about application security. The Bright docs also are really fantastic. We'll have more and more docs that are going to be written to support SecTester, to support the concepts around SecTester. Yeah, so that's a great way to check those out. One thing I want to mention is our Discord is an active community. If you want to get help, that's a great way to get some help, is to join our Discord and ask there. We also really want feedback. We want to know about the tool, if it was easier for you to use, if you want to know why even bother using it and it's not clear to you today, if you have problems with using it. Again, it's an alpha, but we want to know the problems so we can help you fix them and we can fix them ourselves. You can also just share memes if that's what you want to do as well. I'm a big fan of that. So there's our Discord invite. Last 3 things, and then I see there are a few more questions and I will get to those. There's a fantastic book that my coworker wrote called Alice and Bob Learn Application Security. Great book. It's on Amazon. It is super exhaustive. It's very, very thorough. And if you want to learn more about secure coding in general, it's a great way to learn that. Unfortunately, my other SecTester example, I'm going to just put that in the chat. My link got a little wonky, but then we also have the SecTester runner, which you can find there as well. Okay, let's go into some more questions. Again, I'm somewhat new to cybersecurity, so if I don't know your question, please feel free to reach out to me and we will definitely figure it out together. Okay, Yura says, Akira brand. Oh, I already answered that one. Geekle says, Bright's hands-on workshop. Yes, thank you for sharing that. Yura says, what's being sent to the server, code or compliance? I'm not sure, Yura, what you mean by compliance. Maybe you can elaborate on that a little bit more and I can give you a better answer to your question. Nora wants to know, can I go through the code again? Yes, we will do that. Let me make sure I have enough time. Geekle official says, from our platform, what is the advantage of these tests in relation on shell scripting with tools that are built in Kali? That's a good question. I'm not familiar with Kali, so I'm not entirely sure. So what I will do, since I don't know the answer to that question, I will note down that question and I will answer it on my Twitter later today. So follow me there and I'll get that question answered for you. Victor says, would you recommend using it for prod apps? Yeah, absolutely. I think what I would also recommend is playing around with it initially while it's still in beta on maybe a project that isn't like a enterprise project quite yet. Like maybe just use it on a personal project to get more used to. And then on June 9th, we can talk a little bit more about production and whatnot. I noticed that the host is back. I just want to definitely make sure that I'm not out of time so that we can go through the code again. But if I'm out of time, then I'm out of time.
Yeah, so I think you have just a tiny bit time left, so 2 minutes or so.
Okay, cool. Nora let's go through the code one more time. Let's see. Probably, I'm assuming like you might want to see like an actual test. I hope that's what you want to see, because that's what I'm going to show you. So let's talk a little bit about like an example test. This one is for CSRF, which stands for cross-site request forgery. So as you can see here on the top, you're going to do all your imports. You're going to import the severity level and the test type from our engine. You'll import the sec runner, you'll import the config, and then the sec scan. Right here at the beginning, the async functions before all async is where you actually boot up your sec runner. So you'll boot up the test runner itself. You'll have a section to clear or tear down the test runner. And then right here on before each on line 17, you will have a scan that you will create using our engine. The type of the test is for CSRF. And then, of course, we have a timeout. And then last but not least, we have at the very end a describe CSRF const severity. And this essentially is to say when a severity is low or a severity is high, we want you to run it. And then right here, the URL that you are running the test against. Okay. Geekle official says, from our platform, are you sending to the server? When running tests, what's being sent to your servers? Is my repos code being sent? So that's a good question. From my understanding, and I will triple check this, I want to make sure I get this right. So again, look for me on Twitter and I will also answer this. The engine itself is just going to test that piece of code, and the engine is going to run locally on your machine. So that's what I understand. I don't think anything is being sent to our servers, but again, I will double check. So find that out from me on Twitter later today, and I will find that out for you for sure, because it's definitely very important. Okay, I just want to say thank you so much for coming. I'm going to go to the very end here and just make sure that everyone got all the resources that they needed. I really appreciate you all coming and taking a look at this this workshop with me, taking a look at this official sneak peek. Like I said, it's an alpha. These are really good questions to have, though. I really appreciate all the feedback. And just again, thank you for your time, and thanks for learning about all this stuff alongside with me. Like I said, I'm relatively new to AppSec, and I'm really glad to be learning, and I'm really glad for all your questions because it helps me sharpen my own brain. So thank you again for coming, and we will see you another time.
Thank you, Akira, and especially for your motivation that we can really feel from your voice. And it really doesn't feel like that you're new to this field. So it was really insightful. And yes, thank you very much for the amazing presentation. There were a lot of questions, which is a very good sign. Okay, then I think we will slowly transition to our next speaker. So today with us, we have Erick Wendel. And Erick Wendel is going to talk to us about how he automated his home using JavaScript instead of what we might usually think of C++. Erick Wendel is a professional speaker who has given more than 100 tech talks, and he has been educating people all over. And so, welcome, Erick. The floor is yours.
Hello, how's it going? Can you hear me well?
Yes.
Hello? Oh, perfect. So now it's 10 a.m. I'm from Brazil, and I brought some like interesting experiments I've been doing at my home. So firstly, I'm Erick Wendel. I work with content like full time, and follow me on the social media and all this kind of stuff. Okay. So first of all, the plan here is to show you the experiment, the whole thing I've been doing at my own home, and how I changed from C++ to migrate everything to JavaScript. So feel free to like take prints, show me your ideas at the end of this presentation, because I would love to hear about you. Okay. First of all, like I'm not an expert of this kind of stuff. I'm a developer, so IoT hardware stuff, it's being like something new for me. Okay, it's something fun, but I usually go. I usually want to put everyone in the same page. Okay, so first of all, it was my common question: what is the Raspberry Pi, and what is a microcontroller, right? So a Raspberry Pi, it's like what we've seen mostly in IoT projects. It's actually a complete computer, a tiny supercomputer. It has like you can run games, you can run like retro games, video. You can use it as your own machine. It has a complete operating system, so you can do whatever you want right there. It has more like 80 gigabytes RAM or 32 gigabytes storage and expanded. It's usually had like quad core processor. It has Wi-Fi, Bluetooth, and so on. So it's a complete machine, but it's kind of expensive in terms of IoT and automation. That I'm sure use some alternatives. So microcontrollers are usually a small unit of processing, so it has less more like powerful processing, but for most of the cases at home it's like enough. Okay, so in comparison to the Raspberry Pi, this one has just 320 kilobytes of RAM or 4 megabytes of storage. So you can see some challenges right there. So you can like on the Raspberry Pi, you have infinite processing, and right here it's very few, but it's enough. Okay. So on this one, this is the SP32 made in Brazil board, and it has like Wi-Fi and single core. For those of you of like have learned of something about microcontrollers, you may have heard about Arduinos. So Arduinos, it's the most commonly used right there. But the difference here is the SP32 has more power and has integrated Wi-Fi and so on. Okay, now we are on the same page because I'm going to show you something that I've been using like Raspberry Pi and microcontrollers, and I want to make sure that you're getting the same page that I've been doing, okay? First of all, I got a Raspberry Pi, and I was like, maybe I should do something more than like just a HTTP server, right? So I was about, what if I build my own like Google Assistant or my own Alexa? Okay, so I got a beer can, I put a Raspberry Pi inside it, and I did something to help me practice and use it a bit more. So the whole goal of this project was on my main room, I had like my TV or my code, and when my friends come to my home, I have like a camera recognizing them, and then my assistant say, "Oh, welcome back! You're here again." So make some jokes and everything. So it was like, okay, this is nice. So I built this project. Let me show you in practice. It's working. So here I have a Raspberry Pi inside the beer can. Okay. The powerful one that I told you. In this case, I have other one with a camera, and then I have the project running inside the Raspberry Pi. So I'll take the picture right here, and then when it recognizes my face, it will go straight to the beer can and say, "Welcome back. Whoa, that's so nice to have you here." So I actually the hardest part of this project was to turn on the LED. It was great for me to understand like this. The other project I faced was I got from the movie The Purge. The Purge, I saw some kid controlling like a robot, this mad robot, and I was like, what if I try to create something similar? So this is my version. I have like a doll head here, and I have a microcontroller, and I actually hacked the PS3 controller right here, the joystick controller. Okay, so let me show you working. So here I will just turn on the controller. I have some like the power bank right there, the energy supply, and everything working by the Bluetooth, right? Okay. Well, and the other one was to control my door. So I was like, oh, what if I have like an interface? So I'm gonna show in deep dive this screen later. But I will press some buttons, and then you see like some LEDs changing right there. And then when I press on the interface, I can go through my door and I can see the door is open. Oh, very nice. So when you have like a big house, to walk through the whole house just to turn like the off, just to open the doors, it's crazy, right? But wait, before going through this presentation, I should warn you something. Like, if you live with someone else, or you're married, or you have like someone living with you, this kind of experiments might be hard for you. Okay, for me was because on the weekends we can face like the dinner table like this, like how messy, a lot of harder stuff, a lot of wires, a lot of friends coming at home. So this might be crazy. Okay, so let's go to the main idea of this presentation. Okay, how I actually did something to more than just doors, something like smarter. First, I moved to a bigger house. And I have a huge problem. Like every night, I have to walk through my whole house to turn off all the lights. So I was like, I'm a programmer. So what if I just make something smart to turn on and turn off? So I decided to hire someone to make this whole automation for me. And a friend of mine just said, man, I'm eager to help you to understand how you can make it and how it could be fun. I was like, very nice. So he started actually playing with me. And the first thing we were trying to do was to control like the light switches on each room. So I have the light switch right there. And for each button, I will have a controller controlling it, like sending energy, turning on or turning it off. Okay. So here I have the microcontroller. The microcontroller, we use a relay module. And for each button I have on the light switch, the ESP8266 here will send commands to turn on and turn off. Okay. So for each pin I have there, I will change it and make it working. I will show in practice in a few minutes. Okay. Well, just turn on and turn off wasn't enough, so I decided to add more sensors. So I had a humidity sensor and a temperature sensor to get to know how is the ambience, the environment as well. And I put a light sensor detector to get to know whether the light is already on or off. So it might help me to make some decisions whether I have to turn on or turn off. Okay, this is how it's working. My wife was so pissed with me because of all of these wires, but it's actually an MVP, right? It's like just the first version. But look, it's working. Oh, turn on and turn it off. There you can see the microcontroller, the relay, and everything. Well, I decided to like the hardest part of this kind of project. It's how you can hire like this whole cable, right? The wires, and it's kind of crazy. And I'll show you the most expensive piece of this whole project. Yes, the box. To hire the whole thing, I bought some boxes from like air conditioners to put all together, and I was like, this is expensive, but it's just to make my wife happy right now. Okay. But then I think she approved. I saw her trying it out and publish on her Instagram, so I think she approved. Very nice. Okay, in terms of tech, all of this project was built using C++, and I used the Platform IO. The Platform IO, it's amazing for us to help us to deploy code, to help installing dependencies, deploy it on microcontrollers, access it like through the internet, and it's so amazing. Right here, I have like a config file that you can put all ports, what is the framework you want to use, the speed of monitoring, but this is just detail, okay? Don't take too much on it. Well, I'm a web developer and I like to test stuff, right? So imagine I have here, oh, it's not near here, but imagine, so we have like the sensors right there. Imagine if I unplug some connector, put it on my wall, how do I know if the sensors are being caught, right? How do I know if the whole infrastructure is working? So I built an integration test. So I get the whole suite to run on my the whole prototype, right? So I got all of the data sensors, everything coming from the sensors, and then I can say, okay, if the test passes, now I can actually deploy my whole code. It's just a CI, right? So it's the same thing that we do for web development, but it's on hardware stuff. So pretty amazing, right? Okay, so as a developer, I'm a lazy person, right? So I've been using Node-RED, which is a low code platform that you just can drag and drop and create a server, sending data, create a front end in just a few minutes. This was one of the coolest stuff I ever learned, because it's just drag and drop stuff. You can just make sure. In my case, I could take a look more in the wires in hardware than creating APIs to consuming data. Okay, this is how my infrastructure is looking right now. So on the left side, you can see the whole flows I've been using here on the Node-RED, and the right side is the front end. Actually, my users, like my wife or friends that came to my home, will access. Okay, let me show you something here. Well, here I have the menus. Each one of these one will be like a different room for me, and I'll go to the main room. So here you can see that I'm getting the data from the temperature, the humidity, and I have some buttons for the light switch. Right. So when I click on the buttons, you can see on the left side, it's just like mirroring. So I can see in real time what's coming to the Node-RED side. And then here I have every flow. So when my microcontroller sends, like receives a data, I'm just logging it. So I'm using here the MQTT protocol, which is a lightweight protocol to controlling IoT stuff. And right here, I have the other flow, which is for the weather. So I caught the data from the channel, from the messaging channel. I'm parsing the data and sending to a component on the web. So see, there's no JS code here. There's no any code here. I'm just grabbing some boxes, putting like changing only the data, how it's coming, parsing data, but the whole functionality, it's working in production with no actually infrastructure code, right? Nice. And the last one, it's a bit of the spoiler that I'm gonna show later. But here I have some of the logs when someone triggers the light, and I have a people counter to like get to know when the light will turn on or off. But this is for the next steps, okay? Well, I figure that I created a new problem. It was working. Like my wife was like, man, I'm pressing the button on the light switch, it's working. Right now, I have like the whole food, I have the plates, the cup, like the drinkings, and I came to my main room. I had to put everything on the table. I have to get my phone, connect to the internet, open the app, and then press the button to turn the light on. So this is not smart, right? It's just something that's not really automated. So I was like, no, I should make something to turn on and turn off lights like automatically. So I don't know, I don't want to like open the app or even send commands. Okay, so this one is my little brother, and we were testing this experiment. So this, I had like a ultra sensor to get people, to count people, whether it's getting in or getting out. But I figured a lot of problems right here. First of all, we know that software development or hardware developer are not as easy as we think, right? We have a lot of problems, and we have to figure out how to solve the problem. The problem with this sensor was it was sending signals to my walls, and it was reverberating. So my wife is afraid of ghosts. So she was like, oh my God, why the light just turned on? Like, is there someone here with me? So it wasn't so good. So I decided, no, okay, let's using like some powerful stuff like machine learning or anything more, just for me to learn something new, right? So this is the ESP32 cam. and it is just a camera, right? So it promises not only to detect your face, but also recognizes that you are you, right? Oh, this is nice. So in this case, I did that first POC to take pictures here and send to my Node-RED. So here you can see it recognizes my face and the Node-RED really working well. Perfect. But still, I was like, C++ is hard, man. C++, I'm not a C++ developer, as you can see. I was learning on Google, getting some tutorials on the internet, but like memory leak, memory handling, pointers, it's kind of hard to understand in C++. And I was like, I think I've been spending so much time in like easy stuff. Like I just want to turn a LED on, and I'm struggling a lot. So I was like, what if we can use JavaScript to make the whole thing working? So I started like researching, and I found out the Johnny 5 library, which is a very popular library there. But the problem was the Johnny 5, you must be connected to the USB all the time. I was like, I don't want the USB because the microcontrollers goes to my walls. So I have to control it through the internet remotely. And then I found the Espruino. The Espruino is amazing too. It's a JavaScript interpreter, very, very tiny to run on the boards. And it could help a lot you to deploy code and actually do all the stuff like dragging drop. And this is so, so cool. And it's even cooler because it's so small. You have like 128 kilobytes flash and actually 8 kilobytes RAM of usage for it. So you can do a lot of stuff using actually JavaScript on your microcontrollers. No C++ required. So I decided, let's rewrite everything again. Let's just do from scratch. So I just got to the Espruino library, and I was trying to reproduce the same data, and then I figured out some code like this. So I was enabling the people counter sensor right there to turn the lights on. I was sending health check data to get to know whether the sensor was working fine, and then the light density, and so on. I was like, okay, everything good, let's deploy it. When I press deploy it, I just saw a lot of errors. I was like, oh my god, I reached the memory. The memory is just on the limit, and I can't do anything more. So I was like, oh, this is Espruino fault. Oh, this is the microcontroller's fault. And then I figured a whole way to use it. So another friend just gave me the Franzininho, which is the microcontroller that I show you on the beginning of this presentation, with the powerful one, right? So it has more memory and more flash memory available to use. So now the integration is working as I expected. So this is the POC, right? So right here, you can see the microcontroller, and inside it, you have the sensors, and let me show you in practice it working. So here I have the whole Node-RED working. Very nice. Oh, very nice. And all the sensors are working fine. And then my POC was working, okay? So I saw like, oh, it's magic. Oh, everything's working with JavaScript. I don't need to worry with ESP, and it really worked fine. However, we know we have a lot of challenges working with this. But let's think that you want to get started, right? So to get started, you can go to the Espruino website, download the libraries for your board, whether ESP32 or 8266. And then you can do whether on your CLI or on your interface, right? So right here, I'm doing everything on the CLI. So I just downloaded all the binaries. I'm using the ESP2. I show the ports, and that's it. It just go and save your JavaScript interpreter. From now on, you just send JavaScript code, and it will work as you expect. And this you can interact with npm package. So I installed the Asperino package right there, and you can send whether the port, the USB port, or the DNS on your network. So this is for me a game changing. Or even you can use the interface. So the interface helps you to minify your code, to check it whether the syntax is right. The left side, but I mostly used on the VS Code side. Well, some challenges working with this project. First of all, the Asperino was built to work on Asperino devices, right? So they survive selling like hardware stuff and components. When you try to use like generic microcontrollers, as I did, you face some generic errors, and it's hard to get to know what's happening, and you don't have like 100% support. Well, the platform is there, beautiful, but there are a lot to improve. And I think we are, as community, we can help a lot, like with this generic errors, or give more support, or even improve the libraries. And the libraries actually, there are a lot of examples right there, but I can only examples on the Asperino website. If you wanna take a look on other websites, it's kind of hard to find it. So as community, we can build more and more examples to make it grow. And for me, was something like, oh my God, I'm trying to learn again JavaScript because it doesn't support async await, and JS API is limited. When you look website, you can see all of these dashes is like unsupported features. So you cannot use async functions, async generators, object entries, and so on. But it's like, it's not a big deal, right? So you can use callbacks in all of the libraries, and it works fine. Okay, we've talked about the benefit, the challenge, but the benefits is even bigger. So you don't need to recompile your code. Look how amazing it is. Because when you're working with C++, you have your computer, you have to work like code off the code, and you have to deploy the whole thing on your microcontroller and test it like in production, right? So here, you just send your code, and you can use it as an SSH. This is so nice. Remotely, you can send commands and get it in real time. You don't need to configure the over-the-air updates as we do on Arduino or ESP32 devices. It has a built-in feature that you can deploy over the network. And the Asperino helps a lot. The IDE helps a lot when you want to minify your code, verify stuff, and actually see the code running in real time. And you can reuse what you already know about web development on hardware stuff. Look, this is, for me, this is amazing, right? I really love to do it. Okay, so my final words for today. I've talked a lot about this project. This is not a tutorial class, right? So this is something to expand your mind so you can think about your life and how you can make more fun your whole life, okay? So first of all, use your current knowledge to make things work at your own home. It's different when you are building websites or web APIs, and then you start making like a car move, or just make your lights turn on or off, or making jokes for you, or even automating things at your home. This is a complete different thing. For me, programming tech was really a game changing when I was working with it. And actually, don't try just to like turn on or off like buttons. Try adding sensors and make decisions for the sensors. So it's like, oh, it's not cool for me if my room is like 400 Celsius. So maybe there's some problem, or something has happened here. So I can send notifications, or even turn my air conditioner on. So you can like expand a lot of your own ideas, right? And first of all, learn JavaScript, okay? JavaScript is it's not a language made for like web browsers anymore. It's not something to like create forms anymore, right? So you can use everywhere, and you can have really fun with it. And use Asperino a lot, because this is the only way we can improve the framework, the library, the interpreter, and we can make it really work fine, okay? Well, all my presentations are on my website. If you want to take a look, I think you can learn a lot right there as well. I have been speaking a lot about JavaScript, Node.js. I've been contributing to the Node.js core as well. So a lot of cool stuff going on right here. I'll put all the links on the end of this presentation as well. And I'll show you the best thing I've been doing right here. This is my first ever course in English. So it's a Node.js streams course. So the goal is to use the most powerful feature on the Node.js to make your life even easier when working with Node.js to process large amounts of data, terabytes of data, audio, video, and so on. Okay? So thank you so much for having me. All of the links, the slides, my social media are here. If you can, please take a picture, post it on the Twitter so I can get to know that you liked it, this talk. If you have some thoughts about this talk as well, please show me there. On this link, I put some references at the end of the presentations so you can learn even more. Okay? So thank you so much for having me.
Thank you, Eric. I think your presentation was the embodiment of everything that can be made in JavaScript will be made in JavaScript. So we have quite a bit of questions, and I think more will come up. But
Nice.
I'll already start with one. So the first one. If there is any way to automate without using the internet, only local system, in case the internet is off.
Yeah, actually, I'm not using the internet to do it. Everything is working on my local LAN, right? It's just the on my router, or you can even use. I'm not sure if I have any microcontroller here, but you can use the microcontroller as your internet network. Okay, you can put all of the all devices to connect on a microcontroller as the LAN, and you can use everything else. So yeah, you can use everything without the internet, but it's cool to show to your friends when you're outside, like it's working, right?
Yeah. Okay, there is another question. What are the cons you have been dealing with in your house, and does the local market cheap to buy these local boards and others? So
nice.
Is the local market cheap?
Yeah, actually, we've been buying this thing from AliExpress, right, from the China, because it's cheaper for us. But here in Brazil, the scenario is cheaper. Like if you want to build like if you want to buy a Google Assistant, or if you want to make your Google Assistant, you can spend less, like a half of the price. But I think the cons I've been dealing here, it's wiring, right? How to hide the wire, how to make my wife happy with everything I've been doing, because it could be messy. You saw some pictures, right? So this is, I think, the most thing. But I would say the hardest part for me is hardware. Connecting wires and getting to know, because I am web developer, right? So it's it's hard to deal with.
Yes, thank you. Here is another one. How do you connect devices with certain server, and how this differs from KNX?
Well, I don't know what is KNX, but I can connect them all via MQTT, or a WebSocket server, or even an HTTP server. Like for here, I have a server on Azure. I just made a VM right there. I put the DNS, and all of my devices will ping there and sending data there, and then there we can spread all the. It's the same idea of the web, right? It's the same idea of like an application running on the desktop. Doesn't differ anything from there.
Yeah, I think the KNX means to the Sprack protocol that is used in like bigger buildings. So instead of MQTT and so on, so there are some commercial like devices. So if you have, like, I don't know, a university campus to manage and like buy these kind of great devices, I think that's what they meant.
Nice.
There's another question, but I think you already answered it. So do you use any hardware like Raspberry or Arduino? I think the answer is
Yeah, actually, Arduino I don't use anymore because Arduino doesn't have Wi-Fi. Mostly of the components doesn't have Wi-Fi. So I'm into the ESP, which is a competitor. And the Raspberry, I was using the Raspberry Pi here as a main server, right? All of the devices were connecting on it, and then everything was working here. But the problem was the lifetime of my Raspberry Pi. I'm not sure if it was something that I was making by mistake, but it was like 3 months. It was just burnout, right? So I had to buy another and another. I was like, no, let's put it on the server on the cloud, so I won't be having any problem. So this is
Yeah, for me, one thing was a problem was the SD cards when they would just die after booting. I don't know,
yes.
some
The
100
Wi-Fi
times.
just died for a while.
Okay, so thank you for the very nice talk and for your presentation. I think there was also a question about sharing your presentation, but it's already you have already a link to it. And yes, so with this, we can, I think, transition to our next speaker.
Okay,
Thank you.
bye. Thank you so much.
Yes, we still have like 5 minutes before next speech, so we can do some kind of announcement and then we'll wait for Harshil.
All right.
Hi, everyone. Now we want to say a huge thank you to our platinum sponsors, Bright Security Labs, for supporting us and also for giving us the opportunity to share with you some free scanning hours on their platform. Now we will post a link in the chat, and be sure to go register and grab yourself free hours of scanning. And yeah, also look for announcement about a very practical hands-on workshop that we will have on 9th of June. So be sure to check it out when we have the announcement and register for that workshop, and have a great Node.js Summit.
Okay, so we have a few more minutes before we start the next session. So I just gonna use this time to plug and a short announcement that we actually have one more event next week. Yeah, we have a pretty busy schedule. So if you're like interested not only in backend but maybe in some front end topics, so we have a Vue.js event next week, May 25, 26. We have also junior track like today, so feel free to register if you haven't already. And there's also a senior track tickets, just like this event. We have a senior track for more advanced topics. So yeah, consider joining because yeah, that's what we do at Geekle. We do all kinds of events, not only the one that you are watching right now. And also 2 weeks from now, I know this is not as much connected as like JavaScript topics, but we also have Flutter event 2 weeks from now, which our organizer Anna is also doing. So she's pretty busy. But yeah, so Flutter Global Summit 22, also 2 days, 1st and 2nd of June. And also we have 2 more events in June. So we have an Android event. So that's also a bit far from Node.js, but still an Android Development Global Summit, same way, career track consider registering and maybe learning something new. And also we have a data science event. So we will wrap up like the first season, the first half of the year with Data Science Global Summit at the end of June. And after that, this event, by the way, will going to be a 3-day event. So we'll be having career track, then pro track, and then we'll also have a boot camp for the third day. Consider joining and taking a look what it has. And that's going to be the wrap up for the first half of the year. We'll return with events in September. But yeah, we'll have a few more minutes of short break before the next speaker.
All right. So our next speaker is here. All right. So now I present you our next speaker, Harshil Shah, who came today with the topic of role-based access controls, or RBACs, in Node.js. He is a technical lead with a demonstrated history in delivering digital products in B2B and B2C space across various domains, including healthcare, fintech, GovTech, B2B SaaS using full-stack JavaScript technologies such as React, Node.js, GraphQL, AWS Amplify, Next.js, and the like. He also spoke about the future of React.js with React 18 at the Elevate Tech Conference. And, well, welcome. So, hello, Harshil, and let's welcome Harshil for his nice presentation coming up.
Hey,
so how are
hi
you doing
everyone.
today?
I'm doing good. Hi everyone. It feels thrilled to be here again. I was a speaker at the React conference, React Global Summit too, I think a couple of weeks back, and it's great to be back here again.
All right, then I'll give you the floor. So here we go.
Okay. So I hope everyone can see my screen. So yeah, so let's just start with what the topic is. So starting with some introductions, I'm Harshil. I'm a tech lead here at Verdaccio Technologies. We're a product engineering firm based in India. We help startups build MVPs and products with the latest modern cutting edge technologies. So the topic I'm going to be talking about today is basically role-based access controls in Node.js. So the reason why I wanted to talk about this, the reason I want to enhance on this, I'll talk about that going forward. So basically, before we dive deep into why role-based access controls are actually necessary, one thing that we really need to talk about is basically how authorization and authentication work. So this is, I know this could be a bit fundamental for most of the people attending here, but just for the context of actually getting to the necessity or the importance of adding role-based access controls, it's good to have these points actually out there on the table. So starting with authorization authentication. So basically authentication is just the act of validating a person's identity. I mean, just to make sure that the person who's actually claiming they're actually verified that, okay, hey, you claim to be the person you are, and we can guarantee it. That's done through passwords, that's done through cryptography, passwords, or some kind of verification process that just verifies the identity of that person in our system. So there are a lot of well-defined and well-adopted libraries and processes around actually implementing authentication in Node.js applications. So there's JWT, there's OAuth, there's SAML authentication. So there's a lot of well-practiced libraries and well-adopted libraries that actually work with authentication for Node.js, and they're pretty intuitive. I mean, the first thought when someone talks about authentication, okay, hey, I can do JWT, I can do OAuth, right? So that is when authorization, the lack of importance to authorization kind of comes in. So what is authorization? So basically, let's say your user is authenticated, and we know, okay, we verified the identity of the user, we verified that the user is who they claim to be, right, through passwords or through some other ways of verification, right? After that, the permissions or the access to the different resources or the different functions that our system offers, the access to each resource and function, the act of securing that access to a level by adding permissions, by adding policies, is done through authorization, right? So all the users of the system do not have access to all the resources of the system. That's not ideal, right? That is where authorization comes into the picture, where we try to introduce some level of permissioning and policies that is going to allow users to actually that is going to allow us developers to actually add some kind of restrictions to how much of the access to the system there is. And it's a very, very important part of the security of a system, right? So in Node.js, coming to that, in Node.js, there is a lack of well adopted and well practiced libraries, or rather out of the box solutions that offer authorization. There's a serious lack of this. And the way it's done these days is that, so for example, other servers or other languages like Python or Django or Golang or other frameworks like Spring with Spring Boot security or with the Django out of the box authorization models, it's pretty easy to add authorization. It's pretty intuitive. But in Node.js, there's nothing which serves out of the box or serves it very intuitively to make sure that, okay, hey, this is how you add authorization to a Node.js server. So the need is actually to come up with such intuitive and well adopted libraries, or just bring about the awareness, so that when we build our application, it becomes very easy to actually add more and more. It makes it easy to add more and more authorization in a more intuitive and a easier manner. So just to kind of harp on what I'm going to be talking about. So some libraries that are actually that have actually been used, that are being used currently, which are not very well advertised or very well published, are the access control library, the node Casbin library. So Casbin's a general authorization library, so there's a node version to it as well. There's the CASL library, and a lot more which we will be talking about. So moving on to terminology. So terminology is basically, so these are just some terms that we will actually walk through, so that it gives some context before we can actually dive into a more detailed discussion about these are libraries that we're going to talk about, are these processes that we're going to talk about of adding authorization and RBACs or role-based access controls to our applications. So access control lists. So basically, there needs to be some configuration that tells your system that a user, or rather how much of a permission is actually acceptable to a user, or how do you define, how do you tell the system that, okay, hey, this user has these set of permissions for this resource, right? So those kind of permissions are actually grouped into a configuration file, or rather some kind of config. It could be a simple file, it could be something on a server, it could be something in a database, it could be anything. So that is how the way we actually talk about it is by the way we want to tackle it is by having these configurations. So starting with the configuration, the simplest form of configuration out there is ACLs, or access control lists. So access control list is, as the name suggests, it's just a simple list. It's a vast list that is going to actually tell the system, okay, hey, this user has this permission to access this resource. So it's a simple one-to-one mapping for a user to a resource, right? So for example, user 1 can only read record 1, user 2 can only write to record 1, user 3 can read and write record 1. So these are one-to-one mappings of this user to these resource, which is the record, right? So this is how we actually add ACLs. Now, ACLs are very difficult to maintain. Why? Because it will be let's say the application grows to a very, very vast extent. The application grows to an extent where you have millions of users, right? Millions of different users. So maintaining a single ACL could be very cumbersome. It could slow down the authorization process of your application. It could lead into a lot of maintainability or scalability issues. So that is why there are more modern ways to actually write or feed this configuration, feed this authorization configuration to your Node.js server, and those terminologies around those, we'll talk about that now. Policies. So earlier in ACLs, there was a one-to-one mapping of users to the resource. So how about we just define a policy? So policy is just basically, it's a set of permissions or a set of rules for making an authorization decision. So it's just simple set of rules. Okay, let's say, so this an example of a policy in AWS. So we have the secrets manager. So this policy just tells us simply that, okay, the read access to the secrets manager is allowed or it's denied, right? So it's a simple one line statement or an assertive statement that says, okay, read access to secret manager could be denied or it could be allowed, right? So that is a policy. A set of policies will actually help us. A set of policies can actually help us decide the amount of access that a user has to a couple of resources, right? Talking about attributes. So attributes are basically, these attributes are basically attributes of a user or some additional metadata that's attached to a user, and this attribute can tell this attribute will actually help the authorization engine to decide whether the user has access to a certain resource or not, right? The because how it works is that, okay, for example, the user's department is sales. Now there could be thousands of users that are in the sales department. So if I simply have an attribute by which I can decide that if this user has access to this resource or not, that's way more scalable and it's way more maintainable, right? So if I just say, for example, okay, hey, the user dot department is sales. So if the user's department is sales, then I can write a policy that can say that, okay, if the user's department is sales, give them access to certain resource, right? A role. Coming on to something more interesting, which is role, which is what we want to actually focus on going forward. So role is basically, how roles work is, role is a collection of policies. Role is a collection of policies, or rather, role is, in the literal sense, the role of a user is actually a set of policies that are attached to a single role that can decide whether that user has access to a certain set of resources or not. So it doesn't matter that who the user is, what is their additional amount of data metadata, but the role which the user has taken, that role is actually responsible to decide whether the user has certain kind of access to certain policies or not. So, And access controls, or rather the restriction and the permissioning of accesses to certain resources of your system through roles, or that is decided through roles, is called role-based access controls, RBACs. Decision is simply, it's a boolean value, whether it's just a boolean value. It's the response of your authorization system that's going to just tell you, okay, hey, if does the person have access or they don't. Okay. And user context and resource. So user context are basically, these are some additional set of properties, or these are some additional set of metadata of the user that may be fed to the decision or the authorization engine, which can help them decide if that user has access to a certain set of resources or not. Okay. And then some additional resource context. So resource context is basically the metadata of the resource that the person is trying to access. So maybe some metadata of the resource can help us decide whether a certain user has access to certain resources or not. So I'll move on to libraries and different services which we'll be talking about today. So currently the well-adopted libraries are these three, which are listed here, which is Passport, Casbin, and Asserto. So Passport.js. So basically, how Passport.js is a very, very famous library to actually add authentication, or rather add security to your applications, right? It's very well adopted. However, one of the caveats of using Passport.js for authentication is that you have to build the entire authorization from scratch, right? It has some utilities that help us, but nothing out of the box. So, for example, if I had to implement a role-based access control using Passport, I'd have to build an entire system about how to structure the authorization configuration, attaching roles to each and every user, creating a configuration which will actually which will actually speak about author which is actually going to speak about this kind of roles have access to these resources. This is the limitation of the access to certain resources. So all of that configuration has to be done manually if you're using Passport.js. So the reason why Passport.js is considered is because mass adoption is done for authentication for Passport. So it's a general mindset that, okay, hey, why don't I use Passport for authorization as well, which may not be necessary. You can always use Passport in tandem to other uh, authorization libraries. So coming to the one which we are going to actually discuss in detail going forward is Casbin. So Casbin is a very, very well adopted. It's fairly new. It's not as if we talk pure statistics and pure numbers, it's not as adopted or as downloaded as Passport is. But for pure authorization numbers, for pure authorization purposes, Casbin is a very well adopted library, right? It works on this. Also, authorization model of Casbin actually works on this PERM perm meta model, which we'll talk about going forward. And the config. So the way I said, what I was talking about earlier about a configuration file, or you need some kind of authorization configuration that needs to be fed to the system to be able to allow the system to decide accesses whether allowed or not. That configuration is fed through a .conf file. I'll come to that later. So the way actually Casbin works is that the configuration model, since the policies of how much access each resource has, or how much access each role has, or how much access each user has, all that is static, all that is actually pre-decided. It's pre-fed to the system by a configuration file and a CSV file with all the policies of the configuration. So all of that is done in a static manner, right? So which means that in case I want any changes to my authorization configuration, that will require a manual rebuild of the entire app. Even though the core logic, or even though the core logic or the core logic or the core engineering logic of the product is not changed, it will require that we will have to rebuild the entire application just to get the new authorization config in. So then, okay, so considering those setbacks, we're going to talk about Asserto. Asserto is actually enterprise grade authorization as a service. It's basically managed authorization service for enterprise applications. The way it works is that there is an on edge authorizer engine that is shipped along with the application service. So there is a separation. There is a sidecar. So just imagine the main vehicle is my application, and the sidecar is just a simple Kubernetes cluster that's just going to take care entirely of the authorization. So what this allows is that earlier we had the disadvantageous static authorization config. Asserto kind of solves that through dynamic authorization configs, which will make sure that there is a very slight millisecond delay to updating your authorization engines for your application. So I'm going to start. So just some kind of just some pre context before we actually dive into what before we actually dive into how Casbin works, is that we're going to walk through some of the methods of how Casbin works for ACLs and for RBACs and for ABACs, and then we're just going to have a small discussion about Asserto. Okay. Okay, so let's talk about Casbin ACL. So this example right here is just it's in tandem to how to implement a simple ACL or an access control list, which I spoke about earlier. How to implement a simple access control list with Casbin. So what is Casbin? Casbin works on a perm meta model. Perm meta model is basically policy, effect, request, and matcher. So coming to this part, so this is your model. This little configuration file actually defines how your how your authorization model is actually structured. So how this works is that there's a simple request definition. So we'll talk through each terms one at a time. Okay. So let's first talk about policy definition. What is policy? So policy definition is basically what we define here is a format. We tell the Casbin library that, okay, hey, this is how the format of the policy is going to be. When I actually define my policies, the first parameter will be the subject or the user or the role or anything for which I want to provide permissions for, right? That is going to be my subject. The object is the resource on which the person actually the object is actually the resource on which for which we want to decide the level of permissioning. And act is basically action. Action is basically so do they have only read permissions, do they have only write permissions to that resource, etc., etc., right? More often than not, there's also one more part, which is EFT or effect. So effect is basically, should they allow or should that be rejected? So by default it's always allow, because when we define our policies, we always imagine that, okay, this is the allowed list and not the deny list, right? So then we come to the request definition. So request definition is basically the same thing, that the how am I going to tell my authorization engine that, okay, this is how the request is going to come in this format. The subject will be first, which is the user or the role. Then will be the object, the resource on which we want to add permissions, and then the action, right? Then the effect. So effect is basically uh, going to help me decide. Okay, so let's actually go step by step. So I'll come to effect later on. So step 2. So this is how the policy file looks. So like we defined the policy definition here, in the same way we will provide the policies. So it'll be the subject first, which is John, the object, which is record 1, and the action, which is read, right? And like I said before, we can provide the effect. The effect could be allow, it could be deny. Same. So from the looks of it, like from the looks of this policy file, John has read access to record 1. John has write access. John doesn't have write access to record 1, right? Harry has read access to record 1. Harry has write access to record 1 as well. So coming to how this works, right? The implementation. So let's say this is the request that I'm going to send in to Casbin, right? So this request format is exactly like I have defined it here, that the subject first, then the object, then the action. So John is the subject, record on is the object, and the action is read or write, right? So that's going to be fed to Casbin. What Casbin will do is it will match if there is a, so the first part that happens is matching. So what matching is, basically what we do is we try to check if we actually have a policy which is uh, we actually have a policy which will actually return some kind of result based on the input or the request, right? So what does the policy say? The policy says, what does the request say? The request says the subject is John, the record is object, and the action is read. So then we have a matcher that returns a true or false. So how do we match? We make sure that r.sub is basically request.subject is request is the same. The value of the request subject is the same value as the policy's subject. Similarly for object, similarly for act. This can be changed as per your convenience, right? So what that will do is that'll do a one-to-one matching. Do we have a policy that says John record one read and read? Oh yeah, we do. So they find the first one, right? Then the next one is John record one write. Do they find, so they try to find through the list of policy. Do we have a John record one write? Oh yeah, we do. The effect will come to later on. So how is the effect actually calculated? So what we do is now we have two policies in our hand that says John record one read allow, and we have John record one write deny. We have two policies that are there are two policies that are actually fetched as a part of okay, I think someone's facing some issues uh, with the screenshot. So let me check if I can actually go to this little blog and okay, and I'm gonna zoom in. Yeah, I think that should be better. Okay, so okay, cool. So yeah, I was coming to the fact that the matchers, what do the matchers do? The matchers try to match the request with the policy document and check if there are policies existing for what the request has come in. And we found two policies. We found that John wants to read record one, John wants to write record one. The first effect is allow, the second effect is deny. So now what we want to do is that we want to, this policy effect will actually run for every policy that we found. Okay, so the first policy that we found, the effect value is allow. So that is how we checked what is the value of the effect. So the value of the effect here is, okay, e equals sum where p.eft equals allow. So what this checks is that from the policy found, what is the value of effect? Is one of the policies having the allow value? If that is true, we return true, which means that the first request out of these two was accepted. For the second one, the effect value is deny. So when they try to actually read through it, it gets denied. So which means that their request was actually rejected. So I hope that was clear, because it's gonna set the base for our next set of items that you want to cover. So coming to the next part, so yeah, this is the bare bones implementation of how Casbin works, where we provide a configuration file, a policy file, and then we do it. So all this may seem very vague right now unless we don't jump into the code. So we'll actually jump into the code. Yeah, before we actually jump into the code, the library that we're going to use is called Node Casbin for actually implementing this. But I think the Casbin people have been kind enough to actually give us an Express specific middleware for Casbin called Express-auths. So you can also use that as well, but we're going to try to implement it bare bones with Node Casbin. So coming to an ACL example of Casbin, right? So I think some people are facing some problems. If I can I? Okay. Can I download this in somewhere? Okay. Anyway, let's try to talk about this one. Okay. So yeah, this one actually talks about. Okay. So let's talk about how to implement ACL with Casbin, right? So the first one is model.configuration. It's going to talk about how we can. I mean, what exactly is the configuration that needs to be fed to the authorization engine for it to be able to make certain decisions. So it's very simple. It's what we read before. It's basically this. It's It's going to give a request definition that says there's a subject, there's an object, and there's a action. Policy definition is the same. The format of how the policy is going to be, it's subject, object, and action. The effect and the matchers. Okay, this is the policy. So what the policy is basically that Alice has, if so, okay, Alice, when she tries to get uh, when she tries to hit a get request to slash dataset one slash star, then she should be allowed to do that. Similarly, if Alice tries to post to dataset for resource one, she should be allowed access. Bob should be allowed complete access for all actions. Star means for all actions. He should be allowed access for all of these, right? And how do we prepare a middleware for it? So basically, we have our Express application, and it's very simple. What we do is do these enforcer. Enforcer is basically the engine. It's the engine returned when we feed the model configuration and the policy CSV to it, and it spits out the enforcer engine through which we can actually perform by which we can actually perform the authorization. So how that works is that initially we need to make sure that in the first middleware of our Node.js application, um, in the first in the first middleware, we actually want to make sure we get the username from the request token so that we can use that to feed it to the enforcer, and that tells us whether the access is allowed or not. So we do this little, so we're assuming that we've written this function called get username from token, which gets us the username. And then we have this very small middleware which is going to take care of it. So what that's going to do is that it's going to check enforcer.enforce. The first thing what we pass to the enforce function is the subject. So what is the subject? It's the username of the person who requested. Then we're going to pass the object. The object is the resource to which they want to access to. So what is the resource? The resource is the URL to which they want to access it. So what is the resource is the original URL that the person says, since this is a middleware level. And then there's the method, which is get, post, put, delete, any of these, right? So we pass that. So what this is going to do is this is going to check what it's going to do is going to try to match some of the policies. Okay, so if what if the username is Alice? What if the URL that they're trying to hit is dataset? So what it's going to do is it's going to check, and the method that they're doing is get. So they're going to check this policy file. Do we have one? Do we have one? Oh yes, we have one. So they found this one, right? So now they want to try and find the effect, whether this is an allowed policy or a denied policy. Since we haven't provided an effect over here, they just assume it's allow. So how do they check? They check it through the policy effect. They check that, okay, is p.eft allow, which it is by default, but since we've not mentioned explicitly as deny, it's going to return true, and then since we're calling next, it's going to allow the user to go to the actual URL. So this is how ACLs are implemented. Very simple. For every user, there's a one-to-one mapping to the resource. Coming to RBACs, RBACs are something more. RBACs are basically something more interesting. So how RBACs works is that along with my request definition and along with my policy definition, I'm also going to be showing the role definition. So role definition is basically at runtime when I'm providing the policy config or policy CSV file, I can provide a role along with it, right? So this P is person. So person Alice has read access to data one. And what I'm going to do is, what if I want to attach a role to Alice? Okay. So this role can be defined in underscore comma underscore manner. So that is exactly how the format that we follow when giving out the CSV file. So that's going to be through Alice has, okay, so the group that Alice belongs to is data to admin, and data to admin has read and write access to data to as per the policies given here. So it's pretty simple, right? And this is how the RBACs are configured for RBACs are configured for Casbin. So I've just given some examples here of person, but it doesn't necessarily have to be. If we want to scale it, we can just assign every user has a role, and we can just simply provide a policy for every role rather than for every user, right? So similar to what, so coming to the code, similar to what we had done for ACLs, is that instead of getting the username, now we're also getting the role. So to get the role, Casbin provides an API get roles for user from their username. So we provide the username and we get the roles to the user, and then this middleware is going to check either from the roles or the username. And similarly, we're going to pass the subject as the URL and the method as the request, right? And that's going to give us, okay, hey, that's going to check. Okay, so let's say if I pass data to admin as the role and data2 as /data2 as the URL, and what I want to do is a get request, right? So I'm going to pass all of that here. It's going to check it's going to check it over here. It's going to check if there's a policy corresponding to it. If there is a policy corresponding to it, it's going to check its effect value, whether it's a allowed or a denied value, and that's what we get from the policy effect value here. And it's going to return, if it's yes, we return, okay, hey, sure, why don't you go forward and you get access to the controller of this API, or else we just return a 401 unauthorized error. So coming to ABACs, so actually ABACs are pretty they're slightly complicated, more complicated than RBACs. So I'm just gonna give a very small example on their website. So I'm just gonna zoom in. I think some people are facing some issues. So yeah, so the way ABAC works is that our matchers earlier used to check if if I have to show a matcher from earlier, the matchers earlier just used to check that, okay, is the request subject and the policy subject the same? Is the request object policy object and the request action is there? If that is, this is how you match a request to a policy, right? This is how you match a request to a policy. But for ABACs, it's different. For ABACs, what we're doing is to actually be able to match, we're gonna match the subject of the request, okay, the subject of the request, which is the resource. We're gonna check if that is the same as some of the attributes, let's say owner of the object. So object could be, it could be a user, it could be a role, it could be anything. So if an attribute attached to that subject, which is an owner, if those are the same, that is when we actually match the policies. Now over here, instead of feeding a string to my enforce function, I'm going to feed something like a struct, or in Node.js terms, a class instance that's going to return an attribute that says owner, and that is how the checking will happen to a policy, and that's going to decide whether the person has access to it or not. So this is how ABACs are actually configured. And lastly, this is just a bonus. Library that I want to talk about, Asserto. So how Asserto works is basically and as I mentioned before, it's an enterprise grade authorization as a service, and it includes an edge authorization engine that's shipped along with the application. So basically, how it works is that this is your application. This is an edge authorization. So this is decoupled from your application. It works alongside your application on a separate cluster in your Kubernetes pod. Okay. And then the way it works is there's a control plane. So control plane basically is like an administrator tool to your Asserto, which gives you complete control to actually talk about which gives you complete control to talk about the other stuff. So yeah, I think control plane is basically going to tell us that tenant-based artifacts management through Asserto can be done directly through the control plane. So yeah, this was Asserto. You can visit asserto.com for more. And yeah, I think that was it from me. I really thank you all for actually joining my talk. I hope this helps you add authorization to your applications easily.
Thank you, Harshil. So for the very nice presentation, we have a lot of questions, and which is a good sign. But sadly we are out of time. So would you be then? Well, we have still 3 more minutes actually. So I will then ask 1 or 2 questions, and the rest we can then do it on the chat. So, okay, then I need to pick one. So, well, there is a double one here. So, hi Harshil. I know the situation when we are logging into GitHub or other sites. If we open DevTools and look into requests on network tab, we can see our credentials, login and passwords. Do you know a way to avoid this?
So I think a very so I this seems unrelated to what I actually was trying to say, but okay. Anyway, so I think the way to do is that you can easily so there's this function that the browser allows, window.a to b. It kind of base64 encodes your passwords before you send it, and on the server side you need to base64 decode it. So in that way, I mean, in that way, when you're designing your own applications and there's an authentication flow that's involved, the best way, if needed, you can always base64 decode it from your browser, the passwords, and you can base64 encode it from the browser and you can decode it from the server side. So that way, during the request, if you see the dev tools, you'll just see some jargon text which cannot be decoded, which can't be decoded.
All right, thank you. Then there's one about Caspen. So can Caspen read policy.csv from database or at runtime?
Yes, absolutely, you can. So, the good practice that generally people follow is that they store the policy.csv file in a database, and before you, I mean, at the time of spinning up your server, you can obviously read it from the database and feed it during runtime to the application. So it reads strings, it can read a file system. There are different adapters as well for for different databases that can allow reading your policies CSV and your authorization models from a database.
All right, thank you. Then I guess that will be the last question. How to efficiently link RBAC roles to database entities?
Yeah, so I think the linking part is exactly what the authorization model is for. So your database entities are actually accessed through the database entities are actually accessed through your APIs, and the examples that I gave made sure that we secure these APIs through your authorization models, through defining a very good authorization model and feeding it good policy configurations. But also, if you want to add an additional level of security, you can always add another additional column, which makes sure that at runtime through decorators or through middlewares, you can always check if the request is actually allowed to access the application.
Okay, thank you. Yeah, so there are still 3 more questions that we will, I guess, post to the chat for you to answer.
Yeah.
Well, thank you very much for answering your questions and for the very nice presentation.
Thank you so much.
With this, I think it's also the end of my term as the moderator. So it was a pleasure to moderate these 3 talks. They were all very amazing from very good speakers. And I'm also happy to have the privilege to moderate them. Right, so with this, we will have a 10 minutes break, and then we will have our the next session of the day.
OpenTelemetry is the game changer here because it's basically created a lingua franca for observability. So until now, the way it worked is that if you did a vendor implementation, they would give you an agent to install in your environment, and they were in control of that, and they would collect the data from your system. With OpenTelemetry, you are using an open source technology that you can configure yourself, and you can decide what you want to send, whether it's to a vendor or a third party, or collect it yourself and analyze it yourself using open source tooling.
Hey everyone, and welcome to our next block of talks. My name is Paul, and I'm going to be your moderator for the next 2.5 hours. And the next speaker that we're going to have is going to be pre-recorded session from Rasmus Bay, and the talk would be absolutely awesome. So we will listen about. So we would kind of have an introduction to machine learning with Node.js and TensorFlow.js. So stay tuned for Rasmus's talk. And yeah, I'm excited because I love machine learning. And if we can do it now with Node.js, that's awesome.
Hi, my name is Rasmus, and I've been super excited for this talk. Data is everywhere, and doing something useful with it, like making machine learning models, is something that is not only fun, but is super useful. And in this talk, we're going to see how we can use the broader Node ecosystem with TensorFlow.js and also another package from the Node ecosystem. We're also going to go through the broader machine learning methodology so that not only you know from this talk how you go through this example that we have here, but you also know how to tackle other machine learning problems that you haven't seen, and also other kinds of data that you haven't seen before. It's going to be fun, and I hope that you're as excited as I am. And first, a little about me. My name is Rasmus Bay, and I live in Denmark, and I love to build end-to-end solutions. I love to go in the front end and the back end and augmenting those solutions with machine learning or any kind of data science or data-related work. And what enables me to do that is being a freelancer and working for interesting clients. So firstly, who's this talk for? This talk is for people that are interested in machine learning, those that are kind of on the fence of whether they should actually invest more time in it, because they either have preconceived notions of it, such as it's too hard, it's too difficult, I cannot do it, and stuff like that. It's also for the developers that are working with the backend every day and might be thinking of adding machine learning capabilities to their current stack. But as the first point also could be, they might not be aware of what is actually involved in the process and might be scared of that. But we're going to take all of that and we're going to make sure that you have the foundation so that you don't have those preconceived notions that make you avoid machine learning. What is included? As I said, the broader strokes of the machine learning methodology. The thing is, making models has a methodology, but all the different steps that could be available to us will not be displayed in this talk, since each of them could have a talk in its own. But we're going to walk through what the methodology is, so that even if you have data that is more problematic, or you have data that you haven't seen before, you can still do something with it. So this is kind of what we're going to go through. We're going to go through what is machine learning. We're going to go through what is machine learning broadly, and also what are neural networks that we're going to focus on specifically. We're also going to go through what are the tensors, because tensors is the backbone of TensorFlow.js. We're going to go through what are the different data preparation steps, what is modeling, what about prediction and serving the model. We're going to go through all of that through the PowerPoint first, and then we're going to see how it actually translates into the code. And then I'm going to give pointers on where to go from here. So if that sounds good to you, then I think we're just going to get started. So what is machine learning? Machine learning kind of replaces I wouldn't call it the old way, but a way, and that way would be, for example, a rule-based approach. So you want to render some categories and you have a lot of data, then you can make rules yourself, hard-coded, that can mimic kind of what you want to categorize. Making those rules yourself can be super complicated and error-prone, and also sometimes making those rules yourself can just be a huge task, because the function that you're trying to approximate with those rules might not be the accurate assumption. Maybe you've only looked at part of the data, and maybe you've not looked at everything. So you might be biased yourself. But basically, machine learning is about having an automated way of making those functions so that you don't have to make those rules yourself. You can train a model to understand those rules based on the data that you give it. And in this picture here, we have a neural network. A neural network is based on neurons. So it kind of, a lot of people say it mimics kind of the brain, because if you have different neurons they fire depending on the input that they get. So basically, a neural network is a big function approximator. You can see based on which ones fire and which ones don't, and what input they carry with what weight they carry throughout the different connections. You can have a lot of different functions in this network. And that's what makes them so good at categorizing different things like pictures, text, and also tabular data that we're going to work on today. So in each neuron, we have, like the weight coming in with the input. We have the different biases in each neuron, and we also have the activation function, which is what is going to make it either fire or don't fire. So that was kind of the little introduction. Think of it as a really good function approximator, right? And the good people at Google from the TensorFlow team have created kind of a little playground that you can see kind of where what the neural network is doing. Here we have the two inputs, and we have 4 neurons in the hidden layer, and then we have the outputs. Also, I've chosen one that kind of, takes a lot of epochs in order to get the required result. And this is also kind of part of the machine learning method. First, I go through that one, and then I tweak it, and then we go through a second one, and we get a better performing model that takes less time to be good. And that's also kind of the takeaway that I want to give, that it is not an exact science in the sense that, oh, if this is your case, then you always do this. It's always an R&D process, and tweaking the model is something, and coming back to it after you've seen how it performs, tweaking it again is something that you're going to have to get used to. You're going to have to get used to a lot of failure and a lot of going back and forth. So you can see here, the first run took kind of a long time, many epochs to kind of get into the shape that we wanted. We change it, and then we see, okay, does that have any kind of impact? And we see there's a lot of impact. We could also move on and talk about the learning rate. Should we change that? Do we learn too quickly or too slowly, or what do we do? Next up, we have tensors. tensors are really good use case for what we want to do. The thing is, in this in this space, we have to do a lot of calculations on a lot of data, and you can think of these tensors as a programmer just another data type that makes it really fast to calculate many things, and especially when you have specialized hardware like GPUs and TPUs, we can do these calculations super fast, and that's also what we need to make it feasible to make these models. So here you can see, this is from the documentation, you can see that we have, it's just kind of another data type that we're working with. And it seems very similar to an array where we have right now different kinds of arrays. We have different kind of ways that we can represent them. Now we come to data preparation, which is where data scientists spend the most time, because getting your data ready is a crucial task, and it's also a really time-consuming task depending on the kind of data that you have at hand. So here the first point is missing values, for example. If you have missing values in your data set, how do you treat them? Do you remove them from the data set? What happens if you remove them? Do we remove too many if we have missing values? And also, is there a pattern in the data that has missing values? Because if there's a pattern, that's probably not just a good thing to remove them. So do we impute them, and how do we impute them, and stuff like that? Nothing is right or wrong, but you can experiment with different things in order to get the desired result for your use case. Then we have normalization. A lot of machine learning models benefit from having normalized data. So meaning having the features on the same scale. That's why we can, for example, do min-max normalization to get them between a threshold, so that they're on the same scale, like between 0 and 1. One-hot encoding. If we have, for example, a output layer that has like 3 categories, then what we'd want to do is, instead of having 0, 1, 2, or 1, 2, 3, we'd have one of them in an array is 1 and the rest are 0. So depending on which one it is, either 1 and then rest of 0, and so on. Feature engineering. Sometimes it can be really useful to massage the data and generate new features based on the data that you already have, that can help the model. And then also training and test set. Training and test set is crucial in order to see if the model that we've trained actually performs well. Because we train the model on some data set, but we only really know whether it's good when we have included, when we have tested it on data that it hasn't seen. Then we can see, have we overfitted it? Has it learned too much? Because if it's only good at predicting something that is already seen before, it's not really useful. And in this case, we could also have divided the data into 3. So we have a training set, a validation set, and then a final test set, in order to make really sure that we have a good model. But it also, of course, depends on how much data that you have. And the list goes on. This is not an exhaustive list, but it's kind of the good few key points in order to get you started making great models, making data preparation for great models. So the modeling part. This is where we define the model and we train it on the data. And this is where we have the different parameters that we can customize. and depending on each model, there are different things that we can customize, and we can also automate the customization of these, trying different things, seeing how it plays out in an automated fashion. You don't need to know the math in order to actually develop, define the model, train them, and stuff like that. But knowing the math behind the different models is super useful, because you can have an intuition, you can have that context, that background knowledge that makes you more aware of what the different models need and the iteration of the ideas that you have, customizing each model differently, is what can get that extra juice, that extra performance that you want. So, and also it's fun. Maths get a bad rep, but it is more fun than it sounds. Then we come to the prediction. As I said, this is where we use the model to predict on data that it hasn't seen, and hopefully here it performs well. Because if it doesn't perform well, then it's back to the drawing board. Do we have enough data? Do we have the data that we need? Is the data bad in some way? Is the model bad in some way? Like, everything is into play. We might not have the data that we need in order to build the model that we want. That is completely possible. So this was kind of the whole flow. We prepare the data, we build and fit the model, we evaluate the model, and then we go back and experiment. And preferably, we'd do that with multiple models, and see which one is the best. And sometimes we even want to chain those models together to make a more robust system. Maybe we don't want to rely on one model. Maybe we'd actually use different models at the same time, in order to make sure that we have a robust system for many varied use cases. So, as I said, it's not, we never know what's going to work the best, but we can go back and we can test it and we can see, kind of get a feeling for what works really well. And then we come to serving the model. This is where, in an API, that it comes out and it lives. And this is the really important point. And without this point, then, it's not all that we've done. I would not say that it's been in vain, but this is where it gets fun. So let's see. So here we have, now we jump into the code, and for time's sakes, we're not going to go through the data pre-processing in detail. But here we have the iris data set, and we can see we have some different features, and we're going to predict we're going to predict from some data the different flowers in the iris data set that is depicted here with 0, 1, or 2. And in order to be able to do that, for example, with the TensorFlow dataset, we need to get them ready, and we need to get them into the data format that we need. And when we've done that, then we're actually ready in order to fit the model. But for time's sakes, you can look at the code and then you can get a feeling for, as we've also said, as I've also said in the presentation, what kind of steps, for example here, the one-hot encoding, getting into the right format, those are the things that are super important. Of course, we don't have missing data here, but for time's sakes, we're just gonna keep that short and get into the modeling. So here in the model, as I've said earlier, there are some things that we need to define first. So the first things that we're going to define in order to make our model is the learning rate and the epochs. And this is also kind of the place where you can be creative, and see, okay, what kind of thing works for this kind of data set. And then we're going to go in and define the model. And this is here where we have the different layers that we're going to have to define. And we do that here, and we do that with the activation functions and so on. And you could also, it's always nice to have the model summary. And after this, we have to also compile the model and see how we also implement the learning rate, because right now the epochs and the learning rate. Right now we've only defined the architecture, not how we're going to actually compile the model. And that is how we do it here with the learning rate that we can also customize. And now we're actually kind of ready to start to train it. This we're just going to use for getting more output. For time's sake, we're just gonna go down here, and now we can actually, fit the model to the data set. And here we fit the model with the training and the training data, with the variables, the measurements, and then the associated output, what we want to categorize. And then we define for how long it's going to take. And here, this one, even though we include it here, this is just for getting more information out of it, because this right here will not be used to fit the model. That would be catastrophic, because we don't want to use the test set when we fit the model. That's super, super important, because then testing on the test set will be of no value. So that's why we need to keep it out. But keeping it here in this format will not bring it in. So now that we have that, we can see that it's starting to train. And now we feel like a hacker man. We have lots of text in the terminal. We feel good about ourselves. That's great. But now that we have the model, we actually need to make the function where we can test it on the test data set. So now we just do that. We have the function here. And what we need to do is we need to take the model, and we need to make sure that we predict on it. Then we take the predicted values compared to the values that it should have been, and see how many we got right. And if we do that, then here, let's see, do we have the function there? Yes. So let's see if we do it again. We can see that here we have some output that we can work with, and that is amazing. What is important here is keeping everything in these brackets, because this one is especially, it's tidying up the memory is especially important when you're working not also Node.js, but also in the browser, because there we have more constraints than we would like. So the next thing would be to count them, and we can just do that as so. And then at the end, we could get the accuracy, and then of course also log it out. We've done it completely inside the tensor, or inside the tidy function. So hopefully everything should work smooth, and it does. So now we kind of know how to take in the model and the training and the test set, both the data and the targets. We also it's kind of the same method that we're going to do here, because here we basically took in the model and we predicted on the test set. So it's basically the same thing that we have to do here. So what I didn't do in the first model is of course always good to have a guard. So if to make it more robust. So if there's no model provided, we say, hey, you need to put in a model. The next thing would be to do the exact same thing as before. And that would be, taking in the model, predicting on the input array that we have. So taking in the model and predicting on it the input that we have provided, that we also of course need to convert into the right format, because we're working with tensors, therefore we need to keep it in the right format, just as we did in the data preparation. And when we have that, we should of course get a winner here that it's fairly confident about. So far everything is working well, which we're super happy about. The last thing that we're going to do is, right now in this directory we don't have any what we also want to do is we also want to save the model so we can actually use it, for example, in an API or elsewhere, because that's where it lives. We need to use it there. So we need to save both the architecture, the ways, everything. And we have a fairly shorthand function for that. So when we actually come to the bottom of it, we can see that it populates here. So that is amazing. Now we've both went through the data preparation, the modeling, testing on it to see what kind of accuracy do we have, predicting on a manual input, and then saving the model. And of course, this can also be done with other kinds of models in the Node ecosystem. It's not just the model that we have here with the TensorFlow.js. There are many models, and there are also many different kinds of neural networks. But let's just, for time's sakes, put in here another example of exactly the same thing: getting the data ready, defining the architecture, and then predicting on the data that we have, and then see how accurate the model is. So if we also do that for this model, we kind of get the same thing. See, here we get it into a confusion matrix though, and then we see how accurate the model is. So you can also leverage the broader Node ecosystem in order to actually make your models. And you don't have to use only TensorFlow. TensorFlow is great. You could also use TensorFlow for not only big use cases like having a lot of tabular data, a lot of complex data. It can also be a short thing, although it's recommended that the simpler the model, the better. So don't go overhand, and if you have a linear regression problem, don't go overboard and do a big neural network. Generally, the simpler the model, the better. Okay, so now we have seen two examples. How do we actually use it in practice? So here we're just going to have a really short and sweet example where we're just going to do two things, and this is nowhere near production grade. There's a lot of things we need, like schema validation on the endpoints, make it more robust, add TypeScript, stuff like that, that I would like to have on the Express server. But this is just to see, okay, how do we then, when we have produced the model, how do we load it in and actually use it? And here we're just going to load in the model that we have here, and then predicting is fairly straightforward, because what we're going to do is we're going to take it and you use the function that we've already seen, and then return that to the user. So here we have take the function that we've already seen, we've already defined, put in an input array, and then get the prediction and serve that to the user. And when we do that, we have here, and then we are going to take the other one and then see that we get a prediction back. And now we've come full circle. We've taken a model, we've taken some data, we've prepared it, we've defined a model, we've actually defined multiple models, we've saved the input, and now we're serving it in an Express server. So now we've been through kind of the life cycle, and there are many of these things that we can do better. Do better data prep. We can do better in multiple ways in this little project. But now you kind of have the feeling for the life cycle of this kind of project. So where to go from here? There are certain things that I would advise based on the limited scope that we've had here in this talk. And that would be go over K4 cross-validation, so that you're sure that the accuracy that you get from your models, that you can actually trust, so that you just didn't get lucky with the draw that you had. Parameter tuning. In an automated fashion, tune the different parameters that you have to make sure that you're actually getting the most out of your models that you can. MLOps is a huge topic in its own, which I also suggest diving into, especially if you're a developer and you have a little bit of DevOps experience and stuff like that, and you understand the different things, the components. Also, when you understand the math behind the models, you also understand why MLOps is super, super important. Complex data cleaning. Get the messiest data set that you can get, and then start cleaning it, start making it ready for the models. It's super important. This is where you spend the most time, and the better you are at data cleaning, the better your life will be. And finally, also experiment with other models, and also experiment with TensorFlow in the browser. You can also use this in the browser, which gives incredible flexibility when doing front-end stuff. So go wherever your curiosity is taking you and make cool stuff. On the TensorFlow YouTube channel, there are many people that have created cool things, and you can also see go on Kaggle, see what people are doing there. There are many communities with machine learning that are doing cool stuff. So I suggest getting inspired and getting your hands full. And that was it for me. I hope you enjoyed this talk.
All right. Pretty cool and interesting introduction from Rasmus. And now we will have, let me check with our team. I guess we have some free time for the Q&A, and I guess we have Rasmus live with us. How are you doing today?
Hello. I'm doing very well. What about you?
Doing okay. It was kind of, pardon for a slight delay, it was kind of unexpected for me because I knew that we have your recording, the pre-recorded session, and let me please check what we have as for the question for the Q&A sessions. So let me check. Yeah, we have them. Let me start with this one. How does TensorFlow in Node compare to other languages in terms of performance?
So there's like a couple of different aspects of it. So if you only talk about, like, let's say you've created the model, now you're serving it. A model is a model, so I wouldn't expect, when you actually serve the model, that there would be, anything of a delay or performance decrease or anything. I think, let's say you're serving the model, I think it would be much more interesting to get it as close to the device as possible. So, for example, if you have a mobile device, let's say convert that model so that it actually lives on the phone or lives in the browser or something like that. In terms of like manipulation, then I would, I think it's not where you should be the most worried, because these libraries are very optimized, and also you can have different strategies. Let's say you're working with very big data, you can have, like, just say a subsection of the data that is representative of the whole data that you're doing your manipulations on. And when it comes to actually building the models, then there are a lot of cloud solutions where you can throw a lot of compute at them. So the bottleneck will not be your computer or what the library is able to do. It will more be like, what are you most comfortable with? What are you the fastest with? So if you're faster in another language to do like the pre-processing, then you go with that, and then you can just build your model in Node if that is what you're most comfortable with. So I think, yeah, I wouldn't be too worried about that, the performance aspect.
Okay, and similar question. So could you please recommend, maybe there is some kind of tool or resource, or maybe some kind of service, some kind of program, maybe some SaaS solution which you can use if, for example, your computer is not sufficient for machine learning, and you basically don't have enough computing power at your disposal. Maybe there are some cloud solutions that can be used for that, or something like that.
There's very good integrations with Google Cloud. Also, since they're the ones making it, and just general any cloud solution would do. Like machine learning tools in general are like cloud agnostic, so you're not tied into Google's ecosystem if you don't want to be there. But if you are there, then it's super nice.
Okay, thank you. Okay, next question. Is the code that shown in the presentation available? So
I can get it available if people want. Then we'll figure that out.
Yeah, that would be awesome. So I guess okay, everybody, look for a post on Rasmus's Twitter. So if we can have your Twitter, or maybe
Of course.
your I don't know, maybe your GitHub or something like that.
Of course.
Or your Stack Overflow. So we will definitely share it in our profile, and we will tag you there. Okay.
Amazing.
Okay, next one. What would you say are the pros and cons of TensorFlow to other Python frameworks alternatives such as Keras, TensorFlow, or Flask Django?
I think it's also, as I've said before, I think this talk was mostly directed at developers that are kind of on the edge. They're developing on Node day to day. So I could say, for example, that there's a lot of documentation on. There's more documentation on these kinds of things with Python than there are Node.js. But putting in another barrier of, let's say you're working with Node.js, you've never worked with Python, then first you need to learn Python, and then you can try to do the cool stuff. So for this talk, I would say just get with whatever language that you feel most comfortable with, and there's documentation in both. Arguably, they're more in Python, and it's kind of like, let's say, the golden standard. But that doesn't mean that you cannot do it in TensorFlow.js, because people have done wonderful things in TensorFlow.js. So I don't think you should have that as a barrier of entry. Just get going, do cool stuff.
Okay, and we have one, I believe, second to last question. It's very sincere. I know it's hard to fit an introduction to ML in 30 minutes lecture, but I'm still really confused. What resources do you recommend to start learning about this? So what would be the number one go-to?
The number one go-to would be a really good book made by I guess she's a biostatistician. It's an introduction to statistical learning. It goes through all the math, all the things in a very straightforward way. There are a lot of tutorials. I would also suggest going through the official examples. I would suggest going through taking each of the things throughout the talk: the data preparation, the modeling, the prediction, and then researching them individually. What is most important is the methodology, less so the implementation in code, because that can vary from framework to framework. But just as like the general concepts and how to do it, then you can be framework agnostic. It's the same as, how to do backend, but you can do it in Node.js, and you can also do it in another language if you know the core concepts.
Yeah, and if you don't mind, please write the names of the books that you advised in our private chat, and we will post them. Or you can join us at our YouTube session, because we have at least 2 or 3 questions left. But also we have Zaki with us. We have the next presenter, and we already took 2 minutes of his time. So if you don't mind, Rasmus, please join us in the chat under our stream. And if you can name a couple of those books and answer a couple of cool questions that we still have there about what approach to take for those who are using JavaScript for machine learning. So we will be super glad if you can help us with that, tackle that.
Of course.
Thank you very much, and thank you for your presentation.
Thank you.
Okay, and we have our next presenter. We have Zaki with us. Hi, Zaki. How are you doing today?
Hey, hello, Paul. I'm great. How are you?
Awesome. Thank you for joining us, and thank you for an exciting topic, because we will be talking about Node.js, so Node and TypeScript. And TypeScript, my personal opinion, it's very cool and very interesting, and we kind of see it crawling all over the place. So we see Vue migrating to TypeScript, we see Angular migrating to TypeScript. So lots of things going on in TypeScript. And thank you for this exciting presentation. And without any further ado, the floor is yours.
Okay, thanks, Paul. Thanks. Let me start with the. So, yeah, I go. So my screen is visible, right? I feel like.
Yep.
Yeah.
We can see your screen. Everything's cool.
Okay, so here I'm introducing you guys to Node.ts. Basically, it's a made up name for me. It's Node.js with TypeScript. And as Paul said, it is a like buzzword right now, and we should know about it, how we can implement that. So a little bit about me. I'm a Microsoft consultant, and I'm good with .NET, Angular, and the front end technologies, and also started Azure and everything on the cloud also. So I also have this particular blog where I regularly post my content, everything regarding the web, cloud, and everything. Okay, so you can definitely check it out if you want to. So today's topic, I just want to directly jump into the coding and directly want to show the good stuff, because that's how we roll, right? As a developer, we like to see those creamy stuff, not the content, right? And over here, if we are talking about Node.js and TypeScript, I assume that you already know what how awesome Node.js is and what TypeScript is offering. But I just want to brief about TypeScript a little bit. And I'll start with this, and this is a topic I want to cover. I just want to highlight this thing so that people should aware where I'm going to stop. So we'll stop at the deployment. That's it. So before we begin, if I do something related to Node.js, I really like to put this slide on screen so that people can understand what it is and what Randall is actually talking about. So as today's technologies are emerging like day by day, and every 6 months we have something new, so it's very difficult to grasp everything. But at least we can push ourselves to understand the system at least. So here also we can push ourselves to understand how we can integrate Node.js with TypeScript if we want to. Okay. So let's see. I hope you guys enjoy and understand most of it. Okay, so before the beginning, I just want to let you know that you should possess this kind of skill: JavaScript, Node.js, TypeScript, Express, a little bit of it. I don't want at expert level of skill is required, but at least you should know what these things are, so that I can comfortably explain. So this is my expectation from you guys. So I hope that you already aware of Node.js, at least know what is TypeScript. I'll just brief it and little bit of Express, how we can actually run an Express server. That's it. So what is TypeScript? I just want to recap this one, and most of you folks already know about this one. And it's nothing but a superset of JavaScript where we get the cool stuff what JavaScript is lacking over here. So the main MVP of TypeScript is type safety, right? So JavaScript is lacking that at very great extent, and it becomes overwhelming if you're having a big team and huge number of people, and these JavaScript bugs goes to the production. It's really nightmare because of simple type checking is not there and all those things and compilation and everything. So we required some kind of assistance if we are talking about an enterprise level application. So TypeScript plays a major role over there, and it's been developed by Microsoft, and it's maintaining really we are getting every new version and every new cool feature we are getting over here. So we are having interfaces support code compilation, etc. So that's the coolness of TypeScript we talked about. And just a little recap, if you already know, and if you don't know, then you can see that this basic function is even, and it's a very difficult function. No, it's a very simple one. It's just checking whether number is even or not. But here you can see that a JavaScript syntax is actually extended over here. You create a normal arrow functions like that, number, and just returning whether it is even or not, or odd, right? Over here we are just specifying explicitly that number is a number type and it is returning a boolean. So this function returns a boolean and accept a number parameter. So here at the result also we are specifying explicitly that result is a variable which is basically a boolean. So any value assigned to result will not be accepted until unless it's a boolean. So here it's an awesome type checking over here, and you can see it's just a simple extension to your JavaScript, nothing fancy. So you can easily grasp it. And if you're coming from any object-oriented programming background where you have already type safety enabled like C Sharp, Java, and any other programming language, you name it, so you will get familiar very quickly regarding the TypeScript. Okay. Now, this term, like how is it really difficult to integrate TypeScript in Node.js environment, and how is it jamming, and like how what are the people's opinion out there? So it's doing amazing in Node.js world, so having no trouble at all, and people are really looking forward with this kind of architecture where Node.js integrated TypeScript from day one. So you can even see this open source project. These are the frameworks which are really very popular: Nest.js and Prisma, Adonis.js. These are the very good frameworks out there. They are totally based on TypeScript, and also big companies and open source project like tools and everything are they are going with TypeScript and Node.js together. And from my side also, we as a team, we also introduce TypeScript in our every project. Mostly every project we just go with, even if it is a small one or a big one, we doesn't care. We set up that in that way, and it helped us a lot in a bigger run. So let's move on and let's start the coding. So this is the session where I just start the code immediately, and I'll just explain from there, from that point of view. Okay, so let's play along with the TypeScript. So here we'll start with the very basic one. Like we'll first check whether we have Node.js or TypeScript installed in our machine or not. And if you don't have already, just go and install these two, and you can carry from there. And let me just go to the console and start doing these stuffs. So let me just do it for you. I'll just check this one for you guys, and there is Node installed in my machine. And let me just check whether my TypeScript is there or not. Yeah, so I have both of the things. You can check it and verify for you guys also. You can code along with me because we are not doing any great stuff away because as the time permits. Now we'll start with a directory from scratch. I'm just taking a blank directory for you guys so that you can understand like how we can become a zero to hero and how we can go till deployment level with a very basic application, but it enable TypeScript for us. Okay, so I'm just creating a project for you guys over here, and let me just open this up in Visual Studio Code. Okay, so if you, out of curiosity, if you want to know, I am just using Atom theme over here, and this is just a just an extension to colorize the window of Visual Studio. Okay, so let me just run the commands directly over here and start doing on this uh, folder. Okay, so initially I'll start with the TypeScript setup, then I'll go with the Node setup, and I'll go with the actual project Express setup. So in this way, I will just go through it. So right now we are dealing with the TypeScript activities. Then later on we'll go with the project setup, actual one. So initially you have to run this command dash dash init. So you have to first initialize your directory with TypeScript so that you will get a configuration file over here. So this is very important, and every project have this one. And this file is way too big, and there are lots of many properties over here. So basically a JSON file where you will have a compiler option, and these are the settings those control the TypeScript behavior, like what kind of level of type safety and what kind of type checking you want to have in your code, and what kind of engine you want to use, whether you want to go with a node kind of a modularization, or which version of JavaScript you want to go with. Okay, so here you can define it and you can control it. And this is not a thing which I can explain in 2 minutes or 1 minute. This is a big thing, but you can understand this is a configuration area where you can understand. And if you are having trouble with TypeScript, you can go and set up, tweak some of the setting over here, understand which setting you have to touch. It's a good thing. Right now, just to speed a little bit up, you can just simply remove all the comments and keep the default one. I'll just, for speeding it up a little bit, I'll just grab the correct one, the properties which actually required for Node. I'm just copying and pasting over here for the time purpose. Okay, so I'm just commenting these two right now. Let's see later on. I just want to show you what are these. So these are target, which specifies that which version of JavaScript we are dealing with. So EST 2016 features will be available for us. Module, which kind of module, like JavaScript modeling we are using. So we are using CommonJS because of Node.js mainly, and resolve JSON module is true, ES module interop, and all these things you can check it out, and those are amazing things. And here this one is important because this let us not transpile the file if we have something error. So it will not convert the code to JavaScript because we are having error. So this is a required one, so you can have this in the code. Okay, and resolve JSON module is something, if you want to directly get the JSON file in your code, you have to enable this one. Usually you can't require directly a JSON file, you have to do some other way, and if you do it false, it will go an error, give an error. But if you make it true, you can directly do that. So some of the things I just explained over here, strict true, that it will specifically check everything like what JavaScript use strict does. So fine. So let's move on, and let's touch the code base a little bit. So here I just have a code but I just want to do from here, so that you guys can understand. Now you have to change your behavior a little bit. You have to restrict yourself to create a .js file over here. You have to create a file called .ts. Okay, so let's create a basic function over here where we can understand how we can either write a TypeScript based code. Okay, so this is a function I want to create, and this function doesn't return anything. It takes a parameter called message, and the message type is basically I want to keep it string, and this basically print something on the screen. Okay, so whatever you supply it, it just console log on the screen. Okay, so let me just print the most developer friendly term, which is hello world. Okay, so let's run this code. So how we can do this, how we can actually transpile this code to JavaScript. So there's a basic command which is tsc. You just have to type it in your directory wherever you have. So make sure that you run this command wherever you have a tsconfig json file. It is required. So the first step which we done is types tsc init. Okay, so that was required. Okay, so now you can simply run this command. Okay, so it generates, it transpiles the code and generate an index.js file for you. You can check this one. It's the same thing, and you can see, as I mentioned, use strict is also enabled over here, and you can see the same code, but it's not supporting the type specification over here, right? So what it does is basically if you supply something else accidentally or intentionally, you will get particular error, and if you compile this one, you will see the error coming over here, right? And you can see this 100 is not gone to this one. Okay, you can see, oh yeah, because we are restricting that it should not go, it should not be transpiled to the actual JavaScript if we are having some error. Cool. So the basic error we are getting over here, argument type number is not assignable to a parameter string, right? So we have to provide hello world, that is what we have to do. Now let me just show a little bit more thing of TypeScript so that you guys can be comfortable. And before that, I just want to run this particular code, right? We haven't run this. So how we can do that? Basically node, and you can write index, right? Index.js. And specifically I'm saying that because it doesn't run index.ts, it runs index.js. So understand the concept that the Node.js doesn't care about TypeScript whether it is there or not. It simply demands the JavaScript file. So if you have a TypeScript file, doesn't make any sense to Node.js. It requires the JavaScript at the end of the day. And if you are already familiar with Angular and any other framework which are heavily using TypeScript in it, you can know that after you build the project, you will get a JavaScript version of it, right? So here there's the same thing. So make sure you remember that and don't mix up this thing up. So for developer development you require TypeScript, and for the production you require JavaScript file. Okay, so let me just tweak some of the more features of TypeScript. I want to showcase it over here. So let's say suppose I have a product interface, and in that I just have some ID, and let's say I want to have a name of the product, and let's say the price, right? So here you go, and you can create an object of type product. Cool. And when you define the type over here, you can get the intelligence, and the specific type is also shown here. So if you supply an integer number, you will get an error. Okay, so yeah, it must be string, and this must be also string, so whatever it is. And the last one is the price. Let me just give some dummy price over here. Okay, so if you make it string, you will get an error. If you make it proper one, you will not get any error. Okay, and let me just print this one product on the screen for you. So we have to do both the thing. First you have to compile this one, sorry, transpile this one, and then later on you have to run this code, right? Just do node index, right? You are getting the data. uh, you can also specify the type, like for example, if you want to show some type, you have a particular category over here. Okay, so category, I don't want to make it a string. Sorry, I'm doing in the wrong area, not here, over here. Okay, I don't want to make a category as string. Okay, I want to make it a type kind of thing where a specific value should be available. For example, I just want to make it cloth category and food category, and let's say what else we have, uh, medicine. Okay, so these are the categories I want to have. So we can, what we can do, we have created a type over here, and we can simply pass this type to this category. Okay, and whenever we creating this category, we will get the default values like this: clothes, food, and medicine. We don't even have medicines. We should have medicine only. Okay, let me just transpile this code again, and let me just run this code again. Once the transpiling is done, we can simply execute the code, right? Okay, if you're already familiar and know what is TypeScript, you might be aware of whatever I've done over here. So if you are new, then you got a chance to understand what we are dealing with, right? So let's move on to the slide. This is the same code I just kept over here so that in future you can understand from here. And let's move to the npm project setup. So now let's be a little professional and let's see how it goes in the real world project and how we set up the directory. That is the most important thing from the development perspective, and let's do that. So first thing first, we'll do the npm init part. So let's do this npm init. Okay. Sorry, should have to do the npm net y because I don't want to go with all these things. So let's say this node.ts and entry point is this. Test command is just right now. Keyword, let's say node.js, and let put my name. Okay, yes. Okay, cool. So we got the package JSON over here. Fine. And I just want to remove the index.js right now. I don't want to have it because I want to update my folder structure. Now let me come back to the ds config where I just committed this to directory. Now let me just explain what are these two properties over here. So this two properties are very crucial if you are setting up a proper project and big project. So you have to decide which will be the root folder, root directory where you want to keep your entire project code. Okay. So this area where I'm just specifying the source folder. Okay, like any other front-end framework, we have source folder where we have the actual project code, and we have a dist folder where we have the compiled JavaScript code, right? And this is the same pattern we also follow over here, just to make the thing consistent on the Node.js side also. So here we are having two directories. One will be the source, and another one will be the distribution file folder. If we have commented that one, so we have noticed that when we transpile the code, the index.js file immediately generated on the root itself, right? But we don't want to do that, and we can't we don't want to mess the root, right, like that way. So let's create two folders, and the second folder we don't even have to create, it automatically generates. So let me just move this folder, this file to this particular folder. Okay, so let's see how it goes, and the error also gone now. And let me just do the tsc. Okay, so you can see that this folder is automatically generated, and if you go to the index.js file, you see the code which you already had, right? And you can see that there is nothing like interface, nothing like type over here, because it is a TypeScript thing, right? It is not a JavaScript thing. So yeah, we are now pretty decent over here. Like we have two directories and we have to deal with it, right? And let me just jump back to this. We already ran the init command. Now let's be a little more professional. Instead of running this as a tsc and a node and giving the name of the directory now every time. So right now, how we can run this particular code if we have moved this to a source folder? So you simply have to compile this one, and in order to run this one, you have to specify the directory. So dist /index. That's it. You can able to run this one. So let's be little professional, and instead of writing this one, this command and this command again and again, I just want to create some kind of script in the packages and file, which I want to use within my project. Okay. So let's do this one, and I'll just go to the package.json file, and here, if you're already familiar with package.json setup, you can add your own commands over here. So obviously the start command I want to keep is the one which actually run the project. Okay, so this actually runs the project, right? So make sure you do that. And apart from that, I want to create my own command, and make sure you do this, make a build command. Okay, this is the reason, I'll just explain later on. Make a build command where I'm just building the project using tsc. Okay, so do that. And optionally, you should do this one because you want to transpile the project at project level, at the root level where the ts config is there, because it sometimes happen we might have multiple ts config file. So I want to do this at root level, so that's why I'm specifying this. So make sure you do that. This is a project level. You can even write project, so it defines that it's a project level compilation happening, so you can keep the flag also like that. Okay, so we got now two commands which can be run from npm, right? So let me just do this, run build. So it does the same thing. It transpiles the code and it generates the dist folder again for you. Let me just delete this one so that you can have an idea, like I'm just not mocking you guys. You can see this one. Okay, sorry, this one. So we got the transpilation done, and if I now run the project, like start, and now we can see the output over here. See, the hello world and everything is displayed. So this is a little bit more professionalism. Now you can imagine, like if I want to do some changes, let's say I want to make this a nullable. I just make the price as nullable, so we can skip the price if we want to, right? And I want to run again the project, so I have to run two commands. First I have to build this project, and then I have to simply start this project, right? So this is a big old days where we have C program where we have to compile and then run again and again. So you can imagine you have to work a lot of work to do, but you have to do this again and again. So this is not a healthy practice, right? So you have an option, and there is an awesome package available. Let me just go to online and let you know that dev ts node dev. This one is a very cool package which actually transpile your code automatically when you are just doing changes on fly. So it's just the same as node-mon. Okay, so there's a debate going on like whether this one is good or node-mon is better. So people say that, and I also personally feel that it is a very speedy one, ts node dev, as compared to node-mon. And this is actually based on two more packages like node dev and ts node. So it is a combination of these two packages and combined together. So definitely we can go with node-mon also, if you don't have any problem. But the speed actually matters, so it takes some node-mon little takes little time to compile the project. Okay, so so we'll use this one. So I hope you are getting the idea, like this will help us to watch on fly changes. So let me just demonstrate to you. So you just have to install this particular package, and then you have to basically create this kind of script and run the code. Okay, you can even do a shorthand also. Instead of writing ts dash node dash dev, you can write this code also. So it's a very small documentation over here. So let me just do this. Let me install the ts dash node dash dev. Okay, and I want to add this as a dev dependency. Remember that whenever we are dealing with TypeScript, anything related to TypeScript, it's always from the development front. Okay, so it should be a dev dependency. So let me just do this one. Okay, fine. And uh, let me just add one command over here. Instead of directly writing that command, I just want to have this one written over here, because in the latest Windows 11 you will get an error because you can't directly run anything which is not properly legalized with the installation. So these packages are not properly having credential and everything. These are MIT license packages. So Windows 11 actually makes some trouble, so you have to create the scripts and then you have to run. So make sure you do that. So node dev, and you have to respawn again and again when you do the changes, and which directory you do the changes is a source index.ts file. So you have to mention this much is pretty good, and you just have to run this command. Now run watch. I feel like we'll face some error. Yeah, definitely. I was waiting for this one. So it asks actually for TypeScript to be installed in your project also. So let's do that also. npm I TypeScript, and I want to make it installed as a dev dependency again. So whenever you do anything installation regarding TypeScript, make a dev dependency. So I hope you guys understand what is a dev dependency. It's a dependency which doesn't go to the production. Okay, so it will speed up a little bit when you build the code on the production. Okay, so now let's run the command over here. npm run watch. Yeah, so we are getting the data, right? And if I just want to add the price back again, so you can see I'm adding the price and I'm just saving this one. So we are getting the updated value, right? Cool enough. So this will definitely help us to understand better how we can code in an actual environment, right? So let me just speed things a little bit more because we are running out of time. So yeah, I just mentioned all the commands. You can go to, I can share this particular PDF with you, and you can go through all these commands which I mentioned. Now let's come to the cool part. Let's create some Express boilerplate code, and let's start from there. Okay, so definitely we have to run this two command. First, we have to install the Express package, and then this one. Yeah, I want to let you guys know what is this. So whenever you are dealing with TypeScript, you have to install a definition of that particular package. Okay, because by default, Node it doesn't support the definitions of everything. So you will might some face some issues understanding the package. So that's why every time you install something, make sure you add the types of that particular package. So you will find this kind of package for every available packages out there in npm. Okay, so most of them are having this particular types definition, but some of them don't have. So you have to create a file where you have to just declare the module over there. So you just have to install this. It doesn't make any sense. It's definitely type definition for express. So every package have this kind of, see, you can see over here, these are the different types packages over here. So you can think of this as a metadata. Suppose you are dealing with Java programming and you just go inside a predefined function of JavaScript. So you go to the inside of it, you understand whatever the metadata is describing about the function, you can know that. So same thing happening over here also. So let me just do this very quickly. So let me install Express in my system. npm I express, and I just want to do the another one is dev dependency. Make sure anything related to TypeScript should be a dev dependency. Keep a habit of that, it will be a good one. So types forward slash express dash d. Okay, let's just quickly put the I'm just erasing everything over here. It is there in the slides, you can get that from there. I'm just putting a boilerplate code which you already familiar of. I'm just copying and pasting, sorry for that, because this is a basic boilerplate code which you already know. And let me just walk through it because the time permits, right? With some changes, definitely I should mention that also. With some changes that you might not be familiar of, like over here, you can see like how the import statements are going on, right? We are mentioning explicitly this app is basically application. So here the TypeScript is actually playing its part. Okay, we are specifying the type specifically, and rest part is everything is same. Okay, you can touch base. This is exactly same code which you find on the Express website. Okay, so even you can remove this one because we are not dealing with any API kind of activity. Let me just remove this particular code, and we can get rid of this one also because we don't require to do that, because we are not properly creating over here an API. So let me just do this little bit more shorter code. So here what we are creating a simple get endpoint where we are having a request response, and we are simply sending this particular response to the page, right? And we are starting our server on this particular port. Okay, so bear with me and let me just run this code. So how we can do that? We have simple run watch command already in place. So let's just wait for the server to start, and let's see on the page how it goes. Localhost 3000. Yep. So we are having this up and running. Let me just stop this one. Sorry, I just wanted to show quick changes dynamically so you can have the fun. Node.js Express app, right? And let me just add two exclamation over here. I just saved this one, and I am just refreshing this page again. Yeah, so we are getting the data, right? Stopping this, and let me just do a quick deployment because I just want to make things a little bit full circle so that you guys can understand this one. So optionally you can create a repository also. Let me just do that and quickly create a git repository. And what are the options we have? But before that, I just want to create the git repository in front of you guys so that you can understand whether I just uploaded the code from where. Okay, so this is my personal account. I'm just creating quickly a git repository, and I just want to name this node.ts app, and this is a Geekle one. So let me just name it in that way. So Geekle node.ts app. Okay. So I'm just quickly creating this one, and I just want to speed things a little bit up over here. Now, one more thing I just want to show is that what kind of git ignore file we should have with this one, this setup. So definitely git ignore file should contains node modules, and then you should add dist folder over here because this folder is automatically generated whenever you code. So this should not go in your repository, in your project repository, in your organization, because it is not good one. It unnecessarily adds up a little bit weight. And also I'm removing this VS code. This is the extension folder created dynamically. Okay. Now let me just create the run this command git init, and I hope you guys already familiar all these commands which we have to do. So let me just do quickly git add, and let me just run this command from here. I just don't want to waste any more time of you guys, and then I'll just do this remote, and I'll simply use a master branch. Sorry for that, master. Okay, so you guys will get the code from here, and you can enjoy and understand how this actually you can have a better look. Now let's come to the deployment part really very quick. I am running out of time now. So what are the options we have? So the same options which we have with the Node.js environment, we have all the options over here. We don't have to do anything new over here. So Heroku, AWS, DigitalOcean, all these things works well. We don't have to do anything. Just the way how it deploys, just we have to understand that. I'll go with the Heroku because it's allow us to create at least 5 free applications, and definitely required to have a Heroku account, and then you have to create an app. And I'll go with the Heroku CLI upload part because I'm not sure the Git integration is working or not. So let me just quickly jump to the Heroku. This is my account. I feel like I'm already logged in. Yes. So I'm just creating new project over here, new app, and I just want to same that name it same Node TS app. Okay. I just want to keep it in Europe location. Create the app. Okay. So you can see over here, the GitHub Connect is also shown, but I'm not sure since last month it is giving some error and people are still struggling. This is not connecting. It's still showing this internal server error. I'm not sure why it is happening, but you can go the another way around. There is a Heroku Git, and you must have to have Heroku CLI. So I already have Heroku CLI in my machine, so it's a basic installation. You just have to run this command. Okay, I'm just okay. Am I typing something wrong? Okay, so I've been typing the wrong thing. Okay, so here I already have Heroku in my machine. What you have to do, you have to log in the system, and then you have to upload your project to the to Heroku. So make sure the git push is different and Heroku push is different. So I'll just quickly run this commands so that we can have a deployed project in front of you guys. So let me just do this login part. It's awesome. It's easy because it automatically opens the browser and do the validation. You don't have to type anything over here. So we have already logged in. That's why it's quickly do the login part. See it how it's automatically does that thing. You just have to click on this login button, and that's it. You're logged in now. See, and now you have to come run the remaining commands. So you have to be in the project. We are already in that project. You have to run the git init. Now remember that this git init is different. It is happening in the Heroku level. Okay, so you can see the command over here, Heroku git remote. We are setting the remote location over here. We are preparing for the remote repository which are there in the Heroku. So this is done, and then we have to simply command we do the rituals like we have been already did with the repository thing, git repository, and this command we have to just copy and paste and run that. So it's upload the project. Now this is interesting. Just see this one how it beautifully does everything. So because we have actually done the correct things, that's why it will not surely not give some error. Let's see. Hope, because every time we are doing something displaying something to the client, we get the errors. So right now I am expecting this one to happen. Okay, so the luckily I got the build succeeded. And see what has happened over here. Basically it runs this command, build command. I haven't personally told him to run this particular command, but it does, because Heroku from 2019 it does that. It internally runs this particular command. Okay, so it does for you. So what happened actually, it runs this command. So at the Heroku server, this particular disk folder gets generated, and what happens next is we basically it runs the npm start command. So npm start command, what it does, we already written in a way that npm start command looks for the disk directory, right? And it happens automatically, magically, right? We don't have to do anything new over here. So if you just go to this url, we might see this particular application up and running. Okay, so uh, that's the thing. We actually completed the entire circle, and I feel like I'm just 5 minutes more over here. I taken 5 minutes more, and it's the sorry for very quick go through for everything, but here I'm stopping, and it's time for Q&A. And let's see what you guys have. I really want to know and hear about it, and you can optionally follow me and follow my code omelette blog over here.
Awesome, Zaki. Thank you for your
Over to you,
presentation.
Paul.
Thank you for your presentation. Thank you
Sure.
for sharing with us some awesome concepts. And yeah, we have some questions. Let me pull up the first one. So the question is, everything about Node.js is quite clear, but what will you say about another Ryan Dale's child, Dino? It has TypeScript in mind, and a lot of things were already implemented. Last version of Dino is 1.21.3. So
Your
what?
voice is a little breaking for me, but I can see the question. I can tell you definitely. Randall actually switched to work on Dino project, but he assured us that Node.js will be there, and it is definitely there. And Dino support is not still there on many platforms, like Clouds is still not supporting Dino. But yeah, it's a the purpose of the idea behind Dino is the security reasons. So it started an entirely new project, but Node.js is already having a great community and still developing and improving. So I feel like it's not going anywhere. And yeah, TypeScript support was not originally there. That's why we have a kind of hybrid support of TypeScript like this. But definitely Node.js also promote to use TypeScript with the application, and Dino is like kind of a parallels of it. So optionally, maybe I can see the future of Dino, but we can't judge that, right? Technologies are coming, and every time we also have Python, we also have different technologies, so we can't judge them on the booth. But Node.js is there, and it will going to be there.
Thank you. And kind of similar question. So how do you think will the TypeScript be supported by default in Node.js as it is right now in the
Okay.
node. So what do you think?
Okay, so you can go to the official website of Node.js also, nodejs.dev. It's an awesome website, and you can see there they have also a topic where Node.js with TypeScript, and from there you can find the similar thing which I already explained. So due to the reason that Node.js base engine is running on the JavaScript v8, right? So it is difficult to integrate the TypeScript provisioning over there. That's why Dino is an entirely new creation of it. That's why it is easier to do that from a scratch. It's a new thing, but Node.js by default support of TypeScript, I feel like it's difficult. But in future, what I feel like they might have come up with some CLI commands using which you can do whatever we have did so far very easily and very smoothly.
Thank you. Okay, next question. Could you please explain why TypeScript Node Dev is better than standard TypeScript W per service watch output?
Okay, so yeah, this one is actually latest one. It's available. It's quite available right recently. That's why I just picked the one which has already been there a while. And this is a provision which is done by TypeScript so that you can preserve watch output of the folder. But we have to eventually run the code, right? And it is done by Node, not by TypeScript. So make sure that we have to keep in mind that Node actually runs the code. It is a watcher for the TypeScript project. Okay, it generates a TypeScript project, but it doesn't run like what we just saw now, right?
Okay, thank you. Thank you. Okay, next question. Some of the types are defined by type.
Okay, so this last one, yeah. So I just I just want to answer this one. It's interesting. So before that, we used to explicitly define every types, but going forward, the TypeScript also recommend to infer everything because if some function is already returning something, so don't create the type like what I just shown over here, like colon application, because it inferred that express is returning application object only. So you can avoid that. It's a good practice. But when you create your own function, you definitely have to define it.
Okay. So here's another one. What do you think about the status of ESM support with TypeScript no dev?
Okay, this one I have to like check it out and let you know, guys, because I haven't seen that properly toe to toe. So I have to compare them from my end.
So I guess this is second to last. There are a way to use TypeScript indirectly database with Node. I guess, is there a way?
Okay. I little find difficult to understand this question, like from which area it is hitting. But I feel like it's talking about directly TypeScript support in the database. I don't find anything like that. But yeah, if you talk about the database kind of drivers like MySQL, MongoDB, everything, we have kind of TypeScript definitions available, and we can have that particular support of TypeScript, a kind of way of writing the database related code in Node.js.
Okay. And the last question: Is there a difference? Is there a difference in performance between TypeScript and JS versions?
Hmm. No, absolutely not, because the final product will be the JavaScript only. So here it is only talking about the development front, right? What we are writing code as a developers, it is for our need, our help, and it's for our need, right? And everything goes at the end is JavaScript, plain old JavaScript. So it's you will not find any performance bottleneck, anything related to that, because at the end we have the JavaScript code. Yeah, in some cases we have to make sure that we have to, in very specific cases where we find such kind of problems, where we have to use proper typing, like we should go with enums or we should go with type, we have to then juggle in between those things. So it's very specific scenarios, not usually happens.
Okay, Zaki, thank you. This was a bliss for us. This was a super smooth presentation. Thank you for all the answers for the questions, and we're looking forward to have you with us next time at our next conference. And we will post your Twitter and all your social handles in the chat. So if you have any additional questions, Zaki, thank you once again, and we'll see you next time.
Sure, Paul. Thank you. Goodbye, all. Thank you. Have a
Bye.
good day.
Okay, so we have our next presentation from Juan Picado, and the presentation will be about how to improve your workflow with Verdaccio, your private Node.js registry. And from what I see, we have Juan live with us, but we have recording. So I guess we have a pre-recorded talk from Juan, and then we will have Juan for the live Q&A session. So let's check out the presentation by Juan.
Hi, my name is Juan. Today I will share with you how to improve your workflows with Verdaccio, your Node.js registry. So let me introduce myself. Yes, my name is Juan. I'm senior front-end engineer at Mobilidad Nadevinta, but in my spare time I do open source. I do maintain the Verdaccio project since 2017. I'm based in Berlin. So those are my social networks. So if you want to follow me, I will try to follow you back. So what you are going to learn today, I will share with you what's a Node.js private registry and why it's so important, and how does Verdaccio works. And then we will go through tokens and private registries, and we will do a lot of demos based on what we just learned in the first part. But let's start with what's a Node.js proxy and private registry, which you might have seen this image before, right? So it's really a fun image, which represent when you're installing packages and your computer is about to take off, and you wonder what is happening here, what is taking so long. This is what I will try to explain today. How the package managers speak with the registries. But let's start with the very default configuration of the package managers, because they speak with one single registry, which is the public one. When you're installing your packages, it's gonna use this connection, but this connection might be broken at some point, because for several reasons. Maybe the registry is not working at that moment, or they have some problems, or your network is not stable, or maybe your router is broken. There is a lot of reasons that can happen, and this might stop your builds to projects to be built, or your installing to be working, because if you cannot install dependencies, the install won't finish. So what's the recommendation here all the time is to having a proxy registry on the middle that cache everything you request. So the second time you are asking for the same resource, then the registry will return this cache information. And even if the registry is not able to speak with the original registry, it won't fail. So this actually give you some sort of level of trust in your CI pipelines, and this is one of the advantages that Verdaccio does. So how this works? Let me explain how this works. So let's imagine you have you are requesting for jQuery, one of the dependencies of your project, and the first thing that the package manager does is just ask for this resource. Let's imagine jQuery. jQuery will the npm will ask to the registry, the proxy, hey, do you have the dependency? The proxy will say, hey, I don't have it, so I will ask outside and see whether they have it. So if it finds it, it will cache this information and it will respond to the package manager. So the package manager will say, okay, I will find this version the user is trying to find, and if this version is on this manifest, it will grab the URL from this manifest and it will start to download it through the registry, the proxy registry. The proxy at the same time will open a connection with the upstream. It will download the resource. It will cache all the information via streams, and it will pipe it to the outside, to the package manager. So the next time you ask for the same resources, the proxy, it will respond with this information. It's worth to mention the manifest, they expire over the time, by default 2 minutes, because yes, you may have different new version of React or Webpack, etc. But the tarballs are immutable, so they don't need to be downloaded twice, or they don't need to be invalidated. You will have them in the cache. And this is how actually works a normal transaction. It happens thousands of times for every dependency you have in your build. And this is important when you have continuous integration, because if you have a local cache, you will avoid the project. It goes to the network constantly, downloading the same things, especially in buildings, because you may have several builds in one single pull request, right? And you don't have to download jQuery 100 times. So the pull requests, if you have several pull requests in your company, all of them, they will download for your local cache. Also, Verdaccio is a hosting. You can host your own private registry. Today, I will focus on just our tokens and rate limit. There's a lot of things that the Verdaccio can do for you if you host it as a registry. The next is personal development. So yes, if you have, let's imagine you have your own database, MySQL, Oscar. So also you can have your own registry running in your computer, and you can publish packages. You don't have to go to some online services to practice. So you can do it, especially there in your computer. And end-to-end testing, especially if you have big projects with a lot of packages. I have plenty of examples in open source, which you can test one single package manually, but you won't be able to test every time 100 packages in your project. And this is when Verdaccio becomes really, really flexible, because you can integrate in your pipeline, and it does not get too much resources. You will see in that demo. And also Verdaccio has a user interface build where you can navigate in your packages. It's based on React, it's embedded it's installed with the same package, so you don't have to install anything else. I touched a lot of topics about Verdaccio because it provides way more than this. You can see in our channel if you want to watch more videos in deep on other topics. How to install Verdaccio is really simple. You need to only install Verdaccio globally if you want to run it for all your projects. Also, you can install it in your dependencies, like you will see on the demo. And that you need Node 12, but yes, Node 12 is going to expire in April, so I will recommend to use 14 or even 16. But that's really, really small, 1 single megabyte. So let's see how the architecture of Verdaccio is, because Verdaccio is a file system based. So when you run the first time Verdaccio, it just installs all the things that needs within your home. And Verdaccio uses Express.js as a web server. And this is the endpoints that are exposed so they can speak with the package managers. Also, you can install middleware plugins as well. Because Verdaccio is a plugin architecture, so you can use default, which is file system based, but also you can replace it by using something on the cloud if you like. You might have used the plugins already available, or you create your own ones. Local storage is the local cache. It's the local plugin for the storage, and it stores the names of the database of the published packages on the Verdaccio DB.json file. Also, you have the authentication plugin, which also store information in file, which is this one, HTTP, and it stores the user and the password. But Verdaccio can be modified, can be extended. So you can do everything from the config YAML file, which usually is hosted in your home folder. That might depend on this operating system you're using, but you can see in the documentation how to find this file. So let's talk about tokens and private registries. You might have seen this file in your home file, which is the npm rc file. And here you can store a lot of information, configuration from the package managers, or the most important is the auth token. The auth token is like the key that gives you access to some private registry. And this file is really, really important because here the package manager will grab the token from this location and it's gonna send it to the registry. So the registry can resolve whether you have access or not. If you don't have anything here on this file, probably on every request you won't send anything. Because the package manager uses this authorization header to send this token with the bearer keyword you might be aware already used for other applications. And this token is sent to the registry and every request. And Verdaccio receives this request and grab this token. And in order to unpack and unpack this, verify this token, we use the crypto module. using the create cipher. Yes, this library, these APIs already deprecated. This is what you use in Verdaccio 5 right now. It's really nice for local development. It's really short, the token, but it has no salt and it never expires. So I won't recommend you use this in production, but you can use it on your own computer or maybe by yourself. But Verdaccio 6 and the next version, it already fixed that by using the new API, which is the create cipher 4, sorry, and it has salt support. And also you can use your own custom hashing algorithm. The token is a bit bigger, but it's more secure because it returns the different token all the time. The previous one is the same token if you're using the same user and password. This is going to be a breaking change in the next major release. So, but don't worry, it won't be a big issue to replace it. You don't have to do much in your site. You will see in the guidelines in the future. JSON Web Tokens, you might have used this in other applications. Now, Verdaccio also can be used with JSON Web Tokens built in by adding this security property in the config file. You can define the UI already use web tokens by default, but the API can use JSON Web Token with sign and verified. You can define all the properties. All these properties are coming from the JSON Web Token library, so you can just change the behavior of the signature of the verify by just adding expire. By default, I think it's 7 days. But if you don't add anything, but also you can change the verify. Even if you regret shipping tokens with expire 1 year, you can just change to 2 days and you can expire earlier. Why the JSON Web Tokens are really good, especially if you are using some authentication layer that costs money. Because remember, for every request, you will go through the authentication, and this might be not ideal in all cases. So the JSON Web Tokens became really, really handy here because you can when you sign the token the very first time, yes, it's going to go to the authentication. Verdaccio will send it back, and the next request he's going to grab this token, verify everything is fine, and then it's gonna rely on this token all the time because the token contains enough information for decide whether you have access or not to some resources. We'll see in the package access section how these roles and these groups works. Because JSON Web Tokens are stateless authentication, like I mentioned. The tokens can expire. This is the good benefit that the other tokens they don't have. They can store data, but here's the trade-off. The trade-off is you need to trust in your users, or you need to expire soon, or because the groups might change based on your authentication provider. And some user might not have access to administration, for instance, eventually. So yes, this is something you need to figure out based on your own needs. But personally, it's much faster to use JSON Web Tokens in Verdaccio because you don't have to impact them all the time, and you don't have to go to the authentication. So let's run a demonstration so we can see some stuff with one single project. So for these plugins, memory plugins are really important because are fast. They don't hit the file system. They don't create. And we'll see this demo how we can use memory plugins for storage and authentication. So let's see here. We are going to install the Verdaccio memory. This plugin is for the storing packages on memory. So this information is going to keep in memory while you're having the Verdaccio running, and the same thing for the authentication. So, but first, let's uncomment this. This is just to avoid I have to add the registry flag all the time when I type something. Let's run the registry by default. So you can see we are using the default plugins, which is the ones you won't see the local storage, but just when I run as something. By demand, Verdaccio create the storage and just cache all the information from React. But if I change the plugins here in the Verdaccio YAML file, I'm using Verdaccio YAML file because I'm using my own configuration file, and I replace the storage file stored memory and the path, the HTTP path by auth memory. I just restart the server. And when I Okay, I need to remove first the storage because I don't want to ensure. So React works fine, and there is no storage created. Everything is in memory right now. So let's go with package access, because this is the main way that Verdaccio can define who has access to different packages. By default, you have only the ones are below, and when you can see the scope packages, and the other one is match everything else. I have two examples here, but second, okay. Here you can define your own patterns. So you can define, for instance, for the scope, or this example, Webpack plugin, whatever, and you can define your access, publish, unpublish, and the proxy. So you have several groups. First is the all, which match anyone, either you are logged in or not. You have authenticated, if you are authenticated. You have a valid token. And anonymous, if you have no token at all. So you use an anonymous, if you are sending authentication, it will fail. And also you have custom groups. By default, the custom group is the user you are logged in. But if you are using your own authentication plugin, the groups might be something else. There is some plugins there like GitLab. They grab the groups from GitLab and they use that. So that's something you might decide by yourself, depending on the plugin you're using. And the proxy, you can see the proxy, you can have several ones. We will see an example in a moment. So let's actually clear this up, and let's actually check the configuration. Okay, I have one already. So let me add React. This is the one we were using, and let's change access to authenticated. So if you want to access to this, you need to actually be logged in. The npm info, it just let's run the registry first, and the npm info only requires the manifest. It does not denote the package. And okay, so I need to log in because I have no access. So let's use the information from the config file, which is foo bar. Okay, and now, yeah, it seems I used the wrong authentication. And the email is not important. You can ignore it because Verdaccio does not need it at all. Now let's run info React. Okay, you are logged in, so the Verdaccio visit token and verify is correct. So you can see you are getting React from the upstream, which is the one is defined in the proxy npm.js. But if I change the access to some specific group, let's see admin. So I will add admin on my list so I can test both user login, and we can see whether works with foo, but it works with admin. So let's run the registry again. Remember, every time you change the configuration, you need to restart the server. Let's log in with foo. Email is not important. And okay, again, okay, I'm just logging in. Let's find info. Okay, forbidden. You have no access to this resource. I will log out. Then I will log in with the admin. Okay, and the mail is not important. And let's request again React. Perfect. So admin has access to. So then we have the app links and authentication. Because when the package manager sends a request to the registry, it sends this information without token if it's available in the npm.rc file, but it does not send this token to another registry. It just, by default, it asks to the npm.js. So if you have resources that requires authentication, like if you need to speak with another registry, for instance, Nexus, which it requires some authentication, or another Verdaccio backup, you can hook as much app links you want, but this might be protected. So there's an example. There's a nice article from Line Engineering. You can read how they use Nexus with Verdaccio. It's on the slide. I will share this link later, so you can read it. It's in Japanese, but you might want to translate it. And this is how the authentication looks like on the config file. So you have an uplink. You can add the type of the token. By default, usually it's bearer. And then you can decide whether you grab the token from the specific default token, which is npm token, environment variable, sorry. Or you might find your own environment variable if you like. This comes handy, especially when you're using Kubernetes. Also, you can have the token in your config file. This is not recommended, but we are going to use it on the demo because it's handy. But yes, we see the configuration for the uplinks. And let's change React to access, so everyone can access to this resource, because we want to route the request through another registry. And let's just change the proxy. Let's run the registry again. And let's ask for React again. So 404, why? Because the registry returns 101, and the registry was not able to find it because it was not allowed to do it. And for that, we need to add our own token. But first, let's try npm.js as a second option. So if I restart the server, I request the same thing again. The first request is 401, but the second is 200 because Verdaccio can actually search to different uplinks. So if it does not find it in the first one, it's going to go to the second one. But let's try to get information. So you can use with Verdaccio npm tokens commands. So let's create npm token create. Let's create a token in another registry which are running on the background. I will log in, and this is the token that the Verdaccio 2, the one is running in the background. I just create a token. Let's change here. Let's save it. Restart the server. And let's ask again for the same resource. Yes, awesome. So 200. So you can ask authentication servers. So end-to-end testing, because end-to-end testing is critical for if you have a lot of packages. Here I have an example from Angular CLI. They are using spawn from the child process module in Node.js. On my example, I will use fork, but you can use also spawn and other ways to use npm end-to-end test with Verdaccio. So here I'm just running just for this example. This is just an example. Don't take it so much seriously. And here I have the before all, which I'm running a registry with a random port, and my specific config file, which is Verdaccio YAML. And then when I finish, I just kill this process. On this test, I'm just running npm info jQuery, and I verify whether I'm getting the right information from the registry. Here I have this utility which I will fill out now, which with you. And let's use fork here. And since we have Verdaccio installed as a dependency in the project, we can just use require resolve Verdaccio bin Verdaccio, and this will give you the path of the registry. So you can, because fork run Node.js applications. Let's inject the arts share process, and this is a process, right? So we can add events. If you're using Verdaccio in debug mode, it's able to send you messages back because it's running another process, which is the Verdaccio started message. For that, you need to enable this debug _debug through. It's a little trick, and then it's gonna send you this message, so you don't have to listen to the port. It's much easier. And then, okay, let's be a good Node.js citizen, and let's navigate the errors. Let's reject this promise if something goes wrong. And let's do the same for disconnecting, because yeah, why not? Okay, that should work. Let's run the test, and let's see whether the previous test works fine. You can see the login of the Verdaccio. You can turn off this if you like, but it's handy if you are running few tests. But you are running thousands, might be annoying. So let's create another test. Let's create a test for publishing the package. Okay. So verify. Let's add done because we want to done when we finish. We are running everything here synchronously, so shouldn't be a problem. Let's log in and let's actually. Okay, we need to create a utility for publish because we have npm info. We have some file here. To let's copy this one and let's just adapt it to our needs. One npm publish. We don't need the package name because your npm publish doesn't need any argument. Just npm publish. But we might have, yes, we might add this access publish just in case you are decide to change the name to scope. Without this as access public, you cannot actually publish the package. Then let's actually add it to the imports. My TypeScript is not working fine, but it's not important. And let's add the port. We might improve this, but it's fine for now. And now let's okay, we can use the package JSON just to because we want to publish the pre-package we are working, right? So we can just use the package JSON to grab the version of the name from there, so we don't have to hard code it on the code. And let's build the name, because when you're publishing, you get a combination of the name of the version. And now we want to verify whether the package has been published. So let's run the same command that we had above, npm run npm info with the names with the same name and the port. Now we need to verify whether we have the right information, right? So let's add any, because why not? Info name, it has to match with the name, and the same for the version. And yeah, let's add the done, because otherwise it won't finish. Let's run the test and see whether this works. Okay, it works. You can see actually in the log how the request is happening. You can see publishing a package. And let's change the version so we can verify whether this fails if the version is incorrect. See? So we are getting 101. So that's actually how you can do end-to-end testing with Verdaccio. So another feature important is the rate limiting, because security is important and you need to protect your registry. By default, in the latest version of Verdaccio, you can run these commands from here, and you will notice the Verdaccio only allows 1,000 requests every 15 minutes on the key endpoint, security endpoints, which is login and create users. And you can use AutoCannon to run some stress tests and just verify with core and see how you get 429 response from the server. You can decrease these numbers if you are not logging so often to protect yourself. So we're almost finished. Let's recap what we have learned so far today. So first we have learned how let's recap. We have learned how the package manager speaks with registries, because if we understand how this works, we have a better understanding how the tokens are sent and so on. These are really normal questions when people ask me on the forums. We have managed to publish multiple registries with authentication, so you can have the tokens in one single place. We can use JSON Web Tokens to replace the default legacy token signature. At least you can change trusting users, but also you can boost the registry. Also, you can enable strict rate limit to protect your resources and avoid abuse of your endpoints. Also, we can use memory plugins if the end is not persist. The end is not persist the packages, and you can boost your installation. Also, we can use Verdaccio allows to use publish packages programmatically with end-to-end testing. So that's all from my side. Thanks so much for listening. You can follow me on the social networks are below. If you want to find more information about Verdaccio, you can find it on this domain. So thanks so much. Thanks for your attention.
Okay, Juan, finally. How are you?
Hi. Yes, fine,
How are
thank you.
Yeah, so we had a slight miscommunication over here whether I should invite you for the opening or not. So, but anyways, thank you for your presentation. Thank you for joining us, and thank you for
Thank you for having me here.
taking your time joining us. And yeah, let's get to the Q&A session. So we have a first question. Can we use Verdaccio instead of Artifactory? Is used to change. Is used to change. I'm not sure if you get the is used to change part.
I think he refers to whether it makes sense or it's. I think the answer here is depends. Depends what actually you need. If you have Artifactory, it's just a big application for scale for big companies, and probably you don't need a truck to go to the supermarket to grab some eggs or some tomatoes. So it's you need something small, right? So if you're learning Node.js, if you are having a small company or group of friends, it's much easier to have your own registry set up in a few minutes. Artifactory might require some servers, configuration, etc. If you're looking for scale, big company, thousands of users, then you might need to think something like that. But if you're thinking small, then medium, then you can work with Verdaccio.
Awesome. Thank you. So we have another question. This one is interesting. I noticed that when the memory plugin was installed, npm told there is 3 high severity issues. Why is that?
Maybe I should have to use Yarn instead. I know it's fine. I'm just joking. Yes, I mean maybe there is. I try to update dependencies. We use several tools like for security, all the dependencies. We have bots. I think we use Nick for tracking security problems. Also Dependabot. These are open source tools we use in Verdaccio. If something is there needs to be updated, yeah, I would recommend to do a pull request. I'm really happy to receive requests from contributors and merge them, and release them so we can get rid of these warnings. But sorry for that. Maybe something I missed.
Yeah, maybe there is something interesting to discover later on. Okay, so if you okay, everyone, if you have questions, we still have another 4, even 3 minutes of Juan's precious time. So please run fast to the chat if you have any questions, or if not, we will thank Juan for his presentation. And I guess we will be waiting for you at our next Node.js Summit. So everyone, questions? So usually when we have other sort of conferences, other sort of events, so let's say Flutter or regular JavaScript, I may have my own questions, but today this is way too high level for me. So I'm not as proficient in Node.js to answer my own questions. But anyways, Juan, thank you for joining us. Thank you for actually committing your. Oh, we have question. Why Verdaccio? Why?
Okay, there's a long story here, so maybe we need the 4 minutes. I will try to be quick. Verdaccio is it's a project that I started to contribute in 2017, but there's a long story behind of it. It's a fork, another project with this name Sinopia, and which was created in 2013. So it was running for 5 years. Yeah, there was some issues. It was several forks, and the authors of this fork, of the Verdaccio fork, they were looking for a name. So they were looking for something similar to Sinopia. Sinopia in Italian means a reddish color. So they decided to use green, and they selected Verdaccio because it's a greenish color in Italian. So that's the origin of the name and how was created.
So I guess our background is kind of Verdaccio.
Yes, Verdaccio is the one.
Okay, thank you very much, Juan, for joining us, and thank you for contributing to this event. It was our pleasure to have you, and we hope we will see you next time during our next Node.js conference or maybe other JS conferences. Thank you very much.
Absolutely. Thank you so much for having me here. Bye-bye.
Have a nice day. Thank you. All right, everyone. And now we will have a 15-minute break after the... so we will have an announcement right now. And after that, we will have a 15-minute break. So you can grab yourself a sandwich or maybe a cup of tea or a cup of coffee. And we will see you in 15 minutes. Thank you for staying with us. Hi, everyone. Now we want to say a huge thank you to our platinum sponsors, Bright Security Labs, for supporting us and also for giving us the opportunity to share with you some free scanning hours on their platform. Now we will post a link in the chat, and be sure to go register and grab yourself free hours of scanning. And yeah, also look for announcement about very practical hands-on workshop that we will have on 9th of June. So be sure to check it out when we have the announcement and register for that workshop, and have a great Node.js Summit.
Hey, Global Summit for Node.js 2022. Tanya here from Bright Security, the developer-first dynamic application security testing scanner. We've made it easier for you to run security testing and are the first scanner to integrate with unit testing. Start creating automated security unit tests with our new sec tester. Everything is controlled via the CLI to test each function or component in seconds. And with no false positives, you can finally trust your scanner's output to produce secure features at scale. Get exclusive access to this feature by joining our workshop on June 9th. See the link in the chat now or find it on the event website. Security testing just got brighter.
Okay, hello everybody. I'm very glad to be here again in this continuing with this event. I'm Hugo Loza, and I'm glad to present the next session for our presenters. I hope everybody is enjoying all the talks the same way I am. We had a very nice, very interesting topics already going behind us, and now we have many others that are very interesting, and tomorrow the same. So really hope everybody's enjoying. Today I'm broadcasting from La Paz, Bolivia. Bolivia is considered the heart of South America. It's around noon in my time. We all are in different time zones, so that's also great because we are sharing the same events in different time zones, and it's great. So in this block, we have 3 speakers. We are going to have very interesting topics. The first one is the good, the bad, and the NPM package. I bet I can tell you that most of you, even that we don't say it out loud, we suffer a lot with NPM packages. So let's see what we are going to learn, what we are going to see there. Then who needs documentation when you got tests? That's an interesting topic, and even something that we can discuss a lot, I think. And the last topic is to mock or not to mock, testing strategies. So great topics. I hope everybody's excited, ready to listen, ready to learn, and ready to share knowledge together. So don't forget, please send your questions to the different places where you can send your questions. And let's start. So I'm going to present first our first speaker. I don't want to eat all the time that our speakers have. The first one is Feross. He's the founder and CEO of Socket. And Feross is working on the approach to supply chain security by auditing every package on NPM to detect suspicious changes and block supply chain attacks without slowing the development process. is author of the and maintainer of the WebTorrent, Standard.js, and 100 of other open sources projects. So I bet there's a lot of experience there about what he's going to talk about, security and protect our application. So let me add him to the stream. Feross, first check.
Hey Hugo, how's it going?
Fine, thanks. Glad you're here with us. So I think we are basically ready for you. So I'm going to switch everything here, and I'm going to, so you can start. Thank you.
Awesome. All right, they'll be able to see my screen, hopefully. Yes, okay, great. Okay, so welcome to my talk, The Good, the Bad, and the NPM Package, Practical Lessons to Protect Your App. So a little bit about me. My name is Feross. I'm the founder and CEO of Socket, an open source supply chain security company. I'm also an instructor at Stanford University, where I teach the web security course. And I'm the creator of hundreds of open source projects, which are downloaded 500 million times per month. You might have heard of Standard.js, a popular community JavaScript style guide, or WebTorrent, the first browser BitTorrent client. In the past, I used to be a board member of the Node.js Foundation. And I also was a consultant for the Silicon Valley TV show, which is a pretty fun time. A little bit about Socket. So Socket is a cybersecurity platform that protects companies from software supply chain attacks. If you don't know what that is, we're going to learn all about that in this talk. So at Socket, we're auditing every open source package to detect supply chain attacks. So this includes things like malware, typo squats, hidden code, misleading packages, permission creep, and many more other types of attacks. And our customers include thousands of the top tech organizations. So let's get started with the talk. So let me tell you a story. On January 13th, 2012, over 10 years ago, a developer named Faisal Salman published a new project to GitHub. It was called UA-Parser.js, a user agent string parser. Lots of people found it useful. And over the next 10 years, Faisal continued to develop the package with help from many open source contributors, publishing 54 versions over the years. And the package continued to grow in popularity. It grew to 7 million downloads per week, eventually being used by nearly 3 million GitHub repositories. Let me tell you a story. On October 5th, 2021, on a notorious Russian hacking forum, this post appeared. So if you read this post, you'll see that a hacker was selling a password to an NPM account that controlled a package with over 7 million weekly downloads. 2 weeks later, UA-Parser.js was compromised. So those two stories merge, and now we get to see what happens. So 3 malicious versions of UA-Parser.js were published. So somebody clearly bought the password to the NPM account that was for sale on that forum. They used it to add, they used that password to log into the maintainer's account and add malware to the package that would execute immediately whenever one of those packages was installed. So let's dig into the package and see what did the attacker actually do once they took over UA-Parser.js. So the first thing you'll see is there's a new version published, and they added a pre-install script. So for those of you not familiar, this is a feature in NPM that allows a package to run a shell command automatically whenever you install a package on NPM. And so if we dig into what pre-install.js is doing, we can see what the attacker was trying to do. So here's the script. And I'm just going to draw your attention to these if statements at the bottom of the file. So you'll see it's doing a different thing depending on the platform, Mac or Windows or Linux. In the first case on Mac, it actually does nothing. So this is very lucky for Mac users. They were not affected by this attack. But on Windows, they weren't so lucky. So on Windows, the attacker spawns this preinstall.bat file. And on Linux, they spawn preinstall.sh, which is a shell script. So let's dig in and see what those files actually do. So this is the script that runs on Linux. So it starts with a line which determines the user's IP address and the country of origin. And you can see here if they come from any of these 4 countries, Russia, Ukraine, Belarus or Kazakhstan, then the script will actually abort. This is actually a pretty common technique that malware authors use to avoid antagonizing their local law enforcement. It's very likely this attack came from one of these countries. The next thing you'll see here is the script checks to see if the malware is already running by using pgrep. If it's already running, then it exits early. Otherwise, it downloads the malware from this IP address using curl, and then or wget if curl is missing, and then it makes it executable, and then it starts it up. And as you can see here, based on some of the flags being passed into this program, it's a Monero miner, which is a cryptocurrency that is used for privacy. So it's something that attackers like to use. And you can see here, it's basically going to use up your CPU resources to mine cryptocurrency for the attacker. This is the script on Windows. So Windows is pretty similar. It downloads the file, and it also downloads an extra file though on Windows called create.dll. So this is a linked library file, and it goes ahead and starts up the malware, and it also registers that DLL file. So what does the DLL file do? What is this extra file doing on Windows? It turns out it's pretty bad. It actually steals passwords from over 100 programs and the Windows Credential Manager. So really bad. What was the aftermath of this? So it turns out this package, this JavaScript NPM package, was published for about 4 hours, and anyone who installed it during the time window that it was online for was compromised. So any software builds that you did without a lock file would have been compromised, and anyone who updated this package or merged a PR to update this package during this time would have been compromised. And if you ran it on your local computer on Windows, all of your potentially 100 programs on your computer would have had the password stolen. So very, very bad disruptive attack. This was big news in the JavaScript world last October, and you might have heard about it. But this idea of a supply chain attack is actually, it's been happening more and more in the NPM ecosystem and actually across open source in general. So this is really just the tip of the iceberg. There's been, we're actually tracking with Socket, we're actually tracking the number of packages that are removed over time, and we've seen 150 packages removed for security reasons in the last 30 days, starting from today in the last 30 days. So this trend is actually accelerating as attackers are realizing that there's an opportunity here. So I want to focus a little bit on why is this happening now, and then we'll get into kind of what you can do to protect your app towards the end of the talk. But first, so why is this issue happening now? There's really 4 reasons. So the first reason is that 90% of an app's code comes from open source. So this is kind of a new trend. I would say open source has really won. In the last decade, open source has clearly kind of become the way that we build software, and it's the reason we can teams can build applications in weeks, instead of in months or years. So it lets us go faster. And open source works because anyone can inspect the code, anyone can contribute, anyone can publish a package. And open source communities are very trusting by default. So good contributors are rewarded with recognition and eventually publish permissions. And also open source it's won because Node.js, the node modules folder is one of the heaviest objects in the universe. We were using more and more open source than ever before. Additionally, we also have a lot more transitive dependencies. So the way we actually write this software has changed in a way where we use dependencies more liberally. So let's take a look at a real example. So this is the Discord app. This is one example of a popular application, Discord, and it's built on a massive amount of open source. So there are almost 20,000 total NPM packages inside of Discord. And if you look at the commits in those packages, there are commits from almost 400,000 different contributors from 200 different countries. So this is a mind-boggling amount of open source and a mind-boggling number of hands that have touched this code. A 2019 paper at a security conference called Usenix, it found that wrote that installing an average NPM package introduces an implicit trust on 79 third-party packages and 39 maintainers, creating a surprisingly large attack surface. So this is how an app like Discord can end up with so many dependencies. And this is another way to maybe visualize the situation. So this is a visualization that the team at Socket has built. You can see this if you go to socket.dev. You can take a closer look at this visualization. It's actually interactive. You can play around with it, click on any of these boxes. But what you're seeing here is every gray box is a package, and every purple box is a file within that package. And so you can see here we peel back the layers of each package, and within that package you can see how many files are in there, and you can just get a sense for the number of packages that are inside of something like Webpack. So the third reason this is happening now is no one reads the code. So what we're doing really when we install packages from NPM is we're downloading code from the internet written by unknown individuals that we haven't read, that we execute with full permissions on our laptops and servers where we keep our most important data. So it's not really a surprise that we have problems, and it's really a miracle that this system works. Another reason is that NPM doesn't really make it easy to actually read the code. So if you go to the Explore tab on the NPM website, you'll see that there's no code visible here. So you end up having to click that GitHub link there and go and check the code out on GitHub and hope that that actually happens to be the same code that's in the NPM package, which isn't always the case. So Linus Torvalds has this really famous quote about how given enough eyeballs, all bugs are shallow, which basically means that if you have enough people looking at code, eventually the problems will be found, right? But if everyone assumes that this is happening, then there's no one actually out there looking for malware or looking for problems in a package. And this is basically what's happening. So if you look at this other paper from 2020, they found that on average, a malicious package is available for 209 days before it's publicly reported. So that's 209 days during which the wrong npm install command, if you install the wrong package, you can compromise yourself, and that will end very badly. So this is a huge amount of time that a malicious package is available. It's quite shocking, I think. And then another 2021 paper at a different at NDSS, a different security conference, actually found similar results. So they found that 20% of malware persist in package managers for over 400 days and have more than 1,000 downloads before they're eventually removed. And then finally, I think popular tools are giving us a false sense of security. So a lot of people are using things like npm audit or GitHub advisories or Dependabot to keep their packages free of what are called known vulnerabilities. But known vulnerabilities, scanning for those is not enough. The entire security industry is really obsessed with scanning for known vulnerabilities, and it's really an approach that's too reactive to stop an active supply chain attack. Vulnerabilities can take weeks or months to be discovered, and in today's culture of fast development, a malicious dependency can be updated, merged, and running in production in days or even hours. And this really isn't enough time for a CVE to be created and to make its way into the vulnerability scanning tools that all the different teams use. So supply chain attacks and vulnerabilities are very different, and they need very different solutions. Vulnerabilities are accidentally introduced by an open source maintainer, and it's sometimes okay to ship a vulnerability to production if it's low impact. Supply chain attacks, on the other hand, are intentionally introduced by an attacker, and it's never okay to ship those to production. You must catch those before you install them or depend on them. And ideally, we get those removed from NPM as well, so that nobody will have the chance to accidentally install them. So I think those are kind of the four reasons. And now I'd like to jump a little bit into kind of how a supply chain attack actually works. So we're gonna dig into kind of the techniques that the attackers use when they're trying to, we did look at an example at the beginning with U8 parser.js, but I'm going to go into kind of the concrete pieces of how the attacker actually pulls this off. And then finally, we'll conclude with what you can do to protect your own app. So I got really curious, and the whole team at Socket, we got curious about, if there was something we could do to catch these attacks. And so that's kind of how we started this exploration. So the first step is we downloaded all of NPM. And we spent a few weeks poking around it to learn what was going on. And there's 100 gigabytes of metadata in there and 15 terabytes of package tarballs in NPM. So these are the attack vectors and attack tactics that we're going to cover. So there's three of each. So an attack vector is kind of how the attacker tricks you, and the tactics are kind of what the attack actually does to succeed. So let's start. Let's start with the vectors first. So the first vector is called typo squatting. So this is when an attacker registers a package name that is a couple characters different, from a legitimate package. So in this example here, one of these is a typo and is actually malware, and the other one is legitimate. But you'd probably be hard pressed to figure out which one is real and which one is fake. So if you open up the fake version, you'll see that it's using an install script, as we mentioned before. This is a very common technique. And then if you actually look at what's inside that script, so what will actually run on your computer, it's actually a completely obfuscated file. Even without understanding what this code is doing, it's very clear that this is probably not something that you want to run on your computer. The second one is dependency confusion. So this is pretty closely related to typo squatting, and this happens when a company publishes packages to an internal NPM registry. So they have a private registry where they publish packages, and then what happens is an attacker can go to the public NPM registry and publish a package with the same name as the company's internal package's name. And then what happens is the internal tools might get confused and they use the public version of the package instead of the private one. So that's why it's called a dependency confusion attack. And looking through the recently deleted NPM packages, the socket team found a bunch of likely dependency confusion attacks. And if you open up any of these packages, you'll actually find that a lot of these are all removed from NPM now, but if you had opened them up before, you'd find they contain malicious code inside them. And you can see here they're targeting all kinds of different interesting organizations, including the US federal government and big companies that you might have heard of. And there's even some more here on this slide. So yeah, dependency confusion, got to watch out for it. Finally, the third technique is called hijacked packages. And this is when, these are kind of the source of a lot of the headlines that you'll see in the news. And basically an attacker somehow finds a way to take over a package. And, maintainers of really popular packages have been subject to this attack. How does a package get hijacked? It can be for any number of reasons, but the reasons that we've seen happen pretty often are that the maintainer might choose a weak password, or they might reuse that password on another website, and then that website might get its database breached. Maintainers can get malware on their laptops, and it's also the case NPM is not enforcing two-factor authentication on accounts, which makes this type of attack more likely, although they're starting to do a better job of that now. And finally, this is actually a really nefarious one. A maintainer might give access to a new maintainer to help, but it turns out that new person could be malicious, and so that can mean that the package gets taken over that way as well. So now let's talk about the tactics. So what does the attack code actually do once it runs? So there's 3 techniques we're going to cover for this section, and we'll start with install scripts, which we've already mentioned a few times. So most malware uses install scripts. This paper, the one we mentioned earlier, says that most malware, most malicious packages start their routines upon installation, and the actual number for NPM is 64%, because NPM allows packages to run code at install time. So it's actually even more prevalent within the NPM package manager. And so this is a typical example of an install script. So here you'll see that it's actually running 3 different scripts at the same time and hoping that one of them succeeds. And we'll get into what these files do in a future slide. So the second tactic is privileged API usage. That means something like using the network or the file system or environment variables. So basically using APIs in Node that are really powerful and let the attacker do pretty fancy things to potentially malicious things to the machine that it's running on. So let's take a look at one of those files. So this is that file from the last slide. So this is a file which is going to exfiltrate. It's going to steal the environment variables from the user. So you'll see here it's creating an HTTP request to a certain IP address and a domain here. And then if you look at what it's actually sending, it's sending the process.env object, which is all the environment variables in the system. And there's also another way the attacker can do this, which is a little bit more low level and even trickier, which is they can use the DNS package in Node to actually hide their HTTP request. Instead, by using DNS, they can make it look like it's actually just a DNS lookup for a domain name. But actually, they take the environment variables here and they embed them into the DNS request. So very, very sneaky. And then finally, obfuscated code, which we've already seen before as well. So obfuscated code, this is one way to obfuscate code. So basically to hide the behavior from the reader. But there's also another way, which is that an attacker can publish different code to NPM than they do on GitHub. And if they do that, then it makes it a lot harder to audit the code, because most people will just go to GitHub and they will assume that whatever they see there is actually the code that they're running. But the truth is, when you install packages from NPM, they don't come from GitHub, they come from NPM. And NPM does not guarantee that the code on GitHub matches the code on NPM. And of course, you can't really browse the files on NPM directly either. So it's pretty challenging to actually see what's going on in the actual package. So with all that said, it's not hopeless. You're not destined to be attacked. There are things you can do to protect your app, and so we're going to talk about some of those things you can do for the rest of the talk. So the first thing you can do is to choose better dependencies. So if you ship code to production, you are responsible for it, and Node doesn't care whether the code that's running inside Node came from code that you typed on your keyboard, or if it came from code inside of an open source package that you got from NPM. At the end of the day, when you run your application, all the open source code and all of your code are going to run inside of the same Node process, and they all have, all that code has the same permission. So it can talk to the network, it can read your files, it can do whatever it wants. And so really, as developers, we need a mindset shift, and we need to think about our dependencies as part of our app. It's actually our responsibility to make sure that the dependencies work correctly and do what they're supposed to do, because that code is running inside of our app. I'll also just mention that the MIT license literally kind of says this. It says that the software is provided as is without any warranty of any kind. It's not in other words, it's not the job of the open source maintainer to make sure that their code actually does what it's supposed to do. Open source is provided as is without a warranty of any kind. So that said, how do you actually pick a dependency? Well, if let's say you want to do a good job, there are some things you can look for. So obviously the first thing is, does the package actually get the job done? Does it do what you want? It's also important to make sure it has an open source license, and that it has good docs, that it has a lot of downloads and GitHub stars. This one will actually hopefully help you make sure that you're picking something that has at least has some people looking at it, has some eyeballs on it. Ideally, it has recent commits as well, so that means that it's maintained and there's a maintainer around actually actively improving it and working on it. Ideally, it has types as well, which makes it more useful to consume the library with TypeScript. And you also want to make sure it has tests. So these are all great things to look for, but and I recommend you look for all of these things before you select a package. But that said, this doesn't really get to the core of what does the code do when you actually run the code. And in order to do that, you probably have to open up the code and actually look at it and try to get a sense for what is this project actually going to do? Does it actually do what it says on the in the README? Now, of course, most of the time it will. And most open source is good, and most open source works correctly and does what it's supposed to do. But when you find a package that doesn't, then you're in trouble. So if you use our socket tool, the product I mentioned earlier, you can actually dig into open source packages to see what they do. So in this example here, you can type in a package name that you're interested in looking up. So here we're looking at buffer util, and you can see that this package contains install scripts and that it has native code, which means that it's a binary file that is a little bit harder to audit. Here's another example of a package. So this is a package called Angular Calendar, which is a calendar component to show a little date picker on a web page. And if you dig in here and look at the package's dependencies, you'll find that it has quite a few interesting and kind of scary behaviors that it does. So this has dependencies that contain install scripts, that run shell commands, that access the file system and access the network, which is all things you would not expect from a date picker. Why does a date picker need to run shell scripts on your computer? It doesn't make any sense. So this is worth digging into and looking into a little bit further before you add it to your project. And if you use Socket, you can actually click on any of those links there and jump straight to the line of code where the package is doing that behavior to see what it's doing for yourself. So if we do that here, we click on that line, you'll see we jump to the line of code here where, oh, actually, sorry, this is an example of a piece of malware. So you can actually use Socket to look up, a package, and if it's malware, you'll see here, we caught that it's using process.env, which is the environment variables. So yeah, just throwing that out there as a potential option for helping you do research on packages. You can use socket.dev to do that. Another thing you can do is to update your dependencies at the right cadence. So, we're all used to seeing, at least a lot of us use Dependabot, and to stay up to date on the latest versions of our packages. And this is generally really good advice because the new versions often contain security fixes and improvements. However, the quicker you update your dependencies, the fewer eyeballs that have had a chance to actually look at the code. So how quickly should you update? This is a really good question. So if you update too slowly, then you're exposed to known vulnerabilities, which we talked about earlier, and that's not good. If you update too quickly, then you're exposed to supply chain attacks because you're running code that very few people have actually looked at. You might be running code that was published yesterday, right? So there's been no time for anyone to really look at it or to audit it. And so this is a very difficult trade-off, and there's really no perfect solution here. We'll talk about a potential solution later at the end of the talk. The kind of third thing you can do is you can decide, for very security critical apps or financial apps, you can decide, hey, we're going to audit every dependency in our app. So that means looking at every line of code in the app. So how closely should you do this? How closely should you audit your dependencies? Well, you have, again, you have a trade-off between full audit and doing nothing. So if you do a full audit, that means you look at every line of code in the app. That's a lot of work. It's slow because now the developers that want to use a package now have to wait for the security team to do an audit before they're actually allowed to install the package. And it's also expensive. So it takes a lot of developer time or engineer time to do this audit. But doing nothing is also not good. So doing nothing means that you're vulnerable to supply chain attacks because you're just running code without even looking at it and hoping that it's safe. And so this is risky, and it can be expensive in a different way. It's expensive if your company is breached. It's expensive if you have to tell your customers that you were breached and that you had an attack. In terms of PR, that's not very good. So really, what we want here is some kind of a balance between the two, something in the middle, sort of a happy medium, where we use automation to automatically evaluate all dependencies, to look for malware and hidden code and typo squatting. And then we manually audit only the most suspicious packages. So that way we can provide security information directly to developers in pull requests and empower them to solve security issues before they're deployed into production. So what does that look like? Again, I'm going to shout out the product we're building, Socket. Of course, there's many other ways to accomplish this, but if you use Socket, then you get a GitHub app, which can actually come into your pull requests and leave comments to let you know if a dependency that you're installing has a potential problem. So in this example here, the user installed the wrong package, browser list, and should have installed browsers list, which is a plural, which is a one-letter difference. And the bot came in and warned them that they actually installed a package, which is probably the wrong package because it's a lot less popular. And so this way, the developer has the information to go and fix the pull request before it gets merged and protect their app from potential attack here. So you can install this GitHub app if you're interested at socket.dev, and you can get your own repositories protected with that today if you'd like. It has a lot of features here. I'm running out of time, so I won't get into all of them, but you can basically catch a lot of these supply chain attacks with this application, this GitHub application that you can install in just a few clicks. We have a lot of different issues that it can detect. And if you look here at this page on the site, you can kind of see what types of issues Socket can find in your project. And there's a lot here, but I won't have time to show you all of them here. So I'm just going to keep going. Yeah, finally, if you want to try out any of these things, you can go to socket.dev. But I will say before I end here that the key thing to protecting yourself from supply chain attacks is really to have a mindset shift in how you think about dependencies, and to make sure that you think of them as part of your application, and to start to really ask questions about them. Who's maintaining them? Who's behind this code? Has there been a new maintainer added recently? Get curious, right? Really dig in. Don't just use open source and treat it as, don't just treat it as don't think of it as a consumer would. Think of it as something that you're responsible for, right? You can actually contribute to that open source project. You can actually open up the files and look and see what it's doing. You can actually get curious about the code. And if you start to change the way you think about your dependencies, then you'll be a lot more protected against this type of attack. And you can start to look at different tools and different techniques to try to protect your team from this problem. And I think I'm out of time now, so I'm gonna end now and just say thank you for watching my talk. If you want to get in contact with me, my email address is on the screen, and you can check out the product there, or you can follow me on Twitter at Feross. And also, we're hiring if anyone's interested in working with us at Socket. Thank you very much.
That's great for us. Great talk, and to be honest, now my nightmares I think are now also with that first. My first nightmare is dependency, and now security and dependency. So it's right. This tool looks to be very great and useful in any case. So let me start sharing some questions from the audience. Let me show this first one. Does NPM has own methods to test for malware, virus, and so on for all the packages that are being published? If yes, why those things don't catch the actual attacks?
Yeah, that's a great question. So NPM actually does have their own malware detection that they run automatically on every published package. It does catch a lot of malware, that, especially if it matches previous patterns of malware that NPM has seen before. But for some reason, it doesn't stop the kinds of supply chain attacks that we've seen, happening again and again. So, their techniques I think are probably doing something. I know that, from talking to the team there, that they are scanning for this stuff. But for some reason, it doesn't seem to work a lot of the time. It doesn't seem to catch everything, and you still get these headlines, news stories. Just recently we had examples of protestware back in a few months ago, where some maintainer was actually trying to protest the Russian war in Ukraine, and added code to their package, which would basically delete all your files on your computer. And that's an example of something that NPM didn't catch it before it was published. So I think they're trying to do what they can, but it's really not a complete solution, clearly, because it's not working to catch everything. So I hope they improve their situation. But I think there's probably always going to be a role for you as a developer to think about the code you're using. Even if security wasn't a concern, just think about you're still responsible for the code working correctly and for having good quality and not having bugs in it, right? So and for making sure you pick code that's not going to be a maintenance nightmare. So there's always an element for the developer to think carefully about what open source they're using, even if NPM is looking for malware.
Great, thank you. Yeah, and there's some advantage also of having part of our continuous integration and delivery process, something that is also catching at that moment all the issues. And NPM is not really doing that. No, it's something that happens beforehand.
Exactly.
So another question here, now that Microsoft owns both NPM and GitHub, can it check that the code published to NPM is actually coming from GitHub?
That's a great idea. The problem, here's the difficulty with this idea. So a lot of maintainers actually have a build step in their project. So the code that's on GitHub might be, let's say, written in TypeScript, but then the code that's on NPM is published as JavaScript. And they don't want to check in the JavaScript code in the GitHub repository, right? So the GitHub repository has the TypeScript, but the NPM package has the JavaScript compiled version. With maybe the type files sitting next to it, as a type file. So basically, the code can be different in both places, right? So I think then that's actually a good thing in a way. So I think really what they could do, and maybe what Socket could do also, is to confirm that when you run the build command, so when you take the GitHub repository and you run the build command, npm build, that you actually get a package that matches what's on NPM. So basically confirming that the build process produces the same files, if that makes sense. But I don't think you could actually do I don't think you would actually want to confirm that they're literally the same because of this. Because a lot of people use things like TypeScript to write their code in one language and publish it in a different language, if that makes sense. Yeah.
Okay, Feross, thank you very much for your talk. There are many other questions that you may need to answer in the chat. Please take your time so you can help us. Oh, we have a lot of questions, so go ahead and answer there. So thank you very much. Let me present our next speaker, please. And thank you very much again.
Yeah, no problem. Thank you for having me.
Bye. Okay, so let me go with our next talk. That is, who needs documentation and when you got tests? That's actually like a very hard question for every developer in the world. So it's interesting talk. Tal Joffe is the speaker, and he's Tal is director of engineering at Nielsen. So he's a colleague of me. I'm also director of engineering, but at Mojix. And Tal is he's organizer of a big web theory meetup group, editor and writer of Nielsen Tel Aviv tech blog, and champion of design practices, functional programming, and clean code. So all the best practices about development regarding development, not only in Node.js, I believe. And just trying to combine the passion of technology and methodology to create a happy, effective teams that deliver great results. So with that, I think I hope I introduced you well. Even I pronounced your name correctly. So without any more, I think I can leave you and you can continue.
Great. So thanks, Hugo, for the introduction. As Hugo mentioned, my name is Tal, and thanks for joining Who Needs Documentation When You Have Testing. Hugo mentioned most of it. I'm a group leader in Nielsen. I like clean code and functional programming and software design. And as you will quickly find out, I also really like writing tests. To kick things off, I wanted to show this quote by the great Uncle Bob that wrote, among other things, the book Clean Code, which I consider a software Bible. But basically this quote says is that as engineers, we spend much more time reading than writing in our day-to-day. It's over 10 to 1. And why is that important? It's important because if we write code without regarding how people will read it, once we will need to find something in the code, maybe it's a bug fix, maybe we need to understand what's going on to know where to add a feature we need, we might end up looking like this. And I don't know about you guys, but that's not how I want my day to look like when I'm writing code. I want my day to look something like this, right? Coding should be fun. So how can we do it? What do we do when a code is easy, like hard to follow? We can obviously use documentation. We can write a bunch of tests, as we will soon find out. What we can also do is to rewrite all of our code with clean code that is easy to read, so we don't need anything else. And it might be a great idea. It might get you thrown out of a window because in some cases, it's just not possible. Maybe we have a bunch of legacy code that we simply don't have the resources to rewrite. And we have to do something about it because we use it, we maintain it, but rewriting is not an option. We also might have unnatural behaviors like edge cases or external constraints that will be difficult for our code to explain without anything else. Also, a very common case is that we wrote our code, but we missed something, and now there's a bug fix or there's a regression, and we want to make sure we highlight it. So when we change things, we don't make the same mistakes again, right? We made those mistakes for a reason the first time. So if we don't do anything, it's possible they will happen again. So one approach is definitely to document all the things, as the common meme says, right? And that will work. That will fix all of our problems. But this also might be, there's some cases where there's some pitfalls. Documentation is manual. It's time intensive, right, to write everything down, especially when you consider that most developers are not technical writers. Some of them are not natively English speakers or are working in a company where there's multiple different native languages going on. So we can have documentation and it's still not very easy to follow. And I'm sure some of you have came across internal documentation that was like this. Also, a very important note to consider is that even if we spend all the energy writing documentation and it's written well, it still needs to be constantly updated because our code always changes. I've never seen a code base that doesn't have new features or fixes or whatever. And if we don't change our documentation as the code changes, not only it will be incorrect, it might be misleading because it might say something that is very different than what the code actually does. And if we rely on the documentation to let us know what the code is doing, we might be in trouble. So don't worry, it doesn't mean that you have to continue living your day like this. There is a solution, and that solution is obviously testing to the rescue. And some of you might make this face when I'm talking about developers writing tests. I really hope it's none of you people joining in because it's 2022. Writing tests is part of every day for a professional software developer. It's essential for many reasons, but today I will focus about how it can help us with documentation, with explaining what our code is doing, right? And so how can we make it happen? We need to make sure we address three things. We need to make sure that our tests are readable, similar to our code base. We need to make sure our tests are use case oriented, and we need to make sure they're extensive, right? And I will go in length to explain each one of these bullet points, but in general, if our tests are easy to read and they explain all the use cases and they cover everything because they're extensive, now we can use them as internal documentation. So let's start with readability. Three different items, and I'll share examples on each. So first topic is the AAA pattern, the arrange, act, assert. It's pretty common, so most of you might know it. But for those of you that don't, basically it means that every test we write has exactly three parts. A part where I arrange all the things I need for the action that I'm testing to run. All the different, mock data creations, and maybe I want to mock something, and maybe I want to have different types of expected results variables. Now I do the act itself. I call the function I'm trying to test. And the final stage is I assert that, what I wanted to test is actually working. And every test I write, without exception, looks exactly like this. So when I'm reading the test, it's very hard for me to read it. I know the first part is the arrangement part, then I have the act, then I have the assert. Some people use comments to separate the different blocks. I just use a blank row, but you can use whatever you like. Another important thing for readability is to extract mock creation. Sometimes we need to, for the testing, we need to create a bunch of different data objects. Some of them have a lot of different fields. Having them inside of our tests is very noisy, and it distracts the reader for the important aspect. So it's much better to just have some, help method within the test folder that just helps us create the data we need, and we can use the name of the method or the variable that is returned from the method to explain what this object is. So in this case, we say, just give me a valid segment, because all I'm testing that if it's valid, it should work properly. I don't care exactly what values are inside, right? So this makes it much more readable. In some cases, and sorry for using a Java example, but it's a big project we had that used this pattern extensively. Sometimes we can have a test that's built as like arrange, act, assert, but because it's very complicated, we do it internally, and then we just use it as a template to just like use slightly different configuration in different cases, and just use the exact same template. And now when I'm trying to figure out what this code base is doing, I need to understand how the verify scenario test is working once. And now I'm just looking at the different configuration. In this case, the name you see here will be, you will have two different files. One file named like this is input, one file is output. And now when I want to make sure how this code is behaving, I'll just go to the relevant file and see, okay, this is the input, this should be the output. So it's very easy to understand what this code is doing. So not applicable to all cases, but in some cases is useful to easily create readable tests. And now to the second part about being use case oriented. So what we want to do here is make sure our tests are focusing around the behavior, they're behavioral. They don't rely on the implementation, because similar to if we would have written documentation should not care about how the code is doing what it's supposed to doing, just what is it doing, right? We should also mock as little as possible. It makes it easier to read the test and make sure they are actually doing the entire use case. It's also a best practice when writing tests, so why not, right? So I'm not sure if you know this guy, Kenzie Dodds. He's very well known in the React universe. Maybe some of you are full stack developers, you know him already. And he created an open source library called RTL, React Testing Library, which we used in Nielsen a lot and gained some knowledge from it, also for Node.js type of testing. And this quote says that the more the test resembles the way your software is used, the more confidence they can give you that things are working as expected. And that's also what we want to achieve, right? We want our tests to resemble the way our software is used. And that way they can explain to us what the software is doing. And a very nice bonus, they can actually make sure it does it as well, which documentation cannot do. So that's a very nice added bonus. So just like a very quick example of some of the topic, and I have another example coming up. So when, for example, we want to test some service, we can mock the data access component that this service is using and just make sure it's called. But that's a very weak test. And it's also not testing the behavior of the code, just testing the implementation. And if something is off here, it just makes sure that it will continue to be wrong forever, which is probably not what we want to do. What we want to do is just call the function, call the service, and make sure that the actual data that it returns is what we expect without mocking anything if we can afford it. That way, it's very easy to understand what's going on here. And we don't rely on the implementation, because the implementation does not explain to us what is going on. It explains to us how it is being implemented, which is, again, not what we want to do. And to take things further, we want to make sure that our entire testing strategy is not the more common pyramid approach, in which we have tons of unit tests, all the different edge cases, everything is covered in unit tests. And then we just make sure with integration tests that the units are combined correctly. And we have some end-to-end tests, for the important parts. So we don't want to use the pyramid approach. We want to use the diamond approach, which means that we mostly write integration tests and very few unit tests in very specific cases. And this works well if the integration tests are built around the actual use cases our code needs to answer. And in some cases, some edge cases within the internal components will never be tested, but if they're not being used by all of the different use cases we actually support, why do we even need to test them, right? So it kind of goes together with everything I mentioned. And just as a quick example of what I mean when I say behavioral integration tests. So this is a diagram that kind of like abstract how I design software. Doesn't really matter what we see here, but just as an explanation, in the software I design, I have a type of component called a manager that is in charge of what this type of use case should do, not how it does it. So when I'm writing integration tests, I will mostly write the greater majority of my tests will be around the manager. And the manager will call the engine and the data access and all the different layers and the utilities, everything else. As long as I make sure that all the different use cases that the manager should support are tested, then I know that's the middle part of the diamond shape. I know that I covered all the different use cases, and also my tests are explaining all the different things that my service needs to do, disregarding how it does it, because it doesn't matter. I can change, I can work with different databases, do different types of calculation. The use cases will remain the same. So just as an example, how one of these tests might look like. So you can see here that in this case, I'm creating an audience. It's very easy to read that I'm expecting the audience in the database that was created to be what I wanted it to be. Also, I want to make sure a message is sent to somewhere, right, to an alert service. And I want to make sure we're invalidating the cache because something new was created. So when I see this code, it's very clear what should happen in this use case, right? And as you can see, I've extracted away exactly how I'm verifying this, because it's not really important if I just want to read the test and understand what's going on. If I want to deep dive, I'll go inside. But this kind of like explain to me in high level what's going on. What you can also hear is that in most cases, I will not mock my database, because my database is pretty much, part of my, is inside my control. And if I cannot mock something, I will rather not mock it. So I know all the different layers are working as expected. Like from top to bottom, I'm using the actual production code and not like just some representation of it, which in this case, the test might look okay, but the code might not work as expected. And if I have external services, like an external cache or like an external alert service, in that case, I will mock those services. I will just make sure that things are very clear, and I will try to make sure that I'm just mocking the most like external part of my code. Everything works until the external part. Let's talk about extensive. How can we make sure our tests are extensive? So one great way to do it is to use TDD, test-driven development. If you use it the way I describe testing, it sometimes is called BDD, behavioral-driven development. Basically, it means that we start with writing tests. We start with explaining through the tests what we're trying to achieve. And if we did that, every piece of code we write is tested and documented through the testing. And if you want to go down that route, which is great, but there's a learning curve, I really recommend doing it in a way that is called outside-in TDD, which means, like I've mentioned before, we start with integration tests that explain the high-level use case and not starting with tests for all the different unit tests. This is much more time efficient and much easier to wrap your hand around it. And if we want to make sure our tests are acting as documentation and our behavioral, it goes very well together. Another suggestion I have for you here, if you don't want to do full-on TDD, right, for everything you did, you can also do it for, let's say you have a code base it has a testing framework, and now you have a bug fix or a feature to add. You can start with adding or fixing the relevant tests, and then add your behavior. So you can do TDD just like once the project gets going and for small things. And that works very well. And also kind of like goes together with everything we've mentioned before. You can use coverage tools just to enforce. NYC is a very popular option in JavaScript, but there's many of them. And you can have within your CI pipeline a step that says if coverage is less than 80%, 90%, whatever makes sense for you guys, the build will break. So enforcement is also nice in that regard if you want to rely on your testing. And something which I think is super important, and if you do none of the above, do only this one, is to make sure that every pull request we have has relevant tests. We do not code review a piece of code if it's not tested. And more than that, I suggest reviewing code starting with the test, because if the test should document what we're trying to achieve, it's the best way to explain what this pull request should do. So we start with the test. The test should be very readable. It should be behavioral, everything we've mentioned before. And if the test looks correct, now we go to the code and see that we follow the standards and everything. But we start with the test because the test should make sure that everything else is working as expected. We understand what we're trying to achieve here. So these are ways to kind of like enforce everything we've mentioned before, and not just make it like something we say when we start a project and don't follow through on. So that was kind of like everything I've mentioned before was for developers. But in some cases, we have internal stakeholders, which are not developers, and we also want to have some documentation for them. So I brought like 3 different examples. Cucumber is the strongest example. It's something I use a lot. The other 2 are not exactly related to everything we've mentioned, but I thought they're interesting. So I'll just mention them, and you can use it if you think it makes sense for you. There's a lot of information on them. So what is Cucumber? And there's Cucumber.js, which is useful in JavaScript. So again, it's useful when we want to share our internal documentation, which in the case we've mentioned until now is testing. But some people, there could be solution engineers, product managers, maybe even QA engineers, stakeholders we work with that are not accustomed to how we write tests. Code is not that native to them. We can use something like Cucumber, which allows us to describe our tests in plain English, like you see in the bottom. You can describe the scenario. You can start what given, and then what happens in this given situation. And behind the scene, you connect the English, like the keywords, to actual tests, like in this example, which is very nice because you have actual tests that make sure your code is working as expected, but you also have a description, which is very, very easy to read and follow. And here's an example. It's a small portion of a complicated part of one of our services that is in charge of pricing, and our pricing mechanism is very complicated. So we describe all of the functionality, and again, this is like just a small part of it, with different scenarios. So let's say some segment has some rate, and it's this number. And so when we calculate, it should be this, and all the different use cases. And once we have it, whenever someone asks me, hey, how does the pricing mechanism work? I just make a copy of this file and send it to them. And it explains exactly how it works. Also a very nice feature Maybe the product manager has a new feature request or something. I've asked in the past in this situation, can you just add a scenario to the requirement file or features file? And in some cases, actually, it also creates the exact test. If it uses the same keywords and stuff, the test might also be written as is. And if it's not, we can also implement it. But it's very nice to have the PM. We can talk directly on exactly how the code should look like. So this is the extreme version of testing as documentation. It is more time consuming than writing just plain tests. So I wouldn't do it everywhere. But in complicated cases where we have a lot of stakeholders, it's a very nice approach. Something else I thought is worth mentioning is using OPA, which stands for Open Policy Agent. That's the helmet logo is for OPA. It's usually being used not for testing Node.js code, more for testing like Kubernetes configuration and stuff like that, which as Node developers, we also have sometimes in our control. So you can use OPA together with tools like ConfTest to kind of create a descriptive testing for your configuration. So if we have a deployment YAML, for example, we can create some, it's not as plain English as a Cucumber, but it's close to it. And we can use something that will help us describe the configuration, the deployment file, whatever, describe what it should do and why it should do it, and also make sure it does it. Okay, similarly, the same motivation that we've discussed before. Another thing I thought is worth mentioning, this is a little outside the scope of what we've mentioned before, but a lot of documentation revolves around our REST APIs, especially if we have a lot of different Node microservices talking to each other through APIs, and we want to make sure everything is documented so different teams can know what's going on. So obviously there's tools like Swagger and similar that helps us create documentation from our code base. But something, again, I thought is worth mentioning, if we follow the Open API convention when describing our REST APIs, we can create schemas to describe the APIs that can also auto-generate the actual code we will use in the project and also auto-generate testing for that code. And if we work like this, we can start with documentation before we actually have code. So not exactly what I mentioned before, but also very useful. There's a lot of documentation in the Open API and tons and tons and tons of different tools that works with it. If it sounds interesting and if you have a lot of internal REST APIs you need to document, I will definitely go check it out. So to summarize what we've mentioned before, if we write testing correctly, it definitely could act as internal documentation. It can help us understand what the code should do. And as a very positive side note, it can also make sure it does it, as I've mentioned before. We can highlight regression and fixes because as the rule goes, every fix, we need to make sure we have a test that covers it because, fool me once, shame on me, fool me twice. Otherwise, fool me once, shame on you, fool me once, shame on you, fool me twice, shame on me. Sorry. Testing can provide us real-life usages of our code, as we've seen before. If we write our code to very clearly describe the actual use cases, we can also have the data for the actual use case. We should also make sure the naming, the data, the function calls, all of these are representations of how our code will actually be used. And in specific cases, like we've mentioned with Cucumber and such, we can also use it as external documentation, which is a nice bonus. So all of the things I've mentioned does not mean that when properly maintained, documentation doesn't have value. It definitely does, but it has a cost, as I've mentioned in the beginning, and it's for you to consider the cost. And regardless of everything I've mentioned before, as a clean code advocate and as a developer in general, you should make sure that definitely your code should be readable above everything else, actually. But again, we've mentioned in some cases it's not feasible, in some cases it's not enough. So testing can do the make sure that everything is covered. So that's it for me. You can find me on Twitter or LinkedIn or whatever under this handle. I hope you enjoyed the show, and I'm waiting for you guys on the Q&A session to ask me questions. So thanks, guys, and that's it for me.
Thank you, Tal. Thank you, Tal. Let me now introduce our next speaker. Is Jamie Delbick. We're going to see her recorded session, but she's here with us, ready to answer any questions in the Q&A session. She's a software engineer at Adobe, and he's working with AM Assets, a large-scale enterprise cloud service. From her experience building microservices for the multi-tenant cloud service, she became passionate about Node.js and the open source community surrounding it. So I think we are ready here to start her presentation.
Hi, my name is Jamie. Today, I will be giving a talk titled To Mock or Not to Mock, Node.js Testing Strategies. The goal of this session is to learn the basics for Node.js testing. You will learn about the different types of Node.js testing techniques and why they are important. You will see some best practices and some examples from common libraries and frameworks that we use here at Adobe. At the end of the session, you will have better knowledge of how and why to write good tests. A little about myself first. I am a software engineer at Adobe working on an enterprise cloud service called AM. I mainly work on a microservice for this enterprise cloud service that processes files efficiently. The microservice is built on Adobe I/O's serverless platform and is comprised of a bunch of serverless actions written in Node.js. Additionally, as part of a big extensibility push we had in recent years, we got to open source a lot of our code base. This includes some generic Node.js libraries like fetching with retries or getting metrics inside a container that we now get to manage and contribute to. It's been awesome to contribute back to the Node.js open source community. First, I'm going to go over a bunch of different types of tests that are common for Node.js applications. At the base level, there are unit tests. Unit tests test an individual unit of code, like a function or a different method in a library. In this case, you're going to want to use mocks or stubs to test out these individual components or API calls. Another type of testing is end-to-end tests. This tests an entire system without mocking the backend. So for UI testing, this typically means testing in a browser and trying to simulate a user's experience step by step. So you don't mock things like the backend calls, so you can test fully end-to-end. We don't do a lot of end-to-end testing in our repos. We focus more on integration tests. That's because our application is comprised of a bunch of different actions or components that all work together. So integration tests, you can basically test how several different components work together end-to-end without mocking. So you basically check the communication between these different components that rely on each other to test out a specific feature or task. So integration tests, as mentioned, work really well for us because our code base is comprised of a bunch of different components that have a lot of dependencies on each other. Another type of testing my team likes to use is dependent module tests. This basically means you're testing modules that depend on the code you're trying to change. For instance, if we have a change in a lower level library, that means all the libraries that we own that use that library, we will end up running their unit tests with this current version or change in the code. That way we'll know that if there's a breaking change that we didn't realize, it can catch that, which saves a lot of time early on. Additionally, we also know if the dependent module tests are passing, that when we merge and release this change and start using it in the rest of our libraries, we can be confident that it is going to work and it won't cause any of the tests to fail. Another type of testing is performance tests. This could also be known as load tests or smoke tests, but it's essentially testing the entire application under load. And that's basically, you could be simulating different customer use cases or trying to overload the system. Basically, we use it whenever we have a big feature change or something that we've optimized, just to compare the behavior of production code to what this change is that we're going to be making. So the first type of testing I will dive a little deeper into is unit testing. Why unit test? Well, the main purpose is to validate the logic of the code you are writing. Another reason is to catch bugs sooner in the code lifecycle. If you catch the bugs at the unit test level when you're writing the code, that will save a ton of time and money down the line instead of catching it at the point that it's already in production. Lastly, unit tests, having good unit test coverage helps improve the quality of the code base. If you're going to be using a library or you're contributing to a library that already has a bunch of good code coverage, you can be sure that the library actually does what it's supposed to do. So some common libraries you'll see me using today for unit testing. For structuring tests, there's Mocha and Jest. My team actually tends to use Mocha more. Our libraries are a bunch of smaller Node.js libraries, and we just prefer using Mocha because it has a little less of a test setup than Jest. There's also mocking and stubbing in some libraries we use, and we'll see today for that is Sign-On, Knock, Proxy Choir, and Jest has some features built in for that. For asserting or checking or validating the test, there's Chai, Assert, and Jest. Assert is a standard Node.js module, so you don't have to import it, which is really nice. And lastly, there's code coverage tools like Istanbul and Jest. First best practice I'll tell you about today for unit tests is to design for simple and lean testing. This means have the tests all encapsulated. One should be able to look at a test and get the intent of the test instantly. This will lead to fast and efficient return on investment for your tests, because you won't have other people going into the code being confused about what this test is supposed to do, why it's failing. Essentially, a DevOps engineer or QA engineer or you a year from now should be able to look at this code and understand what is being tested. Additionally, for simple testing, having a predictable environment and behavior in your tests so you don't have flakiness. Flakiness in unit tests leads to developers skipping the test or merging with X's in the test column, which is not good behavior. So one good best practice for styling is behavior-driven development style and structure. So this is basically structuring your tests so they read like human-like language. So basically the test name should tell you exactly what the test does. It should tell you exactly what method is being tested, what the expected input is, and what the expected output is. Essentially, so anyone looking at the test, even with little code experience, can understand the purpose of the test. Also, readable assert statements, using libraries like Chai, which are very readable, even for people who are not that familiar with coding. So the first example we'll look at today is the BDD test style. Just a quick note that all of my examples today will use Mocha because that is what my team primarily uses. But there are many other options out there, including Jest, which is very popular. For the BDD test style, we have this outer loop, this outer describe loop that says which module is being tested. I also like to use, which test file is being tested here. So we're going to test this shopping list module. And then in the inner describe loop, we're saying what method we're going to be testing. So we'll be testing the add to cart method. And lastly, at the actual test, we'll say what the expected input is and what the expected output is. So we should add an item to the cart and return the cart successfully. So very easy to follow, very simple structure. Another example for good structure patterns is the AAA structure pattern. This means basically organizing your test into 3 different categories, so it's easy to understand. So the first category is arrange, where you put all of your mocks and imports and setup for the test. Then there's the act section, where you will actually run the method. So we run the add to cart method. Then there's the assert section, where we will check that the result is valid. So just some more testing techniques. Do test exported functions. So whatever your library says in the README or whatever APIs it exports, definitely make sure to test those. Because if you don't have good unit test coverage for those, someone could go in and change some of that code or functionality and then not release it as a breaking change or not realize that they changed functionality that other clients that are using the library rely on. What not to aim to test, internal functions. So these can be like helper functions or internal abstractions about how your code works. This is good still to test if you do have the time for it, but it could lead, if you do test all of your internal functions, whenever you do small refactorings, that could lead to a lot of these tests failing, which could make developers frustrated and lead to skipping tests, which is not good behavior. Another thing to aim to test is functionality. So a good way to make sure you are testing functionality is to use test-driven development. Think about ahead of time, what does this library do? Think about all the error handling cases and the different cases, and then write the code. That way you're aiming to test all the functions instead of aiming to test every line of code. So again, what not to aim to test is every single line of code. Also, what to test is edge cases. So unit tests are the place where you can kind of manipulate and mock to get certain actions or steps to be taken in your code that are maybe hard to reproduce in an integration test or end-to-end test scenario. So unit tests are the place to test this. Also, what not to test is supporting libraries. Any libraries that you're bringing in, if you're writing unit tests for them, you're doing the work that those libraries should have internally. However, it is still good to validate supporting libraries, downstream services, but that place to do it is in end-to-end tests or integration tests. So supporting libraries, don't waste time testing those in a unit test scenario. The next best practices we'll talk about are mocks, stubs, and spies. So why would you use these in your unit tests? Well, it is to have predictable behavior and force the code down a specific path. As mentioned, you could simulate situations that are hard to reproduce in a unit test scenario that might be kind of edge cases. This could be things like simulating a server being down with a 500 error, or simulating a server being overloaded with a 429. Mocking really helps with that because you don't want to actually overload your system in an end-to-end test to get a 429. You're basically just supposed to mock anything that is beyond your control. So any sort of backend API call, a call to a database, that should all be mocked so that you can have a predictable and controlled environment in your unit tests. So some examples, mocking HTTP calls with knock. Knock is a great library for mocking HTTP calls. So if your library is calling an HTTP request directly using like node fetch or Axios, then using knock is really helpful in your tests. So in this case, we have the shopping cart add to cart function that calls this database directly. So in this test, we're going to be knocking the database to return a 401 unauthorized. Then we call the method and expect it to throw with this 401 error. Again, another good testing technique that's added in here is to use like expect throws and or assert throws instead of try catch. This is just a bit more readable. So another example we have is stubbing a method with sign-on. Sign-on is a very helpful library for things like stubbing and spying, basically to manipulate different functions to have different results. So in this case, let's pretend that we're not actually calling the HTTP request directly, but we're using some library CartDB client. So in this case, instead of mocking the HTTP call directly, it makes more sense just to stub this client library update cart function that under the hood calls the HTTP request. Here we stub the update cart method, which ends up throwing 401. And then we expect the result to be a 401. So here's an example of an anti-pattern with stubbing. So in this case, we are, again, using the shopping list example. We are trying to stub the add to cart method. And this add to cart method, we are saying should return a 401 unauthorized. Then the method that we are testing is the shopping list add to cart. So essentially all this code does is call our mocked function, which is not very helpful. I know this seems like an extreme example of stubbing gone wrong, but it's important to call out to make sure you're not over mocking and to the point where your code isn't actually testing anything. How much testing do we really need? Best practices typically says to aim for 80% coverage. And you could find this coverage by using tools like Istanbul or Jest to report how much code coverage you have. But the idea is if you have 80% coverage of your code, that probably means you've covered most of the functional aspects. But it's really saying, you don't need that extra 20% that might be some lines of internal code that could change often. So if you aim for 80%, you'll probably have good code coverage with a good return on investment for testing without spending tons and tons of time trying to get that 100% coverage. So always aim for functional coverage of your code, and the coverage should come along with it. So here's an example of using the code coverage tool by Istanbul to have a code coverage report after your test run. So it's super easy. You just install the dependency and then add the prefix in front of your Mocha call, and you'll get this nice display of how many lines have been tested, how many functions, and it even says the uncovered lines. So if you're not sure where your test set is missing coverage, this helps. The next section I'm going to dive deeper into is integration tests. So as mentioned, my team uses a lot of integration tests. And a lot of people, think, oh, it takes too much time to create integration tests, or they take too long to run. But here are some reasons why you might want to add integration tests. So it validates communication between several different components. So this is typically to test specific features, and you'll be testing these end-to-end without mocking. So it's really important, especially if your code uses a lot of different downstream dependencies, to have some tests running that aren't using mocking. And it also just ensures that all these different pieces work together. So some common issues that people run into with integration tests. The first is flaky tests. So this happens a lot even in our code because we call a lot of different downstream dependencies, and there could be network errors. So what we do is we add retries to tests that are known to be flaky. Another good idea is to run inside a container or a VM, so you have a predictable environment to run the tests in. Another issue that people run into with integration tests are that they're very long running and they take a long time, which slows down the development process. So what you can do is you can run tests in parallel. I'll show an example soon about that. Another issue people have with integration tests is that they're very heavyweight. They take a long time to start up and have a lot of files that are large. So what we do, since our microservice processes assets, is we store all the files in cloud storage. So we're still able to test some large files in our integration tests, but they're not living in the repo with our integration tests. So that helps a lot with just starting up and running the tests. So here's an example of retrying tests with Mocha. So Mocha has a really easy to use method to add to your tests that will retry everything. So this .retries, add that line in, and then it will retry everything in the describe loop or in the describe function if it fails. So in this case, we have a flaky test that processes a larger image that we know sometimes could fail. So to help with the flakiness, we added retries, and we also added the timeout to be longer than the default for Mocha tests. So both of those help reduce flakiness. Here's an example of parallel tests with Mocha. So if you're using Mocha version at least 8, you can just add the parallel flag to your Mocha command, and it will end up running all the different test files in parallel. So the only thing is, well, we actually ran into this where our integration tests were all just in one file. So we did have to do a little bit of refactoring to get the parallel test structure to be useful, since it just runs each test file in parallel. But after that, in our use case, our integration tests were running for about 15 minutes, and now they only run for about 5 minutes. So it really helped decrease time for us. The last section I'm going to talk a bit about is continuous integration and continuous deployment. So after you've written tons of amazing tests at the integration level, the unit test level, end-to-end, a way to make this more useful and save even more time is to use CI/CD. So the main purpose is to save developers lots of time, automate processes like running tests and releasing. Lastly, it also makes the review process for PRs a lot easier. If I'm reviewing a coworker's PR and I see that all the tests are green, and I know that we have really good unit test coverage and our integration tests cover most of our customer use cases, I can be pretty confident that these changes are going to be okay in production. So here's a look at what our continuous integration looks like on one of our open source repos. So we use a combination of different CI tools. For our open source repos, we use GitHub Actions, and for our internal CI runs, we use Circle CI. But there's a bunch of other tools out there like Travis, Jenkins, and others, and they're super easy to set up. So what I like about GitHub Actions, which we use for our open source repos, is that you can define a matrix of different node versions. So you can see we have those 3 build steps there that run our unit tests in different node versions. That saves a lot of time in the developer process because you don't have to use NVM and test the unit tests in every single version locally. Another thing that we have on our CI is a size watcher. This is pretty cool because, like I said, our microservice processes large files efficiently. So what we have run into before is accidentally pushing some large files to our code base. So size watcher helps with that, as well as also just making sure that outside contributors don't try to commit any weird looking files that are very large or something like that. Then we also have the semantic release, which only runs on merge to main branch that I'll talk about next in the continuous deployment. And then we have these two internal CI steps. So the first one is dependent module tests. So I kind of described this earlier, but on every PR to one of our repos, we have an internal list of all the dependencies that this relies on, that use this library that we own. And what we do is we actually npm pack and start using the changes in the PR in those dependent modules and run all of those unit tests. So as mentioned, this helps us find things like breaking changes and other gaps in our testing. Lastly, we have the integration tests, which, similar to the dependent modules, we take the code that has changed inside this PR, and we end up propagating those changes all the way up to the top level of our application. We end up deploying all the code to a unique dev endpoint for our service, and then run our integration tests. What's also nice about getting this unique dev endpoint is if there's any things you want to test manually with these changes, you can just take that dev endpoint and test our service on there. So it's super helpful, and it happens on every single commit. So you can automatically know that merging this PR probably won't have an impact on production. The last thing I'm going to talk about is continuous deployment. So you saw there we have that semantic release job, which runs on merge to main GitHub branch, and it will automatically release the Node.js library according to our commit conventions. So we have specifically defined conventions for breaking release, bug fix release, or if we don't want to do a release for those changes. As well as automatically releasing the libraries, we also have a tool that we use internally for cascading release. So let's say we make a change to one of our open source libraries. It's just a script that we run internally, and it'll end up propagating those changes and releasing all the dependent modules all the way up to our base application. So that, again, saves a lot of time. Then after that, we have weekly deployments, where we have the chance before deploying to run some performance or load tests, just to be sure that everything we are bringing to production is well tested and won't have an impact on our customers. Thank you so much for attending this talk. There'll be a Q&A session coming up later, so please stick around. And also feel free to reach out and we can continue the conversation on LinkedIn or email.
Okay, thank you. So I think we are ready now for the Q&A session. I'm going to add our great speakers to the stage. Hi, Jamie. Hello.
Hello.
Hi, guys. Okay, so all about testing. That's a great and very, very, very important topic, no? As you said, at some point, at this point, it will be a shame if developers are thinking that tests are not in our court. No, it's our responsibility always. So it's a great topic. Okay, we have some questions, and I believe we can try to share together our opinions because all of them are on the same topic. So let me start with the first one. So do you think that unit tests will replace documentation? Let's start with David.
Yeah, so I feel like Tal's talk was kind of, this is maybe his thesis, so he's probably better to answer this. But after hearing his talk and with tools out there like Swagger, I do think that, you know, there are opportunities to automate some of the documentation by using some of those libraries based on stuff you've written in the code or tests.
I'll just say that, well, I talked 30 minutes about this exact issue, but generally speaking, I think it really depends on your use case. If you have technical writers in your team, and there's like many different stakeholders and documentation is super important, maybe unit tests will not replace them. But in most teams, you have mostly developers. Testing is something we already do. So we can spend some energy with what I've mentioned, what Jamie have mentioned, and replace most of the documentation needs with testing, but not unit testing, mostly integration tests that are kind of like more use case driven.
Okay, and my experience with this is especially on the teams that I'm managing. I have a team that is in charge of QA, and having the opportunity to do the BDD, to write the tests like in plain English, as you said, helps a lot, because then they can basically write the scenarios, and then someone afterwards implements the test. So this is also a good way not to have it. But in terms of documentation, I have a follow-up question here. Is the target audience for this type of documentation is relatively technical at some point, no? So it's not really meant for stakeholders, no? And for stakeholders, as you said, these tools can help, but yeah, there's always something like an even nicer, no, that people wants to read, to see drawings and so on. So probably not this type of documentation is more for the technical side, because that's the people who is going to maintain that code. No, I think I don't know if you agree. Okay, next question. Okay, for both of you, also considering that end-to-end testing could be quite expensive, what is your take on alternatives such as contract testing, for example?
You want to take it, Jamie?
I'm not super familiar with this topic, so maybe Tal, you want to?
Yeah, sure.
Yeah.
So contract testing is actually, it's funny because it's something we've tried to make work for like 2 years. It never happened, but I think in general, it's a great idea. For those of you who doesn't know, contract testing means that if I have, let's say, a REST, like an API client and an API provider, instead of actually testing that the client is getting to the provider and getting back, I define some contract. For example, we can use the CDC approach, which is consumer-driven contract, which is very interesting if you want to read about it. And then each side of the contract is testing against the contract, and that way we know everything should work. So it works much faster, but it has a big overhead on maintaining all of these structures. And also you need to make sure you have like the mock server for CDC, for example. There's a tool called PACT, P-A-C-T. So in your pipelines and everything this needs to be part of it. In some cases, it's just like much easier to just call the actual service. So it's a trade-off between runtime and managing this, but contract is usually stronger in a sense where we can prevent things from breaking before they happen, because sometimes we test things end to end, and then one of the sides break the contract, but maybe that's the side that test will continue to run. So we don't know. So if you want to make sure we have a contract that will never break, using a contract testing is very important. So it, again, like a trade-off. If you have like very clear contracts that are very important not to be broken, contract testing is a great idea.
And I don't see it as really as an alternative. I see it more as an additional type of testing that you need to do at some point, no?
Yeah, we actually, I didn't know the meaning of it, but we actually do some contract testing in our code base. So the reason we actually use it is because we run some tests inside a Docker container. So we set up a mock server to mock some of the external calls there, basically with the contract testing method. And it works really well, but we supplement that with integration tests and end-to-end testing as well.
Yeah, right. Okay, next goes for Tal. Is there any full tool for OpenAPI documentation from tests, for example, in
Ruby on Rails, I think.
No, there is a gem called Swag, which creates Swagger documentation from the tests you built.
Yeah, so if you Google, I'll try to look for it in a minute. OpenAPI tools, there's like multiple different like tools, and it's a very common convention. So yes, there is such. I don't remember the name. I can quickly look it up. Maybe I'll do it during the next question.
Okay.
But yeah, it definitely exists. There's probably more than one, but I'll try to look it up quickly. And we can continue the next question in the meantime.
Yeah, no worries. Okay, let's see, Jamie. Despite of having just more setup in Word, given that it's provided everything, at least that appears to be the case from the table you provided. Let me read this again. Despite having just more.
Yeah, so when I was going over the different types of libraries to use for different things in unit tests, like structuring, asserting, mocking, I did happen to list Jest for all of those categories because Jest has features for mocking, and it has features for asserting. So it is kind of a more comprehensive approach where you can use Jest and not have to import as many separate libraries. My team, though, our code base uses Mocha, and we have tried to switch to using Jest or contributed to other libraries that use Jest, and there's just a bit more setup involved in configuration. And if you have a very small library, for instance, we have a library that basically only uses Mocha, and then we use the built-into Node.js assert module where you don't need to actually put it in the package JSON. You could just import it in the file. So for smaller libraries, since we're used to Mocha, we just prefer using Mocha and just importing the other libraries separately.
Okay, good. Okay, next question. Our tests are spread across the code base, and it may be hard to grasp the whole product by just going through the tests. Docs are supposed to be well structured, easy to read. Any thoughts on that?
Oh, so interesting question. And just on the previous note, if you guys Google whoever asked that question, OpenAPI tools, there's actually a site called OpenAPI.tools. It's divided by topics, like tons of different tools just go through it. So what happens when you have like different parts of your code base and flows go through all of them combined, and it's very hard to figure out. It's hard to kind of like answer out of the top of my head because it really depends on your architecture. In many cases, if you don't start off your architecture with a testing strategy on how you're going to test this end to end, you might reach a point where it's like difficult. So I would recommend, if possible, to think about this up front. Maybe we can do it a little differently. But yeah, if your code is such that tests are just not applicable as documentation, use documentation and just document the way they interact together and make sure each one of them doesn't need its own documentation. It's tested as a unit. And you can also add tests that are outside of your code base, like automation tests that actually do end-to-end flows between all the services, and then maybe they can describe documentation, but they are costly, like we mentioned before, because they take a lot of time to run. So, like everything we have in software, it depends.
Yeah, exactly. Trade-offs.
Yeah.
Jamie, this question is for you. Should we use a stub if we have just spy on?
So as mentioned, my team doesn't really use Jest very often. I've only used it in a few scenarios, and we much prefer to use Mocha. So this spy function looks like you're basically just trying to spy on a function. So typically for spy, it's just seeing if the function was called, a certain amount of times, versus stubbing. You'll want to use it to actually change the response of the method. So if the test is using spy on, you're just probably trying to see if the test was called, with what parameters or whatnot, and not actually trying to change the response. So it depends on the case of the test.
Okay. Tal, you mentioned having helper functions for organizing tests, but it makes the test error prone. So you may have to test your test. That's a good, yeah.
Okay, but so end of the day, I get what you guys are trying to say, but end of the day, if the test works, it means that the helper function works. So I usually don't test the helper function within the test because the test runs them. Like if you do a coverage, right, it is being used. So there's no need to test it. If, for example, you take this helper function and you use it as an external library to be shared between different projects, in that case, I would test it because it's like a standalone, right? But if it's part of the test, no need to test it.
Yeah, I think you mentioned it's just extracting from the code, so the code is not bloated with things that are going to make difficult to read. No, it's just extracting to a library. No.
Yeah, and by the way, on this topic, it could be error prone, and I didn't mention it in my lecture, but if you can use TypeScript or typing in any way, it makes the helper functions much less error prone because we make sure the things we're constructing are exactly what the function is expecting to get. Because it could happen that this actually happened to me when the code changed, but the helper mock creation function did not change. And now the code, like the tests are continuing to be green and the actual production code breaks because it's not using the exact same model. So actually typing might help here. But it's kind of like a different topic. It kind of like, as long as you're testing exactly what the code should look like, your helper functions are tested by definition.
Okay. Next question for both of you. What are your thoughts on mutation testing?
I'm not sure if I know the term. Does it mean, do we want to test if there is mutation in the code? I mean, I assume that's the case.
Yeah, it's like a white box testing in where the developers change some parts of the code, like the results of the code, assuming there's going to be like a mutation at some point of that code, no? So it's like redefining, or extending the methods and then adding something there, no? So our tests are ready for that type of mutation.
Yeah, I mean, like
ahead,
all types, like, mutation testing or other things where you're trying to just, I mean, mutation testing sounds interesting because it's like the case, it seems, where maybe someone comes in and extends a method to do something malicious or unexpected. I mean, it's always good to test these kind of scenarios if you have the time for it. But I think if it's not central to like the way that your code functions and how people are using the code, there is that trade-off where it's like, do you want to invest time in testing something like this?
Yeah, so I agree. I would, again, like I've mentioned in my talk, if I'm not building some like very like key component, like an external library people will use, stuff like that, I want to focus my tasks around the actual use cases my code need to do. And that's it. So that's what I'm testing, what the code should do. If it's not something the code should do and it doesn't work, it doesn't matter.
Okay. Okay, another question. With having less mocks, you may end up testing the same code implicitly over and over again. And if it fails, tons of tests fail and it's hard to figure out what is the problem. What do you think? It's really
Yeah, this is interesting because I feel like we've actually run into this in our code where maybe we weren't mocking something and then some behavior changed. And then all of a sudden you see like, 80% of the test cases failing, which at that case, it's usually pretty obvious to figure out what changed. But I mean, I am a fan of mocking at the unit test level. I prefer to mock, or the standard is to mock everything that you can't control. So like as Tal mentioned, in one of his examples, they didn't end up mocking a database because it was something that they controlled, but then they did mock the other external calls. So I think as long as you follow those methods and you mock the things that you don't have control over, supplemented by end-to-end tests and integration tests where those aren't mocked, that's a good way to go. And if you focus on that, then you'll end up mocking what you should be mocking and not over mocking or under mocking and running into issues like this.
Yeah, I'll just add that some cases, like the risk is that I'm mocking something incorrectly and my code actually does not work while the tests are green. So that's a bigger risk for me than having the same thing run over and over again. Again, depends on the trade-off. Some things might be very slow. Our tests should be quick. So this could also be something I would consider. If like there's a very large portion of the code that takes forever to run, maybe I would mock it in some cases just to make sure we're not doing it over and over again. Because if the tests are slow, no one will run them. So we need to make sure their tests are fast. I didn't mention it because it's not related to documentation, but it is important.
That's right. Yes. So we have a follow-up or continue question regarding the test of tests.
Okay.
So I bent the helpers that accepted different params kind of config for the test input, which means apparently there are certain conditions in the helper. And there's a continue. In short, the more logic you have in helper, the more error prone it becomes.
So I understand like this thought process, but I would just say when I'm writing tests, I'm not like trying very hard to have like helper functions across all of my tests. I might have helper functions in different tests that are almost identical, but just for the sake of keeping them simple, I will have like duplicates with small changes. So it doesn't mean we're trying to build a very complex helper function logic. I agree. We should make it as simple as possible. So most methods will just be creating some object, assigning some values. Mostly that's it. So there's not much to it. So this is like an example where I would try to avoid, don't repeat yourself. Here, I would repeat myself to make things simple.
Yeah, I mean, the best practices will say keep your tests all encapsulated. So, without using helper functions, try to have everything in the test. But we also run into that too, where we have a lot of shared code. So we do have some shared test functionality, helper of the test function. So it really just does depend on the test case and your situation, because it's not always that you should follow the all encapsulated rule. There are situations where it's better to not repeat as much if the test cases are really repetitive.
Yeah, and your helper function could be within the same testing file, just not part of the test, just like below or something. That's usually what I would do.
Okay. We have another question. Do you have any recommendations on how to add integration tests to a project with serverless architecture with many lambdas?
So we have integration tests. So I work on a microservice that's built on Adobe I/O Runtime's serverless platform. So our code is deployed into a bunch of different serverless actions. And so our integration tests basically test like starting at the endpoint of our service. And so then internally that ends up going through all the different serverless actions. So we don't integration test like each serverless action. We integration test like our different like path of the cert, like the whole endpoint, basically. So that's what we do. If you want to test like, and so what we do is this is running inside a container, and we just run like HTTP requests to our service. But that's kind of our use case. But at the unit test level, they're kind of like half unit test, half kind of end-to-end test. But to test our specific actions, our serverless actions, which have like their own Docker file component and some Node.js code, we run them inside a container, and that's kind of how we accomplish the serverless. We bring up the container, pass in the parameters, run the test, moving the test files into the container, and then when the test is over, we bring down the container. So that's kind of how we do that in our serverless architecture.
Okay.
Yeah.
Tal, do you have some useful information or tools for automation testing in Java? We know that we are in Node.js Summit, but we are.
Yeah. So I think someone mentioned, actually asked me like on LinkedIn actually just now, and I answered. Basically, there's different tools, different things to read, but I think in general, what I would recommend is to follow like the guidance we've discussed today, because it's like general guidance to make sure the testing is readable, that we can read it as high level like steps of what the testing is doing and extract common things. In automation, we'll extract things between different testing, mainly, object creation, stuff like that, which is very, very repetitive. Maybe the tests themselves are like a first step that is common, and then a second step, which is different. So I would try to make it very readable, very step-by-step, rely on like what the code should do and not on the implementation, not to expect how the Java code works internally or whatever we're testing with Java, to rely as much as least as possible, on how the thing we're testing is built. Like try to build, because this is automation testing. We want to test it from the outside. So I don't recommend for specific tools, just like use whatever most comfortable for you, most performant. Just try to make it readable, because it is code that you're writing as someone else. We need to change it and make sure I understand it. So, try to make it readable. I hope it's helpful. I don't know.
No, I think so. For automation, it's interesting. I'm using lately like a combination of different tools. No? We're using Cucumber for some reporting of those tests, Karate in my case, and it's not really related to Java or linked to Java. No, it's just like a framework that you can use to run your automation tests. Okay. Next, and I think last question is testing internal function calls. How would you suggest testing things which are not part of the output, but very important, like sending data to some cloud, or how you are going to verify that the call was done?
Yeah, so if it is very important and it's maybe hard to reach from like testing the function that's exposed, then this may be a scenario where you do want to test the internal function. There's tools to test internal functions like rewire that aren't exported. And then you would want to potentially mock the call to the cloud if it's not something you have control over that's reliable at the unit test level. So in certain cases, in our code too, we do use rewire and other tools like it to test specific methods that are internal. It just, the only trade-off there is, if you do some refactoring, you might risk having to update or change those tests, which could be annoying to other developers on the team. But there are trade-offs there. If it is something that's important, it's definitely important to test.
Yeah. I agree with everything you said, Jamie. A couple more things you can do in some cases is if you have, like, let's say you want to send data to some client, so you have like a client class or function that is responsive for that, you can mock that function and make sure that everything up to that function works and it's being called correctly. And what you can also do, like Jamie mentioned in her talk, you can use like an external mock server or something like that to represent what you're trying to test. So for example, if you use AWS S3, you can use local stack and stuff like that. It comes up in your container environment, and you test against it as if it was the cloud provider. So your work actually, your code is actually doing everything it should, and it's just like you're testing the external endpoint, mocking the external endpoint. Sorry.
Yeah. And I will add, or I will ask an additional question to that and is regarding the mock servers that you probably have experience with. Maybe you can mention some of them. I know that there are many, but I don't know if you have any recommendations.
Do you have any, Jamie?
The one that we use is this pretty generic mock server. I think it's literally just called mock server. But what we like about it is, well, you can run it inside a container and connect it via Docker networks to be like attached to the container, which is cool. And it's very versatile. You can mock any endpoint. So that's the one that we use and have had a good experience with. I can share the link to it.
Thank you. Okay, Tal, I don't know if you have any.
I think we use something else, but I don't remember the name. We also use local stack we use a lot of AWS things, so it's kind of like, as a replacement for that. They're mostly the same. Like, pick one that you like. It's
exactly.
Yeah, if it works, keep using it.
Exactly. Mock server is the one that I use too, and it's very good. As you said, it's very versatile. Okay, guys. Thank you very much. It was a great speaks and a great discussion. Now I really like it a lot. I learned a lot with you guys. Thank you very much for your time, and thank you to the audience for being here with us. I think we have some minutes to transition to our next sessions. Just some time for you to say goodbye, guys.
Bye. Thanks for the question. Great question, guys.
Yeah, thanks. Feel free to reach out. Thank you. Bye.
Bye.
Bye. Okay. So that's it with me for this section. I think I should transition this now to Tyler. So, or to Mike, I think.
Now we will have just a few minutes, 6 minutes of break, and then Mike and Tyler will start the last block for today.
Okay, thank you, Anna. So let's go for the break. Thank you, everybody. See you later. Bye.
And now we want to say a huge thank you to our sponsors at Scout. As the application engineering landscape continues to evolve, the state of observability has become more and more exciting. With tools like Scout, you can get insights into your stack without having to be an observability expert. OpenTelemetry is a new open source project providing a unified standard for telemetry data such as metrics, traces, and logs. With power of OpenTelemetry, Scout is building a new observability platform to help simplify telemetry data into actionable insights and is now accepting beta testers. If you want to know more about OpenTelemetry and become a beta tester for Scout new observability product, go to scoutamp.com/observability, and you can find this link in the chat right now. Thank you, Scout, for joining and sponsoring us.
Hey everybody, this is Mike. Oh my word, this is I don't know how many. I love moderating, guys. I love the speakers. And before I start, I just want to say a super duper shout out to Geekle. We all know they're doing such an amazing job, guys. Okay, everybody give them a clap. Yay, they're doing so awesome. Okay, let's move on. So I got a really cool, awesome speaker with me on this one. I have Tyler Hawkins, and I'm going to bring him in there. Hey, Tyler, what's going on, man?
Hey, Mike, how you doing?
Where are you? Where are you located anyway? Where are you?
I am in Utah. Good old
You're
US.
You're in Utah, dude. I love Zion National. Okay, for a minute, offline. I love Zion National Park. I love your parks. They are the most super amazing parks, aren't they? I love your state, by the way.
They've got some good hiking, good skiing out here too.
Oh man, I know. Okay, that was just a little advertising right there for Utah, right? Just kidding. Anyway, Tyler, what you got for us today? What are you going to talk about?
So we're going to talk about the Node.js event loop. It's all about the internals of how Node works.
Man, that sounds so super cool because I saw what you were presenting. I said, oh man, I am going to pay attention to this. So what I'm going to do here, I'm going to bring in your slides. I'm going to get off stage and you got it, bro. Have a real good.
Awesome. Thanks, Mike. All right. Well, thanks everyone for being here. I'm excited to talk to you guys today. So as we said, we're going to talk today about, the talk title is Understanding the Node.js Event Loop. We have a whole bunch of code examples to go through today. So if you want to follow along or just play around with this afterwards at some point, you can find the GitHub repo. It's at github.com/thawkin3/Node.js Event Loop presentation. Just briefly a little about me. My name is Tyler. I'm a senior software engineer and tech lead at Adobe. I've been doing software engineering for about a decade now. If you want to connect with me, you can find me on LinkedIn or Twitter. I also love to write, so you can find me on Medium and several other tech blogs as well. So with that, let's dive in. So we're going to talk a little bit about, first off, the JavaScript event loop, as opposed to the Node.js event loop, which are in fact two separate things. And so if you were to Google the JavaScript event loop, what you'll find is about 50 results, all of the same variation of this image. Everyone loves to create this exact same little diagram. But this is a very simplified model of how the JavaScript event loop works. And with the JavaScript being single-threaded, the event loop is what helps JavaScript with concurrency and being able to do things asynchronously. So when we talk about code, we have synchronous code that basically reads top to bottom, and then we have asynchronous code, so things like callbacks and promises or timers, so things that can get kicked off, they wait for a little bit, and then eventually they run. And so the event loop's job here is really to coordinate the work between a couple of different things inside this model here. And so looking through the diagram, we have this heap, which is really just like this somewhat unstructured set of memory where you can, where all of your objects and functions and variables get stored. You have a call stack, and as your functions get executed, they are pushed onto the stack. And then as they finish executing, they get popped off of the stack. And so if you think about the stack, the data structure type, right, it's a first in, last out data structure, or last in, first out. You can think of it like a stack of dishes as it piles up, and then you take the top dish off the stack until you're left with nothing. And then we also have this callback queue, which a queue is a first in, first out. So you can think of a queue as a line at a checkout aisle. First thing into the queue is the next thing to go out. And so with JavaScript, as functions are being called, they go onto this call stack, and then they might make some external calls to these web APIs. So things like interacting with the DOM. So maybe this is again in the browser, and so the DOM, maybe a user clicks on something, and that would then trigger like an on-click callback. You might make an API request, so something with Ajax. You're going to go make a network request, grab some data, and then come back with the callback that executes after this request finishes. Or you might have some timers, so something like set timeout or set interval, where you make sure that there's a delay, and then as soon as that delay happens, the stuff goes onto the callback queue. And so the event loop's job here is really to monitor the stack and the callback queue, and to control the execution of the order, or the execution order of when these functions are called. And so as long as there are things on the call stack, the event loop is going to just keep executing those functions. And then once the call stack is empty, the event loop will check if there's anything in the callback queue. And if there is, it'll take that next method, it'll pop it or push it onto the call stack, and then start executing that. And then once that call stack is empty again, it'll come back to the callback queue, grab the next thing. And it goes on in this loop pretty much as long as your program is running. And so if you wanted to look at, maybe an example of something filled out, maybe you have some example code where you have a method foo that gets called, and then foo calls bar, so that goes onto the stack. And maybe bar makes an API request, so it comes over here, so it kicks something off to this external web API, and then also calls a console log. And then these will finish executing, so the console log is gone, that gets popped off the stack. Then bar will finish executing, that gets popped off the stack. Foo finishes executing, that gets popped off the stack. And then eventually we're left with maybe this API request completes, which then pushes this callback method into the queue. Call stack is empty, so the event loop picks that up and then puts it onto the call stack. And so that's the simplified model of how the event loop works. If you're like me, I like working examples a lot more than just looking at diagrams. And so to help understand some of these concepts, we're going to run through several code examples. And so we'll get a good feel for how this JavaScript event loop works. And then from there, we'll start digging more into the Node.js event loop, which is a specific implementation of this event loop. So let's dive in. Let's do some code. So for all of these examples, they're going to be relatively straightforward, pretty short and simple. If you want to play along at home, you can guess the order in which things will run, throw it in the chat, or just think about it. And yeah, we'll run these and we'll talk about them. So let's start with the first one. So this is synchronous code, extremely straightforward. We've got three methods here, first, second, and third. That's simply console log. And then we call them first, second, and third. And so if we were to run this, we'll execute over here in the top right, exactly in the order you would expect, first, second, third, right? And so synchronous code, it's read pretty much top to bottom. They'll execute in the order that they're written. So no real surprises there. So now let's look at the second example. So synchronous code, we have things like loops, so like a for loop or a while loop or a do while loop. So what if we ran this in a loop? We still have our same first, second, and third methods. And so what we'll do is we'll call the first method. And then inside of a for loop, we'll call the second method 5 times. And then we'll call the third method. So what's going to run here? So we're going to run this. We'll go to our second demo. And you can see it executed in exactly the order you would expect. We've got our first, then we're in this for loop. We're running our second method 5 times, and then third. So again, this is synchronous code, which is also known as blocking code, where the code isn't going to move on down the screen from top to bottom until the functions have finished executing. And so we're basically stuck in this for loop until it runs out, and then we can move on to third. So far, we've had functions that don't call each other. They just do their thing, and then they're gone. So looking at something more involved with the call stack is maybe you'll have a function that calls another function. And so in this case, we have our first function on line 1 that just does a console log. Our second function is going to do a console log, and then it will call the third function. And then the third function will just do logs, and same with the fourth. And so now as we run our code on lines 9, 10, and 11, let's see what happens. So let's run this demo. And again, it's going to run in pretty much the order you expect, hopefully. So we've got first, we've got second, and then second then calls third. So console logs that. So it's, again, kind of building up that call stack, and then the functions are being popped off as we go. And then we get to fourth. So again, we're still in synchronous land here, just running stuff top to bottom. If you want to look at a slightly different example with the call stack, rather than calling third directly, maybe we update the second function so that it accepts a callback and then executes that callback. So now with that exact same setup, we're going to call first, then second, which will then call third, and then fourth. So if we were to run this again, you can see we're still in the same order that we expect: first, second, third, fourth. And so that's synchronous code. And so when we want to start thinking about asynchronous code, one of the first methods that we can think about is set timeout. And so set timeout is a method that will allow you to execute a function after a certain number of milliseconds have expired. And so let's run through this one. So we've got our first, second, and third. Again, they all just do console logs. We're going to call first. Then we're going to call set timeout to execute our second function after 1000 milliseconds or 1 second, and then third. And so if we run this example, you can see we've got first and third, and then second is run. And so now we're starting to get into this asynchronous nature of JavaScript. And so first ran, and then the call to set timeout ran, but it doesn't execute this function immediately, right? We're going out to these external APIs where it works its magic, and then we'll eventually push it onto that callback queue. And so while that's happening, we're just going to continue down the screen. And so then it gets to third. And then after the second, after the 1 second has expired, it will run second. So then you might look at another example. Maybe we have a set timeout, and this time we say 0 milliseconds. So what's going to happen here? We call first, then set timeout with calling the second method with 0 millisecond delay, and then third. Just a second to take a guess. All right, we're going to run it. Okay, so we got first, third, second. Now this is where it might surprise some people that are maybe new to JavaScript. And you might think, why did second run last? If it's a 0 millisecond delay, why not just execute immediately? And the reason for that is if we think back to the event loop, is that it's going to execute first, then it's going to make the call to set timeout. So it's going to go over to the web APIs, and then it will push that once the time has elapsed of 0 milliseconds. It'll push that onto that callback queue. But we're still working through our call stack right now of just this main module that we're executing. So we're still going to run third. That's going to execute first. And then now that the call stack is empty, we can then, the event loop will pick up the next thing off of the callback queue, and it will then put it onto the call stack. And so that's where we get this delay. And so this is a useful method if you want to delay the execution of something to the next tick of the event loop. So there we go. That's set timeout. So let's look at one more with set timeout. And with this one, we're going to try to block the event loop. So again, we still have our first, second, and third methods. They're just going to do some console logs. So we'll call our first method, and then we'll call set timeout with second, again with a 0 millisecond delay. And then we're going to call third inside this while loop. And what this does here is basically just creates this while loop that's going to be blocking the main thread for 5 seconds. And so let's take a look at what happens here. Okay, you can see it's running third. It's going to keep on running that for 5 whole seconds. And then we finally get to second. And if we scrolled all the way up to the top, you'd see that first was the first thing to console log. So this demonstrates another interesting principle and a good point is that when you schedule something with a timer, so something like set timeout, this number here that you've put for the delay is not a guarantee that it will run exactly after, in this case, 0 milliseconds, or exactly after whatever time you've specified. What it guarantees is that it will run at some point after that time has expired. And so by blocking the event loop here and running this synchronous code, we're essentially delaying the set timeout from running. We're just feeding stuff onto the call stack endlessly for those 5 seconds until it's finally done. And then we can pick something up from the callback queue and push that onto the call stack. So good principle there is that it's not a guarantee for that exact moment, just sometime after that moment. Okay, and then for completeness, we could look at set interval as well. We'll clear this out here. So set interval does pretty much the exact same as set timeout. except for interval will run basically in an infinite loop. It will continue to execute your method after a certain or every specified amount of time. So you can see here we're going to console log first. Then we're going to set up some stuff for our second method, which is going to be run in an interval, and it will simply console log second up to 5 times until we clear the interval. And then we'll run third. And so if we run this demo again, so we've got first, third, and now it's going to log second 5 times. So nothing too surprising here. This is the exact same behavior as set timeout, except for we're able to run in this interval, having this asynchronous loop happening. And then just for completeness, if we wanted to do that, add 0 milliseconds as well. You'll see that it functions the exact same as set timeout, where it's not going to happen exactly after 0 milliseconds, but it will be some point after 0 milliseconds. So we can run this again. We've got first, third, and then second. So again, it will go to the timers API and then go to the callback queue. And then once the call stack is empty, we'll pop it off. Okay, so now let's look at one more set timeout, just for completeness here. The thing about the callback queue is that it is a queue, which means the things that get pushed into the queue are going to happen first in, first out. And so if we had maybe 3 timeouts here, we're going to put them all for 500 milliseconds. And then we ran this. You'll see they'll execute in that order for second, third. And if we were to run this again, it will execute in the same order. And it's going to be consistent. So there's not going to be any surprises or race conditions where like it runs first, third, second, or anything like that. It's going to happen in the order of the queue that you've specified. Okay, so everything we've covered so far, this is applicable in the browser with these methods of window.setTimeout and window.setInterval. And it is also applicable in Node.js with their methods for set timeout and set interval. And so now if we look at our next example, Node.js introduces another method. This one is called setImmediate. And so let's go through a few examples. We'll leave it kind of a mystery of how this is working, and then we'll go through the diagrams of the Node.js event loop and dig into it. But let's take a look and see if we can get kind of an intuitive grasp of what's happening here. So we have our 3 methods again, first, second, third. We're going to call first. We'll call setImmediate with second, and then we'll call third. So let's see what's going to happen. Take your guess while we get this set up. And we'll go. Okay, so we got first, third, second with setImmediate. So it appears that it's an asynchronous method. And it looks like it functions kind of like a set timeout with a 0 millisecond delay. So it does get sent off to these APIs, which then pushes it onto the callback queue. And so the rest of the code is going to execute. That third is not going to wait for it. So we get first, third, then second. So it works kind of like set timeout. So now let's look at, okay, what if we mixed set timeout with setImmediate? So we've got our first, second, third methods again. We can call set timeout with a 0 millisecond delay. We'll call setImmediate and then call third. So now this is hopefully a more interesting question is, okay, what's going to happen here? Does set timeout happen first or setImmediate? So we'll give you a second to take your guess, your mental note. All right. We got third, first, second. So the third is our synchronous method. So you can see we're going to run down this thing. We're going to call set timeout. It's going to go over to the timers API. The setImmediate is going to go over to that API. And then third is just going to execute. And we got first and second. So set timeout and setImmediate. So timeout appeared to be immediate. So then we might wonder, okay, is it just because of the order that we called? So what if we swapped these out real quick? So now this is basically the same thing, but instead we're going to call setImmediate first and then set timeout. So again, if we go back to the other example, it was timeout, then immediate. If we come here, it's now going to be immediate, then timeout. So let's run this again. And we'll leave the 12 demo up just so you can see the difference here. Okay, got your guess? Okay, so we got third, and then our timeout and our immediate. So even though we swapped the order, we got the same results again. So you might be thinking to yourself, okay, so set timeout always takes precedence over setImmediate, maybe? Maybe that's the case. Let's test that theory. Let's look at another example. let's do a whole bunch of mix and matching. So we've got just 4 method calls to set immediate, and then we've got 4 method calls to set timeout. We just labeled them each 1, 2, 3, 4. And then we're going to call them in a whole bunch of different orders. So first we'll call immediate, then timeout, then immediate, then timeout, then timeout, immediate, immediate, timeout. So what's going to happen here? This is a little more involved. We'll clear that out. Okay, so what happened here? Now immediate has beat timeout, and you notice that they're grouped. We've got 4 set immediates and 4 set timeouts. We could run that again just to see what's going to happen. So we've got the same thing, 4 immediates and then 4 timeouts, 4 immediates, 4 timeouts. Keep on running it, and hopefully, if this will cooperate for me, we'll see a surprise, or we might not. There we go. Okay, we have a surprise down here. So how about this last one? We've run this exact same code probably 8 times now, but now this time we got a different result. We got set timeout 1, and then we got set immediate 1 through 4, and then we've got set timeout 2, 3, and 4. So what happened there? They're not grouped anymore. They're somewhat grouped, but this timeout managed to escape to get up here. So it appears that there's some sort of race condition, some kind of indeterminacy in here. And then just one more, just for fun, and then we'll start explaining some of this. Hopefully it'll make sense. What if we did the same thing where we have 4 calls to set immediate, 4 calls to set timeout? We're going to call them in kind of a random order. But we're going to do this inside of this read file method from the FS package. So this is for interacting with the file system. So we're going to read a file here. What's going to happen now? So let's run this. And okay, so the immediates beat the timeout every time, and they're in their groups. And we can run that over and over and over. And immediate will always win. There's never going to be a timeout that escapes to the beginning. Okay, so what's going on here? How is this all working underneath the hood? And so to understand that, to understand how this behavior works with set timeout versus set immediate, is we need to get a better understanding of the Node.js event loop. So not just the JavaScript event loop, but the Node.js event loop. And so if you were to read the Node.js docs, they provide this diagram, and they say that the Node.js event loop has several phases, and there are at least 6 of them. They leave out a couple that they kind of wave their hands and say, don't worry about these. But they list at least 6 here. And so they say, okay, so there's this timers phase, there's a pending callback, so there's idle prepare, poll, and then we're going to check for incoming connections, check, and then close callbacks, and then it will loop back up to timers. And then they give another explanation. So this screenshot is just straight out of their docs. And so they give an explanation saying that, okay, so what happens in each phase? So in the timers phase, they say that executes the callbacks from set timeout and set interval. During the pending callbacks phase, that executes IO callbacks that were deferred to the next loop iteration. And when we talk about IO callbacks, that's usually working with the file system or network requests. We've got idle and prepare, which is only used internally, so they don't worry about that. We've got poll, which is going to get new IO events and execute IO related callbacks, which is a whole bunch of callbacks except for timers and set immediate and close callbacks. Then we've got the check phase, where set immediate callbacks are invoked, and then close callbacks, like when you close a socket connection. And so when I read that with the Node.js docs, I was trying to kind of reconcile, okay, we have this description here, and then we have, this diagram that everyone shows about the JavaScript event loop. But how do you reconcile those two ideas? And after reading the docs many, many times, it finally hit me that what they're trying to say here is that the Node.js event loop has multiple callback queues. Each of their phases has its own queue. And so that can help explain the behavior of set timeout and set immediate. And so if we want to combine this idea of these Node.js phases along with our simplified model of the browser's JavaScript event loop, we get something that looks like this, which is a little more complex. And so the top is the same. So we've got this heap, we've got our memory where our functions and objects and variables and everything are stored. We have our call stack where functions will be pushed onto the stack and popped up and executed. We have the now Node.js APIs instead of web APIs. So with Node, we're not going to have a DOM that we're interacting with, but instead we can interact with the file system, with the database, with the network, and then still timers with things like set timeout and set interval. And then we have all these different queues. And so we have these timers queue, the pending callbacks queue, the idle prepare queue, poll queue, check queue, closed callbacks queue, and then two more that they didn't talk about, but that we'll get to in a little bit. And these are these kind of sneaky queues that aren't quite phases, but they can steal away the current operation of what's happening in the event loop with this next tick queue and the microtask queue. And so the Node.js event loop has a lot more going on to it than the normal JavaScript event loop that you think about in the browser. And so let's go look at with this filled out now, taking that information from the phases of what gets executed when we're in the timers queue, things like set timeout or callbacks from set timeout and callbacks from set interval will get executed. When we're in the pending callbacks, we've got deferred IO callbacks, the idle prepares, again, just kind of a mystery. The poll queue will be IO related callback, and then check queue is set immediate callback, and close queue will be closed callback. And so when we're running these examples with set timeout versus set immediate, what's really going to happen is that if you're running a combination of these methods inside of just like the main module in, just a main module that you're running with Node, their docs say that the order in which the set timeout or set immediate callbacks are run is going to depend on the speed of the process. And so really it's just kind of a mystery of what's going to happen here. And that's why we saw that sometimes set timeout came first, sometimes set immediate came first. It really just depended on which one of the APIs could run and push those onto the callback queue, and then at what point in the event loop you actually were. But then for our example where we read the files using that fs.read file module, we saw that it consistently executed the set immediate callbacks before the timers callbacks. And the reason for that is that when you're doing IO related work, so with the file system here, you're in this poll queue. And so the very next thing to execute is going to be set immediate always. And so set immediate will always run first before set timeout, as long as you're in some sort of IO operation. Okay, hopefully that makes sense. And so this was honestly like the biggest revelation for me, was that the Node.js event loop has multiple callback queues, not just a single callback queue. So with that, these examples should make a lot more sense. We don't necessarily need to run them again, but again, the set immediate, it is asynchronous. It's getting pushed into the callback queue for set immediate. Versus timeout, they're going to run in an indeterminate order. So timeout might be first, might be immediate. It's going to depend on the speed of the process. Same thing, no matter what order you run it in. They will be grouped because once you're inside of a phase, it executes all the callbacks in that phase's queue. And so that's why we saw these groupings of set timeout and set immediate. And then finally, once you're in this IO phase, it's going to, the very next phase is the check phase, which executes the set immediate, which is why set immediate will always beat set timeout when you're in any sort of IO operation. Okay, hopefully you're still with me here. So now let's look at the next one. So let's talk about process.nextTick. So this is another method that Node.js introduces. We've got process.nextTick, and yeah, let's run this. So we've got first, second, third. We've got first, then process.nextTick, second, then third. If you're seeing a trend here, you'll probably be able to guess what's going to happen. But it goes first, third, and then second with process.nextTick. So this is another method that kind of delays things to happen soon after. So it's not synchronous, it'll be asynchronous. Just as a quick time check, I know I have like 10 minutes left, including QA, so we'll try to wrap this up in the next 5 minutes. Okay, so we've got an asynchronous method, but now we might get kind of curious about the same thing we're looking at of set timeout versus set immediate. What's going to happen with set timeout versus process.nextTick? Well, if we run that, we'll run this demo, and process.nextTick is going to beat set timeout. That will consistently happen. Okay, so what if we did that with process.nextTick and set immediate? Run that one. And process.nextTick will consistently beat set immediate as well. And then just for fun, we could look at that with immediate and timeout and nextTick. We could run that again. And process.nextTick is going to win again with set timeout and set immediate, being able to flip-flop back and forth. Those could run in an indeterminate order. But then if we put that inside of our method to read a file, so we're into IO related stuff now. If we run this, we'll leave that 19 example up. We're going to run 20 now. Now you can see these two flip-flopped. So set immediate's always going to beat set timeout. And then if we wanted to look at, we'll pause for right now. We'll pause on that one. We won't look at that example yet. But so thinking about this, let's go back to the Node.js event loop. Let's go back to our demo here. Process.nextTick is kind of this special queue that doesn't really fit into any of these phases. What it does is it's a way to kind of circumvent the event loop. And as soon as any sort of operation is completed, if there's something that's in this nextTick queue, it can steal away JavaScript's attention to go execute those methods. So if you set up some stuff during the timers queue and then there's a call to process.nextTick, it could execute those right while you're still in this timers queue. And then once it's done, we'll move on to the next queue. And so really it can jump back and forth between any of these, during those phases. And so if we want to understand that one a little bit better, we could come over here to this last example. So this one is a little more convoluted, but we've got some methods set up. The one for the first set timeout. We've got another one for the second set timeout, which will console log set timeout 2, and then make 2 calls to process.nextTick. We could have a third set timeout, and then we just have our methods for process.nextTick. So then if we run this, we'll first call set timeout with our first timeout method, then our second timeout method, then our third timeout method, and then just process.nextTick. So then if we look at that example, this. Okay, so we first executed nextTick 3, and so that was on line 18. That was the first one to get executed because process.nextTick is going to beat out the timers. Next, we're going to get into our timers, so it'll execute 1, then it'll execute set timeout 2, and then that on lines 5 and 6 makes some calls to process.nextTick, and so then those are able to just steal away the event loop's focus and executes those right then. And then finally, we're going to get down to set timeout 3. I had a couple more examples for promises, but we'll forego those. So just to wrap up, couple more or one last slide here. Hopefully that's been interesting for you to see. Some main takeaways here. The Node.js event loop is complicated. There's a lot more to it than I thought there would be when I first volunteered to give this talk. I learned a lot in the last couple of months preparing for this. And so it is complicated, but if you want kind of a simplified model, the thing you need to understand is that the Node.js event loop just coordinates the work between the call stack and the callback queues. And that's queues plural. So takeaway number 3 is that the Node.js event loop has multiple callback queues. It's not a single queue. Takeaway number 4 is don't block the event loop. So like while we had that for loop that was running or the while loop, that can block stuff and cause delays in your other asynchronous code. So prefer these asynchronous callbacks over synchronous callbacks. Number 5, don't starve the event loop. So we saw how process.nextTick can kind of steal away the focus of what the event loop's working on. So if you were to call process.nextTick recursively, you can kind of get into the same situation as like almost like an infinite, while loop or something. Is you could get stuck there, starve the event loop. And then number 6, just if you're going to mix and match usage of set timeout, set immediate, process set next tick, and promises, mix and match them with care. Understand how the event loop works so you won't have these surprises or these race conditions with your code executing. With that, I think we'll be done. So thank you for listening. We'll do some brief Q&A. Again, if you want to take a look at this later, I have the GitHub repo up here, and it's also in the chat. Thank you.
Hey, man, thank you so much for that, Tyler. That was super awesome. Wow, I learned so much. And you know what? Thank you also for all the time you spent. You said it took you several months to collect all this information, and it's really helpful, especially for me and everybody else out there. So let's get to these crazy questions we got for you. Okay, here's the first one. I'm going to bring it up on the screen. Are the Node.js and JavaScript event loops just different implementations of the same spec, or are they different specs?
Yeah, that's a good question.
Yeah, I know it is.
I'm trying to think what like the correct semantic way to say this is, but yeah, they're different. I'd say you could probably call them different specs of like, there is a concept of an event loop. And so they are different kinds of event loops, where the JavaScript event loop in the browser is a different implementation from the Node.js event loop on the back end. So however you want to call them, they are different concepts that share some of the same underlying ideas.
Right. That's awesome, man. That's a really good way to put it. Let's move on here. What resources do you recommend to learn more about Node.js internals and the event loop?
Yeah.
This is another good one.
Yeah. If you actually check out the GitHub repo that I shared in the README, I have a whole bunch of list of resources. So I would recommend those. The Node.js docs, the official docs, have a lot of good resources there. There are also a few good talks from tech conferences like these that have some good explanations that go into it in more depth from just what the official docs say.
Yeah, and I think that's one thing about Node.js that I learned. There's a lot of good documentation, right? It's not like it just leaves you kind of dry out there and hanging. It seems like it's really well documented, and there's some really good information when you get stuck. Like me sometimes. Let's move on. What would be the best practice if I had to create child process and synchronize the response and a worker through the main thread?
Oof.
That's what I said.
Off the top of my head, I don't know. We haven't really covered this in the talk at all, but when you're thinking about Node.js as well, there's we talk about single-threaded JavaScript. Node.js is even a little more complicated than that, in that the event loop is single-threaded in Node.js, but then it can also offload these tasks to these worker pools. So kind of what you're alluding to here. And then the worker pools will then report back. Anyway, so off the top of my head, I don't know, but this would be a good one to get back to maybe.
Yeah, and that's a really good point. I think that something like this is something that, like you said, it's a single thread, and totally understand that. Okay, let's continue on. How does Node.js event loop differs from browser event loops?
Yeah, so we've kind of covered this a little bit in that first answer. But yeah, so there's similar concepts where the event loop's coordinating work between the call stack and the callback queue. The biggest one is with Node.js. There is multiple callback queues and multiple phases. It's probably the biggest difference.
That's true. Yeah, and that's Node.js is the back end, correct? In other words, so it's different than kind of the Java, the browser where it loads and all of that. So okay, let's continue on. Okay, how do I prevent unwanted APIs when Node.js is updated or when required APIs are downloaded and installed?
I'm not sure I understand that question.
In other words, like if I'm going to install something new on Node.js, right, some new API, sometimes they bring in stuff that's unwanted, right?
Yeah, I'm really not sure if we're talking about like a latest version of Node.js,
which
then pulls in like a new version.
And you're updating, right.
Yeah. I honestly don't know how to answer that. In context with the whole event loop and stuff, like these methods really haven't changed at all since Node was created. So just things like set timeout, set interval, set immediate, process.next tick. So if it helps answer it all, like no matter what version of Node you're using, you're going to see consistent behavior with these. If they were to change those, that would be a fairly massive breaking change that I think they would. They're smart to not change that.
Yeah, and I really like that answer because I mean sometimes it's not just creating the application, deploying it, is it? It's also the support in it, right? And so when you have updates, for example, to Node.js, and it sounds like what you're saying is it's pretty stable, so you don't really have to worry about like a major change or implementation if you were to update it or something like that. That's a really good answer, Tyler. I like that. Okay, could you please explain the difference between deferred IO callbacks and retrieve new IO events, execute IO related callbacks in 2 different phases?
Yeah. So the docs are pretty vague about that, and I had that same question of okay, what's an IO callback versus a deferred IO callback? As far as I can tell, all of like the IO callbacks will happen in, geez, I'm gonna have to refer back to my diagram. All of those IO callbacks are gonna happen in that poll phase, anything that you're interested in. For that pending callbacks with like the deferred IO callbacks, those actually usually refer to like things that Node.js is using internally. So kind of more of their own little magic stuff. And so you're pretty safe to say that all of like your actual IO callbacks are going to execute during that poll phase.
Yeah, and then I think this is okay, we got 2 more. I'm going to try to run through these really quick. And by the way, I appreciate your patience hanging in there with all these great questions. Okay, could you explain how the race between, and you kind of mentioned this a little bit, could you explain how the race between set timeout and set immediate beat each other in that one execution case?
Yeah, so that's a fun one. And so the Node.js docs, all they have to say is basically when you have calls to set timeout and set immediate in the main module of a file executed by Node, the timing will be bound to the performance of the process. I think that's roughly an exact quote, but they don't really give any more explanation behind that. And so I guess, I mean, what's happening is it depends on how fast, because again, it goes out to those external APIs, so like out to these timers APIs, and then it pushes the stuff onto the callback queue. And so when we saw that one where like the timeout beat the set immediates, and then we saw more set timeouts, like it seems like it was, those external APIs were able to push the one timeout callback onto the queue and then push like those set immediate ones onto the queue, but not the last 3 timeout ones. And then as the event loop's running, it went through the timers phase, it executed the one timeout callback, and then it went to the check phase, it executed the set immediate callbacks. And then at that point, the process was able to finish pushing those remaining 3 set timeout callbacks back into the timers queue, and so it looped again. And so yeah, it's a little hard to wrap your head around, which is why it's kind of annoying that it's this indeterminate race condition type thing.
Yeah, that's a good point. Yeah. Does this one make sense? Use a software component analysis tool to inspect dependencies of dependencies.
I don't know what that would be referring to. There was a previous talk talking about the vulnerabilities in NPM packages, but
maybe so. Yeah. Okay, let's move on. Could you please give final? This is awesome. Yeah, I like this because this might be the last question. Could you please give final parting comments on microtasks versus what we saw till now?
Yeah. So the microtasks, that's kind of what we were getting to at the very end, where with that diagram, there were the 2 other little queues off to the side. There was the next tick queue, which is for process.next tick. And then there's also this microtask queue, which is for promises. And so those operate kind of the same way, where process.next tick and promises, they don't have their own phase, but what they can do is they can steal the focus of the event loop as soon as the current operation has been completed. And then even within those, process.next tick queue takes precedence over the promises queue. Anyway, so microtasks are kind of, they're ways to steal focus away from the normal progression of the event loop. But because of that, they can starve the event loop if you got like stuck in an infinite loop of microtasks or something. So anyway, that's a fun topic, and the Node.js docs kind of cover it a little bit, but they're lacking some depth there. So that's a fun one to explore. There are some other good blog posts on that.
And I came in earlier and I said it was really good documentation. And then you sat there and then you said, well, it's lacking. I'm like, great. That was a really good statement on my part.
They're great docs, but they are
Yes,
trying to
docs. Wonderful docs. Okay, Tyler, last parting words. What are you going to say to everybody out there? This is your moment of fame. So go ahead, just say something.
Parting words. Yeah, just thank you for listening. I really appreciate it. If you want to get in touch, feel free to connect with me on LinkedIn or follow me on Twitter or read my work on Medium. But yeah, I'd love to talk with you.
Thanks, man. I appreciate it. Tyler, have a good one. Thank you so much for all the work you did, because what you said, and it was great information that you provided, and it was so awesome the way you presented it. Have a good one, man. I'll see you later.
Awesome. Thanks, Mike.
Okay. Yep. See you later. Okay, everybody. I think I got my next guest here, and it's Deepa. I can see her nod her head. Hey, Deepa. How's it going?
Hi, Mike. Doing good. How are you doing?
How am I doing? You really want to know?
Awesome. Rocking.
Awesome. Rocking. Super cool. Enjoying the weather in Southern California. By the way, where are you? Where are you located?
I'm in the Bay Area.
Oh, okay. So forget it. Yeah, you're Bay Area. I'm SoCal. I'm down in Palmdale. So how's the weather up there anyway? Is it nice?
It's beautiful out there. It's sunny. It's nice outside.
Cool. Okay. Anyway, we're not talking about weather, right? So what do you got for us today? What are you going to talk about, Deepa?
I'm going to be talking about how to build fast and scalable web applications using Node.js. There's going to be a little bit of what Tyler talked before. There are a couple of questions I think I can answer with the child process and stuff. So yeah, looking forward.
I think that's super cool because he talks and then you come back and you add a little bit more. I am super excited, Deepa. What I'm going to come in and do, and I'm trying to do it the fastest I can, I'll bring in your slides, I'll get off stage, and you got it. Have a good one.
Okay. Let's go. Hello, everybody. This is the topic that we are going to be talking, and it works. So who am I? My name is Deepa. I'm a developer at Adobe. I'm also involved in a few communities outside of work. I'm the organizer for Google Developer Group San Jose, an ambassador at Google Women Techmakers. I also write blogs on Medium. These are the social handles you can connect with me. And a fun fact about me is I'm an avid coffee drinker. So if you're in the San Francisco area, let's catch up with a cup of coffee. With that said, let's go ahead with this talk. So I'm having some assumption before you attend this talk, you should know certain things. So I explicitly put this beforehand so that we can just set the stage here. So you should know Node.js. Of course, you're here. You should know it's a single-threaded JavaScript runtime environment. That there are no major features of Node.js. It's high-speed, asynchronous, event-driven. It's highly scalable. And also, I would want you to have some working knowledge of how web works. What is the client side? How does backend talk to the front end and stuff like that? You should know some parts of cloud services because there's an overlap when you're trying to talk about scalability with Node.js. There's an overlap of cloud services, databases, container orchestration, and of course, I would assume that you have some knowledge of software design pattern. Okay, so the agenda today was we're going to be talking about basics, and then we'll see how to scale. There are different ways to scale an application. I'll be listing those, and then finally we'll say what are the tips to make your application faster, and also at the end we'll see what are the other factors that you need to keep in mind. This information is going to be a little packed, and I'll be breaking for Q&A in between rather than wait until the end. So here is, I think Tyler talked before me, so I'm not going to reinvent a lot of these things, but just a quick overview. As you know, Node.js uses single thread event loop architecture, which can handle multiple concurrent client requests, right? So a bunch of requests from users goes to your web application, and this could be either a complex request or a simple request. that the user wants to perform in a web application. So it goes into the Node.js server, which is a server-side platform, which takes a user request, processes those requests, and returns the responses to the corresponding user. So when the request goes through, first it goes into the event loop, and where every single request are processed one by one, right? And there's something called inside Node.js, Node server is libuv. It's a multi-platform support with a focus of asynchronous I/O operations. So it goes into it, and then I'm not going to reinvent the whole wheel again. We have event loop, and then it goes, some of the requests goes through the thread pool, and then mostly complex ones goes through, and it goes through the external resources such as the database, network, file system, and others. So just to give the whole thing, and just to make it very simple, request goes through, simple tasks goes through the event loop. But the complex tasks like I/O operations, if you want to fetch a large amount of data from your database, then that goes into the thread pool, right? So this is just a visual of how Node works. Now, moving on, switching gears, we'll say what are the different architectural patterns generally used by Node applications. There are different ones. I'm not going to be talking each one of them, but these are the general ones, that are used for creating a Node application. It could be a layered architecture, event-driven architecture, microservices, which are very popular these days, and then Lambda architecture. You have the model view controller pattern, you have client-server pattern, broker pattern, etc. So with that said, why would you scale, right? First, you need to understand why would you scale, right? So if you created an application, right, and then it slowly you start to see traffic. When you have an increased traffic in your web application, then you need to scale. You need to somehow meet the demands of the traffic. So you need to increase the processing power and make sure that your application is highly available always. So that's one of the reasons to scale. And there could be, there are some scenarios that your web application should be fault tolerant. For example, you're creating a e-commerce website and you are putting on some sale, for example, Thanksgiving sale, right? You should make sure that your application is available all the time during those increased traffic, and there shouldn't be any issues while processing those payments and stuff like that. So those are the reasons that you would use. You would also scale based on your internal and other external factors as well. So now there are, these are the, on my research, I found out that there are different ways to scale. And these are the popular ones that I came up with. There's about 8 of them. We'll stop for Q&A when we are halfway. So let's first start off with vertical or horizontal scaling, right? Horizontal scaling, as you know, as you can see, scale out. You can add additional nodes. Vertical scaling describes adding more power to the current machines. For instance, if your server requires more processing power, vertical scaling would mean that you're upgrading your CPU. You can also scale based on memory, storage, network, speed, etc. And the next one would be cloud services. You have many cloud providers, cloud service providers these days. So why do you want to use cloud services? If you're looking for elasticity and your architecture is ready to be horizontally scalable, then you could use cloud services. Cloud services, what does it do for you? It can handle spikes, and it can also scale automatically and decrease your about decrease the memory, or it depends on how you set it up, right? For example, AWS, if you're trying to have it, you can scale it based on the time of the in a day. If you have a lot of traffic, you can customize it based on the time of the day, and make sure that you can increase the traffic by doing that. You can also replace node without having to lose anything else. So I'm just going to be showing a couple of pictorial stuff right after the slide. And because it's all in the cloud, it's available everywhere, and you can deploy in multiple zones. You can deploy it in different geolocations, starting with people start out to roll out their changes based on specific location in the map. So here's an example. On the left, you see deployment can happen in different zones. You can using the load balancer. Load balancer basically is distributes your traffic depending on which zone you would be in, right? And this is how cloud services works on the service side. But if you want to use it for your database, you can replicate it using similar principle. You can have your master or not master, main database in one of the zones, and if one goes down, the other one becomes the main. So here, the replication is nothing but making data copies. You could also use sharding. Sharding is essentially you're splitting your data into smaller sub-segments, and you can distribute it in separate buckets here. So these are the two common ways of doing, scaling your application using cloud services. Now, there's a term somebody asked about child process and stuff. I'm just going to be talking about it. Clustering is one of the ways that you can scale your application using Node.js. It's an inbuilt module available, and cluster is a collection of small child process of a single parent process in Node. I'm just going to be showing a demo quickly. So these are the methods that are available. And remember that only a parent can communicate with a child. There's no child-to-child communication. And clustering is mainly used when you're having a vertical scaling. You would use clustering on top of a child process. So here is a demo. If you can see this, let's see if I can bring this up. Okay. Here's a demo for a cluster. I've created I don't know if you can see it. Hopefully I'll make it a little bigger. So here, the parent process will contain a 4-child process. I'm declaring it here. And then I'm identifying this as a parent process. So these are inbuilt methods that are available. Cluster.fork. You can use it for spawning new Node.js process. So once I do this, here is the output. So if I go ahead, I'll do this, and if I refresh, it's going to say, hey, here's a process ID. So this is how clustering works in Node.js. And moving on to microservices. Microservices, initially, all applications were in monolith. All modules were within one application layer. And later, microservices came into play, where you can decouple your code and have them as separate services. For example, if you go to Amazon website, right? Amazon auth services are different, and their cart selection services are different. So anything that you have it on, if you had seen a product and or if you have saved it, it's in a separate one. So these all could be into separate services, and these kind of this way of scaling your application would help you deploy in time. It's very easy to deploy, and then it's flexible. it's also reliable, because one service goes down, you just need to fix one particular service that was failing, and it's highly scalable. So I know I covered a lot. So is there any questions so far before we start talking about how to scale with the next set of ways, if there are any questions? Okay, I am assuming that there are...
Yeah. Deepak, I'm so sorry. Oh my word. I was so like into what you were talking about. I went, wait, what? I got to get back on stage.
No, I thought, okay, because it's a lot of information,
Yes.
I thought I would have questions in between.
Yeah, definitely, definitely. Are you ready for a Q&A or?
No, I'm just breaking it for in between. If there's any questions, I can take it up now, or we can keep it at the end, because there's a lot of information. I don't want,
Right.
I just wanted to make sure people are asking questions.
Yeah.
Or else I can move on.
I would move on. I'm sorry, because
Okay.
they're dropping up into the question bucket, and we'll get to them right when you're finished. So
sure, sounds good.
Sorry about that. Go ahead. Continue on.
So the next method of scaling is caching. So generally speaking, data that are accessed frequently, but that they do not change, should be cached. Example, you want to list the number of banks in your list the banks in your country, then that could be cached. You have different levels of caching. One is browser level caching. You can have server level caching. I'm going to be talking about this part, the backend part of it. So caching using content delivery network is one of the popular ways to do it as well. So if for caching, you can cache content such as images, videos, web pages, and proxy servers that are closer to the end user. For example, here's a user who wants to, from the East Coast, wants to get a content, say some images or videos. So they don't need to all the way go to the origin and get those. Instead, they can get it from, these are cached in this content delivery network so that it can be accessed more quickly. So this is another popular way of scaling your applications. So the next one is I/O operation timeouts. I think Tyler talked a little bit. I just wanted to add some more details to it. A timeout is a maximum wait time that is set on a request. So if you want the client to wait on something, so that you can do that. You can globally set a timeout, like on the top right. Or else, if you want to set a timeout for a specific API, here, for example, I want to set it up for this example.com. And for this particular route, I've given a timeout of 2 seconds. So you could do that as well. The next one is worker threads. Worker threads are a mechanism. They are a mechanism to run CPU intensive tasks. So it does not block the main event loop, but what it does, as you know, Node.js is a single-threaded asynchronous task, but it can be made more efficient with workers. So I'm going to show you a demo in a moment. So there is a main thread, and you create worker threads along with this. And once the worker thread gets its work done, it sends a message called post message, and then it hops onto the main thread. Let me just get this demo here. So here I have it. First thing, this is the main thread, and you instantiate a new worker from this worker constructor. And then once as you can see, that when the worker is on, it goes through these messages. For example, let me run this thing. If I run this, the main thread has started. So it goes into this loop. And then once it's just saying, oh yeah, it's doing its thing, and then the worker messages are also posted. Then it goes back to the main loop. So this is how worker threads work. And any synchronous task can be efficiently done using worker threads. Okay, I think I did the same thing. Now, multi-server. So as your business grows, it's time to add more servers to host your application, right? So first you can add a load balancer and your load balancer to your app units, and then you can set multiple availability in different regions. That's where Amazon AWS services comes in, or any service provider such as Google Cloud Platform would also come into play, so that it reduces the latency rates by having multiple availability zones. And then you can split up static files for, like I said, you can have them in caches using CDNs, etc. This is one of the other ways you could scale your application as you grow. I'm talking about enterprise level. So what are the tips now? How do you make your application fast? First of all, make sure that you go asynchronous. Asynchronous allows you to append additional tasks and add extra callbacks without blocking your main thread. It also uses queues to monitor your workflow. Like I said, remember those the ones that it was like the event loop was there and the thread loop was there. Think about it. And here I'm trying to read a file using asynchronously, and versus the synchronous way. And optimize your queries. For example, if you have comments on a post, on a Twitter post, for example, and you might you might have to exclude some of them while fetching, you can definitely do so by having something like this. You can create queries like this. And also, it's because Node is perfectly suited for running multiple asynchronous functions in parallel. So here I have set of functions that runs parallelly, and this way you could make more sense of how to parallelize them. This is just an example to show that you can have parallel requests that does not depend on each other, can go together, right? And finally, you use caching. You can use something called as tools like Redis to cache your data, and also track your app activity using logging. There are different logging libraries to use, and then you can, if you use them, you can monitor your application, see how is your application doing, and what are the times you see heavy traffic and things like that. And finally, if you can use a server client-side rendering when possible. So other factors apart from this, you're trying to scale your application. First, you should have a team of people who knows about how to establish end-to-end scalability, right? You should have stakeholders, architects, engineers, DevOps, administrators, testers, etc. And also technology, right type of infrastructure, including network capacity, load balances that you want to use. What is the stack, and what are the standards and patterns you would build for your system? That thing also needs to be considered, right? Scalability process. So establish some kind of a process and patterns. So during the development phase, and of course, you need to know how to handle incidents, monitor. Like I said, have some logs to monitor your application. So with that said, there's a lot of companies that use a Node.js. Well, Netflix uses for streaming, large enterprise applications like, LinkedIn uses it, and then messaging services like Twitter, and there are a bunch more. I just wanted to give a visual of these are the companies that use them, but there are a lot more companies use them. Even SpaceX did use it. And on a final note, I make sure your code is clean, have separate front-end and back-end layers in your application, and detach them from background job from the main system. Select your design pattern wisely. Keep your tools up to date. So somebody was asking about what is the versioning of. It's better to use. I know that when you are trying to use different versions, and if you update Node, sometimes you have issues, but then you need to make sure that your application works along with the current one as well. Remember, any faults in architecture of your application will cause negative impact when it comes to scaling. So you need to do regular reviews of your architecture. How is your application doing? Constantly, if it's a large scaling one, then you would do it. So with that said, I know it was packed with a lot of information. We saw the architecture of Node, some of the common patterns that are used. Why do you need to scale? What are the different ways to scale? And then what are the tips? How you could make your apps faster? And with that said, once again, my name is Deepa. You can connect with me in LinkedIn. And if you're interested in talking or giving a talk, please reach out to me. I can organize an event for you. With that said, these are my references. And any questions now? You're muted, Mike.
I know. You know what? I always do that. I'm like, I'm not going to unmute. And it always, I don't know why that happens to me. Anyway, let me go ahead and pull off your slides here from you. And, that was super amazing. I really loved how you talked about that. You talked about the entire architecture, because that was like so relating to what you're, bringing up to us. I'm looking at the questions for you because there's quite a few, actually. I'm trying to figure out how we're going to do this. Okay, here's the first question. This is an awesome question because this is so important, right, for scalability and performance. What roadmap to follow while we develop to assure good performance and scalability? Wow. Okay, Deepa, go.
What is a good roadmap? So first off, where are you? What is your application? What are you going to do with it? What are the how do you architecture your application, right? And if you can make it, if you want a good performance one, you have to make sure, like I talked about, different ways you can keep have it as a cluster. You can have worker threads, and you can also use cloud services. So if you are, these days it's very common to use cloud services. People use constantly, we use AWS. So those are the good ways to get, if you're to begin with, if you're a person who is starting out learning these things, maybe probably try to host your application in one of, I host mine in Google Cloud. So very simple ones. It doesn't cost you that much, but then if you're trying to grow, like if you had seen Tyler's website, he has a bunch of stuff. Mm-hmm. So he has it hosted in Heroku, but I don't know what kind of backend services how he's hosting it. Mm-hmm. It depends on how you're going to scale your application. Imagine if I'm starting out something, then I would go slow, start with monolith, then you go with microservices and stuff like that.
It's funny when you said that, because I do the same thing. When I look at somebody's website, I'm like, I wonder what their back end looks like. I wonder what the front end is. That's so funny you said. I can so relate to that. Okay, here's the next question. What all scaling techniques notice the scaling's coming in. What all scaling techniques can we use for stateful servers?
Honestly, I am really not sure with this answer. I do a lot of stateless servers. So I think this is something that I don't know. I'm not going to say anything about it, but I can definitely find it out.
I really like that. I like that answer because, we just say there's a lot of different ways to get that information and, Google it, right? Or something like that. Okay, let's move on. can I build a website purely with Node.js, or do I need a framework such as React.js for the front end? That's a good question.
Node.js is mainly for your backend, right?
Mm-hmm.
So React is, if you're working with React, React doesn't have any server-side rendering by itself. Like Angular it's a full-fledged framework. So if you're using React, I think you need to have something, some other third-party library to work with. With that said, you would use React for your front end, and then you could use Node for your backend.
You know, I really like that answer because the way you explained it is, because sometimes there's confusion. Can you use Node.js on the front end, or where is it? And when I first was learning, I'm like, whoa, wait, Node.js is like server side. It's the back end. So that's a really good way to explain that. Oh, one of two. Since we have modern tools like Docker Swarm, or I guess that's Kubernetes, for scaling horizontally, usually we just would replicate the service with a balance. Part two.
Load balancer.
Yes, right. Load, like you mentioned, right. When do you think there is still a place for worker threads inside a single service instance?
When you want to have, I just did, I know that this question will come up, so I was like, I had to look it up too. So just give me 1 minute.
No problem. This is awesome.
So when you want to have, it's when you have a CPU intensive task, like I said before, and if you want to make a synchronous, because Node.js is asynchronous, and you want a synchronous task to be used in your application, that's when you would use worker threads.
Yeah, can you give us an example of a synchronous task? Sorry, that's kind of throw something.
So a synchronous task is if you're trying to, streaming, like I said, right?
Yes.
So you have to instant messaging. You have to constantly get a reply back. How do you do it, right?
Yes.
So those are the things that I would use it for.
Awesome. That's a really good, awesome, great example. Okay. Any advice when to use child process and when worker threads for heave jobs?
So child processes are usually used along with clusters. So if you want to process, if you want one process that has to be launched each time, and you want to communicate it via your CPU has to communicate with the inter-process communication, that's when you use it. And it's good for if you are having, it's great to have when you have many spawning HTTP servers. And if you want to use the share the same port, then you would use it.
Yeah, that's a good, I like that. Okay, next one. Hello, Deepa. Somebody says hello to you. Would you recommend a good Node.js framework for building web apps using a microservice? This is awesome. But for using a microservice approach, or do I have to roll it on my own?
I did try it out with, starting a monolith application, try to segregate it with microservices. You need to know, and then I connected it to AWS too. So if you know how to do it, learn it. But if you're just starting to, learn something on your own, I would start slow. Try it with first build up a monolith one, and then based on what you have built in monolith, separate it out. Have a front end and then back end, and then even the front end you could do different services.
I love that approach because don't try to create a Tesla, right? Or a spacecraft. Start out small, right? Start out monolith and then work your way out for what your actual main goal might be. Great answer. I like that. Okay, here we go. Does it help on scaling when using a micro app? We apply solid, or thinking in scalability is the same?
I'm not so sure about this question. I don't understand it.
Yeah.
Can you help me understand, because it says micro app when using micro app? Why would you want to scale a micro app if it's a small application, right? That's how I'm understanding it as. I don't understand this question.
Yeah. Okay. Let's just move on. That's okay. Maybe the person, if you're out there, you could kind of give us more information on what you're trying to get across. And I'm sure, I'm just saying, Deepa, maybe they could contact you, right? You guys can figure this out. Yeah. Okay. Let's move on. Any recommendations on getting started on scaling? Boy, I'll tell you what, that must be really popular. It is, right? It really is. Any recommendations on getting started on scaling concepts as a beginner?
So, like I said, if you're starting, try out. This is mainly on the back end side of things. If you are try to host your content, if you're trying to create a website with photo application, right? And if you want to store your photos, try to see if you can find a ways to store your content so that your friend in Europe could easily access those. Something like that. That's how I would begin with. Like how I started it was using AWS. Again, I'm so sorry, I'm going back to AWS. So I used it along with cloud services mostly.
Yeah. Okay. Here's a really good one. Lambdas are really popular, right? And this seems to be coming up a lot. Hi, Deepa. Can a microservice architecture be built with Lambdas?
Yeah, why not, right? So this is something that you can create them, and I'm not sure as how you're going to be architecturing your services, but then based on that, if you want to do it, go ahead, do it.
Yeah, can you kind of explain to everybody what a Lambda is, or is that too much?
I think it's like I said, the architecture itself, it's a lot of ways to. I'm not focusing too much on the architecture.
Yeah, that's fine. So. Okay. Okay. I think that's it for. Oh wait, no. Whoa, wait a minute. I just scrolled here. Here's another one. We got a couple more. When do you recommend a cloud service versus a homegrown one?
It depends. Like I said, start with homegrown one, and then slowly start to get yourself exposed to cloud service. I've used Firebase. I've tried it with AWS too, but I've never tried it with other Azure or anything like that.
Yeah, I've tried to work a lot. I mean, I'm just saying to everybody out there, there are different flavors of those, and Azure's different than there is, with Amazon and Google and everything like that. I guess it really depends on what your requirements are, right? What your company or whatever this project that you're working on and what they're trying to solve.
Yeah, I think Amazon gives you for a year. It's kind of free, so you can try to explore on this and try to put in different location wise too. And see what works and how if you're trying to host or deploy it, and not here, but then in Asia, and try to see how fast your application loads, things like that.
That's a really awesome point, because those kind of things need to be considered, right? It's not just like a local prem application, but when you're talking about the cloud, right? You're talking about where is it located, what's the best approach, how much is it going to cost. When should I use like Lambda or even microservices or something like that? Right.
And just to let you know, if you don't know what you're doing with, because I ended up paying quite a amount. If you're somebody who's starting out, don't leave it open. Or if you're trying a project, then please shut down all your projects after if you're not so sure about it. Otherwise, there are articles that people ended up paying $30,000 overnight. There was one article in Firebase that said that people were, it was something like a GoFunding kind of a thing, and then overnight they had something like $30,000. So of course Google reimbursed those things, and then they took it off. But know what you're doing.
Yeah, that's a really good point. Like I've heard serverless versus another one, because serverless it's a lot cheaper and more cost effective to operate.
And there are some times that you don't need to keep your data syncing all the time. That was an issue with the Firebase one, where they were trying to sync their data constantly. So that when you're trying to read, it's some a different. There's something when you want to write. It's not there. There are some. Depends on the service providers, there's a read operation, there's a cost, there's a write operation, there's a cost. Some are free for reading, and some are free for this thing. I'm not so sure about it, but it's not at the top of my head, but know what you do before you do anything.
No, but that's really good advice. I think it's at such a high level that it makes people think about, what is my approach for a cloud architecture? Okay, we got to go, Deepa. I'm so sorry. Go ahead, give us your last amazing statement to everybody out there, wise wisdom and all that.
Yeah, thank you so much, guys. This is my first Global Summit. I hope to come back again. Yeah, it was fun. Yeah, it was. Thank you so much for hosting me. And then thanks, Anna. Thanks, Mike. Thanks a lot for hosting me here.
Thank you, Deepa. We've really enjoyed it. All the information you provided. Yes, please come back. I'm sure a lot of people out there going, yes, please come back. So see you later. Have a good one.
Yeah, you too.
Okay.
Thank you.
Okay, bye-bye. I think before the next speaker, I think we have an announcement. So take it away.
Hi, everyone. Now we want to say a huge thank you to our platinum sponsors, Bright Security Labs, for supporting us and also for giving us the opportunity to share with you some free scanning hours on their platform. Now we will post a link in the chat, and be sure to go register and grab yourself free hours of scanning. And yeah, also look for announcement about a very practical hands-on workshop that we will have on 9th of June. So be sure to check it out when we have the announcement and register for that workshop, and have a great Node.js Summit.
All right, that's super awesome. I'll tell you what, guys, there's so much information during these summits. And guys, I don't know about you, but I just really enjoy it. I mean, I get so much this vital, just amazing information that I apply in my job and everything. But let me bring in Ramez. Are you ready, Ramez? Are you there? Hey, man. Hey, Ramez. How's it going?
Hello, can you hear me?
Yeah, I can hear you. Yep. Hey, so how's it going? Where are you located anyway?
It's going well, first of all, and I'm located in Seattle.
Oh,
Seattle,
nice.
Washington. Yeah.
Nice. Yeah, I'm on the Pacific Coast too in California. Hey, man, so what are you going to talk about with us today? What do you have?
So today I will be talking about WebAssembly, and not a dive deep into WebAssembly, but just like basics of WebAssembly and how it works, like roughly trade-offs and demo, things like these.
That's super awesome, man. I'll tell you what, it sounds like you got a really awesome talk. I'll tell you what, I'm going to bring in your slides here, and I'm going to back away, and sir, you've got it.
Awesome. Okay, so my name is Ramiz. I work for AWS as a front-end engineer, and today I'll be talking about WebAssembly, how it works, trade-offs, and demo. And please let me know if you cannot see my screen or if you cannot hear me in the chat. So yeah. So anyway, let's get started with WebAssembly. So overall, for the context, programming languages are generally classified into two major categories: high-level languages, low-level languages. The main benefit of high-level languages is that they are hardware agnostic. Like, you don't have to know a lot about your architecture when you're writing the code. And the benefit is that your code, they provide an ability to write human readable code, and so that it's maintainable, for easier to maintain and easy to understand for humans. So they are like far from the machine and close to the humans. So some examples are, you all know about it, like Java, Python, C, C#, all of them are high-level languages. But when it comes to low-level languages, they are sort of the opposite of that. Like low-level languages, they are more close to the hardware. So if you're writing your code in low-level language, your goal should be performance and not the maintainability or not the human readability of that code. So usually you have to have a really good reason if you're going to write your code in low-level language directly. So yeah, and some examples are assembly language and machine language, and assembler is required to convert the assembly language into machine understandable code. So taking this concept and now applying it on JavaScript world or Node.js world. So we have WebAssembly that is similar. That's a similar concept as assembly language. So it's a low-level assembly-like language with a compact binary format that can directly run in the latest browser, and it can also run in Node.js environment. So yeah, languages, and again, you can have languages like C, C++, C#, or Rust, and you can compile these languages into the WebAssembly. So that provides an ability to write your front-end code into backend languages like Rust or Java and stuff like that. It was released in March 2017 to run alongside with JavaScript or Node.js code. So this is really important to understand that WebAssembly was not created to replace JavaScript. It was created to run alongside with it. So it's like something that complements JavaScript, something that can improve the performance where it is required. So yeah, let me just quickly go through the demo. I have made a simplest demo possible. It's just like a 2-number calculator, nothing fancy. Just you're gonna, write like 2-number. If you click on add, it has two functions: subtract, 4 functions actually, multiply and divide. Let me just show you the code. The code that I wrote was in Rust, and I've compiled that into WebAssembly. So this is how it looks like. And if you are not familiar with Rust, so Rust use something called cargo. Cargo is like the way we have npm for JavaScript and Node packages. Similarly, we have cargo when it comes to Rust. So it's just a package manager. You can define your dependencies in this file, and it gives the CLI to build your project for web or for any other target that you have. And so yeah, this is how the source code looks like. It only has one file for the simplicity. This is the Rust file. So as you can see here, I'm using a package called WebAssembly bindgen. It's an external package, and it is required if you want to expose your Rust functions to be used in JavaScript. So when I'm defining this, I'm basically I'm exporting this function called add, and all it is doing is adding 2 numbers. Same here. I'm exposing the subtract function, kind of exporting it to the JavaScript world so that JavaScript can use it. And same with multiply and divide. And at the same time, I can also import function. I can also use JavaScript function in Rust. So let's say this alert is a JavaScript function that's used in browser. So I'm importing it from there, and so that I can show the answer, like in the print answer message, in the print answer method. So yeah, this is what's going on here. And when you compile it, so the command that I have written everything here. I'm going to share the link in case somebody is interested. So when you're going to run this command, wesimpact build target web, it's going to create something like this. That's something that's you're going to deploy on the server, or that's you're going to use in your index.html. So as you can see here, it is generating some JavaScript file, some TypeScript declarations, and at the same time some WESM file. So this is what it generates. So that's like I don't know if it can show it or not, but it's a raw binary code, so that's why it's not showing it. So that is it's already compiled and already just ready to run in the browser. So it's also generate a JavaScript file that is sort of consuming that WebAssembly file that was generated. It was using all the APIs that JavaScript provide to effectively load the WebAssembly file and then export these functions to be used in JavaScript. And yeah, and in the index.html, all I'm doing is importing from the source. Importing from the package the JavaScript file and just getting the DOM. So one thing about WebAssembly that you cannot get DOM elements directly in WebAssembly. So you still have to rely on JavaScript for the DOM manipulation. But everything else, like your calculation, your business logic, can be written in Rust or in any other language and can be compiled later to WebAssembly. So okay, after the demo, let's just dive a little deeper into WebAssembly and let's see how it works. So in order to understand how WebAssembly works, we need to first understand a little bit about how JavaScript or how Node.js works with the V8 engine. This is the overall flow of V8 engine. If you don't know about V8, so V8 is sort of the black box inside your Chrome that actually makes your JavaScript work, that actually parse your JavaScript and make it run efficiently. And it does a lot of processing. As you can see, it has a lot of steps. So first, source code is your JavaScript file. It's going to go through the parser. Then it's going to generate something called AST. I will go into detail later. And then it's going to go to Ignition, and then Ignition will generate bytecode that's going to be executed in the browser. And then at the same time, it does something called just-in-time compilation. So what it's about is it's also track your functions and see how frequently you are using a specific function. So if a function is getting called again and again, it's going to classify that function as a hot function. And then it's going to send that to the turbofan. That's a compiler. So turbofan is going to optimize that hot function because it's getting used again and again and generate the machine code for that. So next time when you're going to call that function, it's going to directly use the machine code instead of using the bytecode. So yeah. So let's just go through step by step. So first step is parser converts JS source code to something called AST. That is like abstract syntax tree, and that is it's like if you're writing let variable let A is equal to hello world. So it's going to break it down into like, so it's gonna create a JSON tree for that and say that you have defined one variable as let, so that it can be processed later. And then it's also parser will also perform the lexical analysis on your code, that is breaking down code into tokens. It's like a smallest piece of your code. Token is the smallest piece of your code, and then something called syntax analysis. It's going to check your syntax. If you have some error in your code, it's going to throw that. If you have a syntax error in your code, it's going to throw that. So converting token into AST and also checking for syntax error. So this is what this parser is doing. So now we have abstract syntax tree or AST. We're going to send it. V8 is going to send it to Ignition, and Ignition converts. So Ignition also is sort of an interpreter inside V8. So it takes AST and then convert it into a bytecode. And why it does that? Because AST is huge, so you cannot save it in the memory, or you can so that you can reuse it. So you have to convert into a shorter format. So Ignition, the first thing Ignition does is convert AST into bytecode using bytecode generator and keep it in the memory. So whenever your code is getting run, it's actually a browser is just running the bytecode again and again, and not like running AST again, or not like generating AST every time. So yeah. After that, Ignition executes the bytecode using a high-performance interpreter. At this point, JavaScript code has been executed, and user can interact with it. So which point? Like here. So once we are done with this cycle, at this point, your page is ready to use. So yeah, and during execute now the feedback loop of V8 is going to check in the execution, and Ignition will monitor and record the execution information like execution frequency of a function. That means how many times a specific function gets called, and what parameters were passed, and what was the execution speed of that function. And if a function is executed multiple times, then Ignition mark it as a hot function. So Ignition will say, you know what, this function is really important because it's getting used again and again. Let's optimize it. But by optimizing, I mean, let's see if the code can be optimized to something more fast. And then hot function, and then send it over to the turbofan compiler. So turbofan will optimize the hot function and convert it into efficient machine code. So next time, whenever your hot function is executed, the corresponding machine code will be executed directly, which greatly optimizes the performance. So the logic behind it is, next time when you're going to execute the hot function, it's not going to go back to the bytecode and then run that. It's going to go to the machine code that's generated by turbofan, because again, machine code is even shorter than the bytecode, and it's even faster because there is no need to convert it to anything. It's just going to directly run on your hardware, and it is it is also optimized. If there are dead code in it, it's going to remove it, or optimize the functions and everything. So when the function, okay, there is a possibility that the function is no longer hot. It was getting used in the beginning, but after a while, it's no longer hot. So then turbofan will de-optimize the code, because probably the code is not valid anymore. Probably something changed. So then it's going to convert the optimized machine code back to the bytecode, and transfer the execution back to the Ignition. So if the function is not hot anymore, and you will run after that, you will run that function after it's not hot, then it's going to run from the same stage, like from the bytecode stage. So yeah, this is how overall V8 work. So let's see what happens in the case of WebAssembly, because the same V8 engine is used for WebAssembly. So, and that's a good part about it, that you don't have to do anything to run WebAssembly. Your browser supports it naturally, or Node.js supports it naturally. It's inside, embedded in V8 engine. So in the case of WebAssembly, since first of all, what is WebAssembly? WebAssembly is the bytecode for AST. Is the I will cover it here. The parsing step is not required because WebAssembly is a binary encoding for AST. So it's already here. It's already the AST and parser is already done for WebAssembly. You have already covered this part when you were compiling your code on the build time. So this step, like parser to AST step, it doesn't have to be done on the runtime because you already covered it on the build time. So when you have a WebAssembly file, you already have a binary implementation of the AST. So after that, it does not use ignition. It's used something called V8 use something called liftoff compiler, and then it just straight away generate the machine code from the WebAssembly code, and then directly send it to hardware for run. And then when it comes to turbofan, so we have turbofan compiler for WebAssembly, but the difference is that in the case of JavaScript, ignition used to monitor the code and identify the hot function, and then used to send that hot function to turbofan. But in the case of WebAssembly, it just optimize whole file before it ahead of time, before it gets run in your browser. So it's not gonna keep turbofan again and again. It's not gonna track hot function and do that. And that is called eager tear up. Like when you are basically optimizing the file ahead of time, that's called eager tear up, and that's what it does in case of WebAssembly. And the reason for that is because WebAssembly wants to have consistent performance. Like it doesn't want to have, like, at some instance the application is running fast, but at some instance is running slow, or there are some fluctuation, some lagging. It doesn't want that, because that's the main reason of building WebAssembly, so that you can support heavier application like games and stuff like that in the browser. And nobody likes lagging in the game, and that lagging happens because in the case of JavaScript, turbofan kind of keeps optimizing behind the scene, so that creates a little lag whenever it optimizes the hot function. So they want to remove that in the case of WebAssembly. That's why they put turbo compiler in the beginning of the pipeline, and it does the ahead of time compilation. So the parsing step is not required because WebAssembly is a binary encoding for the AST, as I already covered. And instead of ignition, V8 use baseline compiler. So baseline compiler is just a compiler that quickly compile your code in the background. That is called liftoff compiler to compile binary encoding of AST, that is WebAssembly, to machine code as soon as possible. By as soon as possible, I mean in the linear time. The worst case is linear. It's not going to go to the square or anything, and in a single pass. Liftoff compiler compile ahead of time together with WebAssembly streaming APIs. It compiles while downloading the WebAssembly file. So if you use this API, streaming API, it can also compile the WebAssembly while it's getting downloaded. So they're not going to be any lag after. It's not gonna be like the file is downloaded first and then it is started to compile. You can compile it while it's getting downloaded if you use the streaming API. So that's going to save a lot of time. So, and your file will be ready to use immediately. So it compiles while downloading the WebAssembly file over the network. After liftoff compiler, turbofan compiler compiles the WebAssembly again in the background thread. And that's important because you don't want to block your main thread that is running the code to generate the optimized machine code. Eager tear-up strategy is used instead of dynamic tear-up strategy to provide the consistent performance for WebAssembly. As I already covered, like there are two strategies, eager tear-up and dynamic tear-up. So eager tear-up is just turbofan recompile everything ahead of time in the background thread to generate optimized code. And it's not going to come again. It's not like it will keep checking the hot code and keep compiling it again and again. That's not going to happen in eager tear-up. But dynamic tear-up is used in JavaScript. In the case of JavaScript, it compiles just in time only the hot functions, and then it keeps coming in and keeps kind of changing the performance of your code That's something we don't want. We want WebAssembly to run consistently every time and for as long as possible. So, okay. So what are some benefits of WebAssembly if we talk about? First of all, as it's pretty obvious, it's efficient and fast as compared to JavaScript. Why? Because it does not require a lot of steps that JavaScript required to be processed. Parsing and all that is not required. And second, consistent performance, as I talk about, because ahead of time compilation, no just-in-time compilation pauses. And then compact file size as compared to JavaScript, because JavaScript is like a full-fledged code. But when it comes to WebAssembly, it's already into binary code. It's already the binary implementation of the AST. So it already get converted into a smaller, shorter format. So that means your download time will be much lesser than JavaScript. And one more advantage is language agnostic. Rust, C#, C, Java, and Python code can be converted. In fact, there is even TypeScript can be converted into WebAssembly. And then, yeah, that is very important, being language agnostic, because let's say if you have a current application that is a desktop application or anything else that is written in Python or some other language, and you want to migrate that to a web application. So you don't have to rewrite everything in JavaScript. You can just reuse the modules from that applications and then embed them in JavaScript using WebAssembly. So easy to migrate desktop application to web application, as web application can reuse the code modules written for desktop application. And some examples for that is Figma, AutoCAD. They have done it. So yeah, there are some limitations as well that we need to be aware of. First of all, not supported on legacy browsers like IE11 or even in the older Chrome browser. So you have to make sure that your customers, they don't use IE11 or any other old browsers. For some applications, this point is really important. So yeah, and also performance gains are only significant for bigger applications. So again, if you have a simple application that is not doing a lot of calculations or a lot of optimization on the front end, it does not have it's not front end heavy, or it does not have a lot of heavy JavaScript code, then probably you're not going to see any major gain in terms of performance. Okay, number 3, it can also add some learning curve by having multiple language in the same application, because now you're opening that door of if you're using WebAssembly, then you can use Java, Python, or whatever in the same language. So probably it can be a trade-off in the long run. Like probably you are using Python, somebody else joined your team, and now they want to use Java. So probably it can be a combination of multiple languages within one application. I don't think anyone will like that. And number 4 is your DOM. It cannot be WebAssembly cannot access DOM directly from WebAssembly. It relies on JavaScript to access the DOM. So that is again not like it's one of the things that's sort of a limitation for now in WebAssembly. So let's look at some performance benchmark. I was able to find some performance benchmark from Figma. And so if you don't know what is Figma, Figma is a tool that designers usually use. I mean, sometimes developers also use it to basically design the wireframe of the application, or basically anything. It's a heavy tool, because you can drag and drop. You can do a lot of things. You can generate buttons, change their color. So yeah, it's front end heavy. So they used to have, they still have a desktop application, but then they have to move to just browser experience. Like you can use everything in the browser. So they used WebAssembly for that. So their code was written in asm.js. I will explain what is that. It's sort of a subset of JavaScript. So this is their load time. So when they were on ASM, as you can see, the large document, like a document with a lot of components on Figma, that has a lot of design and a lot of wireframes, a lot of screens. It used to take 12 seconds probably, and now after moving to WebAssembly, it's 3 seconds. So that's a significant gain. But when it comes to like a smaller document, empty document, not that much. Like probably it was 3 seconds before, and then they brought it down to 1 second. So yeah, and then when it comes to download size, uncompressed ASM was around probably 7 MBs, and then the WebAssembly uncompressed was around 4 MB, and after gzip, not not that significant, but it's still, again, gzip probably takes some time, so you can avoid that and just directly use WebAssembly. So anyway, so yeah, with asm.js, so above benchmark is asm.js versus WebAssembly. So ASM is a subset of JavaScript with highly optimizable instructions. So ASM is used when you want to do a lot of calculations in your front end, a lot of geometrical work in your front end, and that's what Figma is all about. Like, giving the size of the button and all that, putting the right CSS. So yeah. So in conclusion, what I would like to say is it is important to understand that the goal of WebAssembly is to complement JavaScript and not to replace it. So that is important, because I'm not asking you to, or again, nobody's asking you to write your whole application in WebAssembly. WebAssembly can greatly improve the performance of the bigger and UI-heavy application like AutoCAD and Figma. Using WebAssembly for normal application like simple CRUD application, if you have a simple application that just contains forms and simple payment methods and stuff like that, then probably using WebAssembly can be an overkill. So always consider risk to reward ratio before choosing any unconventional tool. So it's still, WebAssembly is not a conventional tool. You're not going to find a lot of developers using WebAssembly. So always make sure that whatever tool you are using, if it's unconventional, you have to have a good reason, because whatever you're going to choose now, it's going to impact next 4 or 5 years at least for that company. So yeah, we need to be wise about choosing the technology. So yeah, that's pretty much it from my side. You guys can ask me questions if you like, or you can ask me about AWS, about WebAssembly if you want.
Hi, Ramis.
Hello.
Today I will try to moderate your Q&A session. It's nice to see you here. Yeah, Mike has some urgent meetings, so
I see.
Yeah.
So
Yes.
sorry, one thing. Where can I share the link? Can I just put it in the comment, or
Yeah,
can I?
you can put in a private chat, and we
Okay.
will post it everywhere.
Yeah, so you can.
Fine.
Yeah, please post that.
Yeah, we'll post it in chat on YouTube and also on our platform.
Awesome.
Yeah, so I'm still waiting. Oh, yeah, we got first question that is, it looks like first part of the question. So WAM's code firstly complies to machine code and it's being executed, and later at some point comes the optimized machine code from the turbofan.
Okay, so no. So in the case of, if this is something that they are testing, like, so dynamic, what you are mentioning is dynamic tear up, and it is available if you want to test, but by default V8 turbofan compiler optimize the code ahead of time. It's not gonna, so this is how it's gonna work. Your WASM file will get downloaded, and while it's getting downloaded, first it's gonna be compiled by liftoff compiler, and then it's going to be compiled straight away in the background by turbofan compiler, and this is it. Now it's ready to use. Now turbofan will not come again and compile and keep compiling your code again and again. It's done. So if you want to test that, so you can enable it in your Chrome by setting a flag for the dynamic tear up, and then then basically you are testing the functionality where turbofan will keep optimizing the WebAssembly. But by default, it's always going to use eager tear up. I hope that answered the question.
Yeah, and second part was it on your diagram. I see both optimized and optimized code coming to hardware.
Right.
The second part, yeah.
Yeah, so I did that to show that it's not it's not blocking the, basically the reason I put both of them is because sometimes there is nothing to compile for turbofan, so it can just straight away go to the machine code, and or if it will go after the optimized machine code. Again, this diagram, I just made it. I was not able to find it in their documentation or anything, so I just created that roughly. So probably there are some pieces missing in this diagram. So it's sort of like an abstract diagram for how things are working. Yeah.
Okay, we have a few more questions. Next one is, you mentioned about streaming API and compiling at the download time. Is it done automatically always, or should somehow configure it that otherwise it won't be compiled while downloading?
Yeah, so there are like multiple ways to use your, like there is an old way of using WebAssembly code when this streaming API was not available. So if you're using that old way, then it's not going to be compiled while it's getting downloaded. But if you want that feature, then you have to use this streaming API. So you have to sort of load your WebAssembly file using this module. It's available in JavaScript. So if you're using this API, then it's going to do that. Then while it's downloading, V8 will start compiling the code.
Mm-hmm. I think it's brilliant answer. And one more question. What exactly are the use cases for WebAssembly? Also, can you convert entire Python applications to what, for example, and execute on JS somehow?
Okay, so let me just go through. There are two questions. So what exactly are the use cases of WebAssembly? So WebAssembly use cases, as I said, the biggest use case right now that I can see is if you already have an application that is in desktop environment, and you want to migrate it to web, or you want your customers to be able to use that in the web app. So of course you don't want to write your whole application into JavaScript. So what you can do, you can reuse modules from the existing application and sort of compile them into WebAssembly, and then you all have to do is to write in the JavaScript a logic to load those files and probably some features. But you don't have to migrate entire application from, let's say, existing C# application if you want to migrate to the web. So that's one of the main use case right now. That's going to save a lot of development effort. And at the same time, there's another problem with that when you migrate your application to JavaScript, so performance is not usually consistent as your desktop application, because desktop application will always run faster than browser because it's just running on your machine. But when it's come to browser, the files will get downloaded, V8 will compile them and all that. So if you want almost same level of performance in web and in desktop, then I would recommend using WebAssembly for your application. And also your application needs to have that heavy UI where you are doing a lot of geometrical calculation on the runtime, where customers can draw stuff and stuff like that. Or probably if it's a game, a lot of frames are changing. Only then I would recommend to go for WebAssembly. Otherwise, you're not going to enjoy the benefit. And for the rest of the part is, can you convert entire Python application to WebAssembly, for example, and execute on JS somehow? Technically, yes, you can convert entire Python application. So for example, I was using Rust. So there is a package for us to compile Rust code into WebAssembly. I'm sure there's a package for Python as well to convert that into WebAssembly, and then of course you can use it in JavaScript. Yeah.
Great. And I think last question for now is, can code in all the languages like COBOL or Fortran be compiled to WebAssembly, reuse validated legacy business code?
I'm not sure. I didn't see the compiler for COBOL or Fortran yet, but I know for sure about C. If you have a C code, then it can be compiled to WebAssembly. But for COBOL and Fortran, I'm not sure if there is a compiler available to convert that into WebAssembly.
Okay. One more question come up. So how exactly would I enforce streaming API to be used? Which model should I enable?
So, okay. You don't, it's up to you. It's up to your implementation. So let me show my code again. And
Just a second. Yeah. Yes, of course.
So let's say in my case, in my implementation, if I go back and see the package is generated. So again, this is the auto-generated package by Rust, and as you can see, it is generating one WebAssembly file and one JS file. So this JS file is sort of loading the generated WebAssembly file. So from my index.html, I'm not loading WebAssembly directly. I'm loading this JS file, and this JS file is actually doing all the heavy lifting. And if you go inside it, and if I just look for, yeah, so it is, you see here, it is checking if the instantiated streaming is available. then it's gonna load. So I have this load function. Again, all of this code is auto-generated. I didn't write it. Rust is doing it for me. So it is already checking. And I'm sure for the other languages, the compiler, they must be doing it. So you don't have to worry about it. So it is already checking if the streaming is available, then you use the streaming, because in older versions of browser, it's not available. So else it's gonna just probably throw an error, failed because your server does not serve WASM with blah, blah, blah. So yeah, this is the example of how you can load your WebAssembly using the web streaming. And again, you don't have to worry about it. Rust, if you're using Rust, if you're using this package called, wait a second. If you are using this package, if you're using this package, it is going to do it for you. You have to only worry about what you're going to put in your Rust code, what functions you're going to put in your Rust code. And then this package, wasm bind gen, it's going to, when you run this command, it's going to generate the JS file, also WebAssembly file, and load, and that JS file is going to load your WebAssembly file for you. I hope that answers the questions.
Looks like you're getting a lot of questions. It means the presentation was really good, because it's a result of presentation. And for now, we have such question like, what would be the use case of using WebAssembly of Node.js since there is no UI?
What would be the use case? That's a good question. Again, it depends on the performance. If you are not satisfied with your current Node.js performance, let's say, whatever the application is, because it's not just about the browser. As you can see in my presentation, it's not just about how it is running after it gets rendered. It's also about the compiling. It's also about the first phase, this parser and this thing, and then AST tree. This is all going to skip. So if you're not satisfied with your current Node.js performance, I would recommend you to try with WebAssembly. Don't get onboarded with full-fledged migration straight away. Just play around with like a one module and then benchmark the performance. And if you see the significant improvement, then only move towards it. And first of all, you have to find out what functions are the bottleneck. If you are having performance issue, the first step should be to identify your bottlenecks, like which function is taking most of the time, and then try to convert that function to WebAssembly. I will not recommend to straight away migrate the whole application to WebAssembly. Just try one function at a time and see how much performance gain it is adding.
And you can't believe that we got one more question. So I think you have time for this. Is version code generally faster during execution or only during loading, as was shown on Figma result chat?
So in the case of Figma, it was actually both. Like I have put both graph, like load time and download size. So load time means when it's getting loaded in the browser. So that is also improved. And because it's obvious that the parser step is not required anymore. Turbofan is doing ahead of time compilation while it's getting downloaded. So no need of coming back and compiling it again. So load time is improved. Number two, download size is reduced. So of course, the network loading must be faster. When you're downloading the file, it's going to be faster because it's smaller. So it's actually both.
Great. I think it was last question for today. And I really want to say a huge thank you for this awesome presentation and answering for all these questions that we got from audience. Seems we're really listening to you. It's a good sign. Thank you so much. I really hope to see you at our next event that we will have in December. So it's some kind of announcement. Yes, December 6th and 7th, we will have Node.js Global Summit 22.2. Yes, I'm really glad to see all of you there. And you like a speaker as well.
Thank you so much. Thank you so much for inviting me. And thank you so much, everyone, for joining. I hope you guys, I don't know, I hope you guys have learned something. Again, I'm not a pro in this topic. I'm also learning it. So I just shared whatever I know. I hope it added some value for you. Thank you so much.
Thank you for being with us. Also, I want to remind you that it was on the first day of Global Summit for Node.js. Tomorrow we have second day for senior developers. So if you want to find out more, please check out our agenda and visit and listen to our topics from senior track. Thank you for attention. Thank you for being with us and hope to see you at our next events. See you.